Information system auditing, otherwise called IS auditing, really deals with two primary concepts. The first being investigation, where as IS auditors we investigate the security controls that protect assets, and then the second portion is to inform stakeholders on the state of those security controls in terms of their efficacy. So the IS auditing process then begins with gathering evidence based on what we've determined needs to be audited. After we determine whether or not the controls are effective, we then report on weak controls and related remediations. IS audit planning begins with looking at the audit subject. This would include things such as the location where the audit will take place and any related business processes that will be audited. Then we have to look at the audit objective, whether it's something specific like looking at determining whether a payment processing system is secure, or whether sensitive documents are being retained in accordance with things like regulations. They're being stored securely and for the right amount of time. We then have to consider the audit scope when we are planning an audit, which really details what exactly will be included in the audit. Then we go through our audit pre-planning, where we either conduct a risk assessment against assets that have value to the organization and the threats that go along with those assets, or we can use a risk assessment if it was done recently and applies to the audit scope. We have to think about compliance with laws and regulations and the time frame related to conducting the audit. Finally, we need to create an audit program. This really outlines the audit procedure that will be followed when the audit is conducted. Audit procedures begin with obtaining documentation, so organizational security policies, departmental policies, process procedures, and data workflows. It's crucial that an IS auditor has a strong understanding of the purpose of the business, and specifically with the audit scope, knowing exactly how business processes are used and how data flows within that business process. Then there is regulatory compliance, which might include things like the retention of certain types of documents or logs or transactions for a specific period of time. And then we have to consider the audit tools that will be used during the audit, such as web application fuzzers, which are used to test what happens when we feed a web app with a lot of random data to make sure it doesn't disclose sensitive information, to make sure it doesn't crash. We might also look at tools like host vulnerability scanners, which are used to identify weaknesses. Isaka stands for Information Systems Audit and Control Association. It's an international association where the overarching goal is proper IT governance. Now, specifically for certified information system auditors, or CISA, this is going to be important. The CISA certification provides an assurance to clients that business processes and supporting IT solutions are secure through proper auditing processes. The Isaka Code of Conduct includes 7 items, the first of which is to support the implementation of and encourage compliance with appropriate standards, procedures, and controls for information systems. This comes straight from the Isaka site. The next item in the Isaka Code of Conduct is to perform duties with respect to CISA auditors with objectivity, due diligence, and professional care in accordance with professional standards and best practices. The third item in the Code of Conduct is to serve in the interest of stakeholders in a lawful and honest manner while maintaining high standards of conduct and character and not engage in acts discreditable to the profession. Because if it's deemed that this is occurring, then you could lose your CISA certification from Isaka. The next item in the Code of Conduct is to maintain the privacy and confidentiality of information that you might learn about through the course of the IS audit. And 9 times out of 10, you will be exposed to sensitive information, whether it's data or unique business processes that are unique to that specific organization. The next item in the Code of Conduct is to maintain competency. This means that as IS auditors, we need to make sure that we are always keeping up to date with the latest auditing standards. Also, making sure that we also keep up to date with the latest threats related to IT security. The sixth Code of Conduct item is to inform appropriate parties of the results of the work performed. That would be the clients, because a very big part of IS auditing is to inform stakeholders of our audit findings. Finally, the last part of the Isaka Code of Conduct is to support the professional education of stakeholders, to make sure that they understand how the underlying technology supports their information systems and any weaknesses that need to be addressed. An effective IS audit means following standard guidelines. And here we're going to take a look at Isaka Auditing Standards. First thing to bear in mind is the Information Technology Assurance Framework, or ITAF. This is a set of standards that is published by Isaka. It's a risk-based approach to taking a look at business processes and data and the resulting underlying technology that supports those items to make sure that security controls are in place to protect assets. It also means that we have to adhere to the Isaka Code of Conduct, the 7 items that all Isaka certified individuals must adhere to, such as maintaining client confidentiality, because during the course of an IS audit, it's inevitable that you will be exposed to sensitive information. There are also guidelines for IS auditing that result in audit efficiency, so that the audit takes place in a timely manner, and that the audit report results are effective in conveying information to the client about the state of their security controls for their prioritized assets. There are numerous Isaka auditing standards. Here we have a couple of them, such as Standard 1001, the Audit Charter, which defines things like the audit purpose, the audit scope, and access to resources in conducting the audit. Then we've got things like Standard 1005 listed here at the bottom, due professional care, where audit activity is executed with integrity, care, and communication. This means as IS auditors, we need to make sure that we are documenting our steps along the way while we follow auditing standards. Other standards would include, for example, 1007 assertions, where we verify internal as well as third-party controls, security controls, validity. So if we've got a security control that's already in place, and perhaps a previous audit has determined that it was effective, it may have been at that time. But when we conduct the most current audit, we have to revisit that, because over time, what once might have been effective as a security control may no longer be effective. Also, we've got Auditing Standard 1201, which deals with engagement planning. The engagement in this case being the actual audit that's being performed, where we look at the audit objective scope and the timeline. Other standards would include 1204, materiality, where weak or absent security controls could result in a failure to meet control objectives. A control objective is a standard about what the control should do, such as to protect data at rest, where the control is the actual solution that actually results in that protection. Also, we've got a standard such as 1205 for evidence, where any conclusions that we draw from the audit need to be objective, and they need to be based not on opinion, but strictly on the evidence gathered. And remember, we will be documenting tools and techniques that resulted in that evidence during the course of the IS audit. Other Isaka auditing standards would include 1206, using the work of other experts. So if we don't have the correct skill set within our audit team, we need to either get someone as part of the team that has the correct skills to assess security controls, or we can outsource a part of the work. Again, everything needs to be documented properly. Then 1401, reporting, to make sure that we communicate our audit findings and educate the stakeholders, that would be the client. And then 1402, the standard that deals with follow-up activities so that we can revisit any audit recommendations after an agreed upon period of time to ensure that any controls that need to be changed or put in place have been done so effectively. A crucial aspect of an IS audit is to make sure that we have good information on which to base the audit. And so organizational documentation is very important. We're talking about audit information gathering. We need to make sure that any documentation that we use in our audit falls within the audit scope. It's got to be relevant to what is being audited. We also need to make sure that any documentation that we base any findings on is up to date. Now, there are many different types of documents that we have to consider. Let's start by talking about organizational charts, which really outline the employee hierarchy within the organization. We can also see job role relationships, which can allow us to identify things like overlapping roles, so that reduces efficiency and may not be needed, and also roles that might result in a conflict of interest, which might necessitate segregation of duties, for instance, within a certain process. But then we have to look at the business processes themselves within the organization and any related documentation, such as how those processes are used to achieve organizational objectives. We have to make sure that processes are efficient. We might even gather that type of information from employee onboarding materials like instruction manuals. And we have to take a look at the underlying supporting technology related to that business process. Bear in mind that any existing security controls that may at one time have been effective may no longer be effective. So part of a thorough IS audit is, of course, to revisit all security controls that fall within the audit scope. Other types of documentation that you would be interested in as an IS auditor would be things like network diagrams. Now, that we'd have to make sure would fall within the appropriate audit scope. For instance, if we're only interested in auditing a small subset of the network, then we only need to see that part of the network diagram. However, depending on dependencies, we might have to look on a larger scale at a wide area network diagram to determine, for instance, where the resultant data flow ends. And so we have to be careful and take a look at the scope of our audit, but then look beyond it at dependencies. We might have to look at network diagrams to determine details about hosts and their addressing information on the network, as well as their placement within the network. Infrastructure devices like routers, switches, wireless access points, not only determining that they are placed correctly, but whether in fact they should be there in the first place. Then security control placements, things like VPN devices, firewall appliances, to make sure that they are in a location that makes sense from a security perspective. Then we have to look at the common network traffic flows, and that's where the whole network diagram kicks in, where we mentioned we might have to see a broader network diagram to actually understand the information flow. A risk assessment is a prioritized list of assets and related threats. Now, we might have existing security controls that we have to revisit and make changes to due to new threats that didn't exist previously. Other documentation might include product and service documentation for the specific business, the types of services they offer and the details related to that, or the products that they might sell or even manufacture. So in other words, know the business purpose of the client that you are performing the IS audit for. This is absolutely essential. You need to understand how products and services are made, available, how they're sold, and how they're supported after they are sold to the customer. We might even look to past audit reports. Were there any recommendations that were made in the past that have or perhaps have not been acted upon? We can also take a look at business and technological changes that affect the organization that have changed since the last audit occurred. That might include something, for example, like ransomware, which has become more and more prevalent, and so it's part of what we have to consider when it comes to the protection of data and making sure it's available. We then need to consider other organizational documentation in the form of organizational security policies, of which there could be many, like a VPN policy, an email acceptable use policy, the usage of social media within the organization and what is allowed and what is not, how mobile devices are to be used, how documents are shared within the organization, both physical and electronic documents, and how they are destroyed. And finally, policies such as a clean desk policy, which might prevent sensitive documentation from physically residing in paper form on desks when people aren't around. So there's a lot of documentation that can feed into the information gathering phase of conducting an IS audit. While we must adhere to IS auditing standards, not every audit will be exactly the same, and that's because the client or the organization being audited will always be a little bit different. So we always have to consider stakeholder needs. The first order of business is to make sure that you know your client. If you don't truly understand what type of business the client is in, then you're going to have a difficult time understanding business objectives that are met through business processes and the underlying technology that supports those processes. So we should also know things like the history of our client, the products and services that they offer and support, any processes that result in making those products and services available and generating revenue for things like shareholders, any outsourcing dependencies. Always consider the weakest link in the chain. So if we've got a client that we're performing an IS audit for that outsources either some services or the creation of a product, then we have to consider all of the security controls in that external client, because there is an outsourcing dependency in the supply chain that we must consider. We should also look to previous audit reports to see what the state of the organization was and its security controls at that point in time, with an understanding that things change. We might also look to using questionnaires, such as properly designed questionnaires that are distributed either physically or electronically to the appropriate parties within the organization so we can learn more about stakeholder needs. Stakeholder needs are based on assets that have value to the organization, whether that is personnel or business processes, data, which is always considered an asset in this day and age, and the threats to those items. Compliance is also a big part of stakeholder needs. Following standards such as Pci Dss, which is used to determine how secure an environment is where it deals with cardholder information, such as credit card information for payment. Then we have to think about regulations that might apply to a specific organization for the industry it's in and the legal jurisdiction that affects it. There might also be contractual obligations that we have to consider as part of our IS audit that must be met. For example, we might have a smaller organization that has a defense contract, and so there are more stringent security controls that might apply than if that client did not have that Department of Defense contract. So we have to consider that as well. And then, of course, laws, again, based on the jurisdiction that applies to the client. Stakeholder needs also affect the audit scope. So whether we're looking at auditing a specific department or a specific business process or one part of a network or an entire large-scale network to make sure, for example, it supports the Pci Dss Cardholder processing standards, we might even look to a specific host. Or we might be looking at a scope of a particular database to make sure that sensitive data that gets read from and written to that database is properly secured. Now, all of this will serve to allow us to build an engagement letter with the client so that we can actually start planning further and then, of course, ultimately execute the IS audit and report on our findings. Planning and performing an IS audit goes much deeper than understanding the technology and the security that goes along with that technology. We also have to be able to apply the auditing process to the organization because in the end, the technology really is only there to support business processes. So we need to understand the underlying technology that supports business processes, which ultimately serves business objectives. So as IS auditors then, when it comes to network diagrams and conducting an IS audit, we need to be able to identify any risks with the use of that technology on the network. Then we need to be able to identify any weaknesses that must be addressed. And then we have to determine even further details like how specific security controls will be tested, such as testing a network firewall through a penetration test. So in the end, we need to make sure that the configuration for the network, if that's part of the scope of the audit, complies with security requirements. Now, the security requirements will stem from things like organizational security policies, which in turn might be influenced by laws, regulations, or even contracts that the client might have with organizations where further security requirements are stipulated. Pictured on the screen on the left, we have an on-premises network that includes servers that would include holding things like databases. We've got intranet websites. We've got mobile devices and wireless networks, each of which is common in today's use of technology to serve business needs. However, it's not without risk. So, for example, at the server and database level, we have a risk of things like server hardware or software failure. So if any of that fails, we lose availability to that data in the databases. Then we've got intranet websites, which could be susceptible to common web application attacks like SQL injection. Then we've got malware that could be within an app that users are downloading from an app store. It's been known to happen. Just because an app is in a mobile device app store doesn't mean it's not without its risk. Then we've got on the wireless network side of things, MAC spoofing, which can be used by malicious users to gain access to a wireless network that uses MAC address filtering, where the MAC address is a unique hardware address, which is different for every Wi-Fi card. There's also tools out there that allow malicious users to crack WPA and WPA2 security that we might use to try to secure our wireless networks. And so we have to consider all of these technical details because in the end, this technology only exists to serve the business. So we have to apply our auditing standards against this technology. Then we've got another issue these days in the form of a public cloud provider where organizations might, for example, have a public website hosted in the public cloud, and they might have virtual machines deployed in the public cloud to support the website or to support a testing environment if they're building new software. And then we might have the same types of issues in terms of risks that could apply in the cloud as they would on premises, like SQL injection attacks. Although the scope here for a public website would be much broader because we've got a site that's exposed to the internet. And if a public website is compromised, that might be a bigger deal than if an intranet website, for example, that only hosts employee documentation might experience. So not everything is equal. When we talk about exploiting a website through SQL injection or any other attack, always look at the context and what type of data is on that. Of course, we always have to think about the fact that if we've got a failure at the hardware level, how valuable really is the hardware compared to the data that it stores or processes? In the virtual machine side of things, we have to consider, again, server hardware or software failure. Now, what's different in the public cloud is responsibility, because in the public cloud, as a cloud customer, we are not responsible for the hardware. However, we would be responsible for the deployment and management of any virtual machines that we deploy on the cloud provider. Using technology to partake in business these days is pretty much inevitable. And with the use of that technology, risk is introduced. So security controls must be the focus of our IS audit. What has been put in place to protect assets by reducing risk? And so a big part of security controls is risk mitigation and then mapping security controls to control objectives. So a control objective, for example, might be to protect sensitive data at rest, so stored data, whereas the control might be to use a specific encryption solution to carry out that control objective. There are many different categories of security controls. Preventative controls are designed, as the word implies, to prevent negative incidents from occurring, such as having thorough employee background checks before hiring new personnel, user training and awareness For instance, to make sure people are aware of the latest social engineering and malware threats so they don't click on links in suspicious email messages. Performing data backups is preventative because we have data availability if something negative happens, like files are deleted or encrypted with ransomware or become corrupt. We can also use firewall access control lists, ACLs, which normally run on routers or even specialized firewall appliances, which can prevent certain types of network traffic from entering the network or leaving the network. Job rotation is at the personnel level. It allows us to place people in different job roles, and with this knowledge, personnel might not be interested in partaking in illegal or fraudulent activities if they know that somebody else might occupy that job role. Door locks are also preventative to prevent someone from breaking into a building or perhaps even a room. Security guards can be considered preventative because they might have the ability to prevent a crime from happening or a negative incident from occurring. Detective controls, like the name implies, can detect that something has occurred, either through log file review or through the use of an intrusion detection system, an IDS, which can detect suspicious activity and report on it. Alarm systems are detective. They can detect, for instance, if a window has been opened after hours. Job rotation is not only preventative, but also listed here as detective, because as a new person takes upon a new job role, they might detect irregularities from the previous occupant of that role. Security guards can be detective as well. They might detect that something has occurred. Corrective or recovery controls allow us to restore a system or data back to a functional state. That might include the act of restoring data from backup, or re-imaging a failed server, or patching a vulnerable host. Deterrent security controls, as the name implies, will deter bad behavior from the beginning, such as having perimeter fencing around a sensitive facility, or having lighting inside and outside the facility, including in parkades and parking lots. Having signage that might warn of video surveillance systems. Security guards can also be deterrent. The mere fact or the presence of the security guard can prevent negative activity from occurring. Compensating controls are alternative controls or a second choice to a primary control that, for one reason or another, we cannot implement. It could be due to the fact that the primary control is too expensive, so it's cost prohibitive. Or it could be due to the fact that implementing and managing that primary control is too complex. And so examples of compensating controls might include, at the personnel level, segregation of duties to prevent a single person from having control of a business process from beginning to end, and also perhaps using network isolation, on which we might place legacy devices on that network segment that might not support modern requirements like password complexity. But by placing those legacy devices on a network, we might be able to force connectivity to that network through an authentication server that does support password complexity. Now, when it comes to your IS audit and looking at security controls, make sure you approach existing controls with a healthy dose of professional skepticism, because existing controls might be out of your scope of responsibility. They might actually not be effective. They might not have been effective when they were implemented, and over time, they might have become less effective at protecting assets. So we need to be aware of this as we conduct our IS audit, which really focuses on looking at controls. A structured approach to IS auditing means understanding control objectives and controls. Control objectives and controls are important because we need to think about mapping specific audit objectives to how controls get tested. Remember, controls are put in place to protect assets, to reduce risk. And we're really talking about an IS audit through a risk-based approach. So we can have multiple security controls that might be used to satisfy a single control objective. So imagine that the control objective is to protect cardholder data, so to remain compliant with Pci Dss. Well, we might achieve that through numerous means, such as by implementing network firewalls, having malware scanning in place, and also encrypting data at rest. So that's an example of 3 controls that map to a single control objective. Control objectives can be influenced by laws and regulations and also by contractual obligations related to security. The control objective exists to represent a desired state. What are we striving to do? For example, maybe the desired state is to make sure that data is always available, even in the event of some kind of a disaster like a fire, flood, or an act of terrorism or a malicious attack. Also, another desired state might be financial transaction integrity, to make sure that financial transactions and resultant financial documents can be trusted as being true. Another desired state might be data confidentiality. So we might need to make sure that encryption mechanisms are used to maintain the confidentiality of sensitive data. If the control objective is user awareness of latest social engineering threats, maybe our control would be to have monthly or quarterly lunch and learn sessions. Now, as an IS auditor, we have to look at these things and determine what is appropriate. And often, it's not just based on technology. If the control objective is user awareness of latest social engineering threats, maybe our control would be to have monthly or quarterly lunch and learn sessions. Now, as an IS auditor, we have to look at these things and determine what is appropriate. And often, it's not just based on technology. We might have a control objective of financial spreadsheet user accountability. The controls might be to have separate user accounts so we can track which user was doing what to the spreadsheets, and then to audit file system access to those files. We might have a control objective which requires encryption of personally identifiable information, PII, things like social security numbers, credit card numbers, addresses. And so the control might be to force Pi storage on Windows BitLocker disk volumes. So if we're using Windows machines, BitLocker ensures that the entire disk volume is encrypted. And so even if the machine is off and the disk is stolen, the data is still protected. We might have a control objective that says high importance emails need to be authentic. Well, how do we do that? Well, the control might be to implement email digital signatures, which give assurances that a message came from who it says it came from and that it's not been tampered with. We might also have a control objective that states we need accurate migration of data between dissimilar systems. That might even include migrating from on-premises into the public cloud. And so maybe a control is to make sure that we export data in an XML file format, which is a universal standard, which allows importing into other dissimilar systems. So it's important then when you conduct an IS audit to understand control objectives and the controls that will satisfy that objective. Part of planning your IS audit is resource planning. What tools and personnel and budgetary requirements must be in place to conduct the audit properly? So we have to consider whether we're talking about internal versus external audits. Internal audits are carried out by personnel that are part of the organization. Naturally, external audits use third parties. We then have to think about the team members, the tools that will be used, the budget. So let's start by talking about external audit teams. With external audit teams, because they're not part of the organization directly, then we're going to have meetings and correspondence between the client and the external audit team to get things moving along. Because the external audit team may not be familiar with the client organization. Now, there will be exceptions where they might be if they've conducted a previous audit. But again, things can change quickly. Companies might adopt new business lines. There might be mergers or acquisitions. And so either way, meetings are a big part of this. So there might be new internal control changes even that have changed since the last audit. And so external auditors might not be aware of this type of thing also. So external audit teams need to be informed about the audit objective and the scope of the audit. What should be covered? What should be audited? Planning the audit means looking at skill sets and tools. Do we need to outsource specialized skills that our immediate audit team might not have? And that might include something like auditing a storage area network or a SAN. So sometimes, depending on the nature of what we are auditing, we might need some very specialized expertise to carry out the audit correctly. And that's part of an auditing best practice, is to know when your team does not have the correct skill set and you need to go to a third party. We also have to consider any hardware or software tools that might be used to conduct an audit. Now remember, an IS audit does not have to always include technology. So maybe what we need to do is increase user awareness of social engineering threats, and that can be done through a lunch and learn mechanism, which isn't directly related to technology, at least not the solution, although the overall discussion piece is related to technology. Then we have to think about budgeting. There's a limited amount of time and resources that we can allocate to a given IS audit for it to remain relevant. So we have to think about external auditors that would have to travel and have related expenses. That has to be paid for somehow. External audit service fees, of course, for the work to be conducted in the first place. If we're dealing with an internal audit team, while we may not have a direct expense associated with paying a third party, we still have time allocation, training, and conferences. In other words, that internal audit team is putting their time in conducting an audit when they might be doing something else that might generate revenue for the organization. So it's still a budgeting concern. Then, after the audit is complete, we look at the audit report, we take a look at any recommended remediations and determine which ones should be implemented. So there's a cost associated with implementing those remediations. That's yet another part of audit resource planning. The cost of implementing these types of remediations might include technology solutions like requiring more storage for logs and tracking as a result of an audit recommendation, or maybe the creation of scripts to test security controls. That would be another cost for the time required by personnel to create and test these scripts thoroughly. In a way, part of planning an IS audit is similar to project management in the sense of managing resources and also, as we're going to talk about, managing time. So it's important to think about audit scheduling. It's part of the initial audit engagement letter, or sometimes it's called the statement of work, or SOW, that would be between the client being audited and the auditing team, especially if they're external auditors. We also would have to think about scheduling as it relates to invoicing. Now, that would certainly be true if you're talking about having external auditors outside of the organization performing the audit. Now, you might also have to deal with scheduling even sometimes with internal audit teams in a larger organization where departmental chargeback is being employed. Audit scheduling deals with things like when the audit will begin. There should also be scheduled periodic progress updates as the audit is underway. There should also be periodic audit status meetings. So rather than just communicating, for example, via email, there should be face-to-face or video conference meetings so that the client knows the current state of the audit. Then there should be a schedule related to when there will be final deliverables or reports made available to the client based on evidence from the audit findings. Finally, there should be scheduled an audit closing meeting to close out the audit after the reports have been made available to the client and the findings have been discussed with the client to make sure that there is an understanding of any remediations that should be put in place. Scheduling should also be put in place for scheduling the remediation follow-up meeting. Now, the timing from when the audit completes and there's an audit close meeting will vary from one audit to another, of course. But we don't want to wait too long to make sure that remediations or compensating controls of some type have been put in place. So we take a look at whether those were put in place, and in some cases, due to the complexity of the control, certainly if it's a technological type of security control, the client might need direction with how to actually apply that control so it meets control objectives. And in some cases, it might also require outsourcing that expertise. But all of these items have to be considered in a timelined approach. During the course of executing your IS audit, you might at some point discover incidents that are urgent in nature that need to be dealt with immediately. So as an auditor, you have a responsibility to communicate the finding to the client right away. Now, these communication mechanisms would have been established initially during audit planning. The other thing to think about is whether or not the incident is technical in nature or whether it's more user-related. For example, in the case of fraud or collusion between multiple employees. So sometimes these urgent incidents are intentional, such as collusion with internal employees or with a malware infection, but other times it might be unintentional. With urgent incidents, we have to see how that maps to the Isaka Auditing Standard 1204 materiality. This specific auditing standard focuses just on this, urgent incident discovery, where we've got weak or absent controls that result in a failure to meet control objectives, such as to ensure that we don't have collusion between employees that control the business process from beginning to end. Then in some cases, you might even uncover incidents of fraud. Now this could be internal or it could be external for people outside of the company that perpetrated this type of crime. Now it could be the result of ineffective internal controls, such as allowing a single employee to control multiple processes, such as ordering equipment and also dealing with the payables on that order of equipment once invoices are received. So there needs to be preventative controls to ensure that ideally this doesn't happen, but it could be a failure of a preventative control that results in an urgent incident discovery that is material, that can actually affect the outcome in some cases of the audit itself. Sometimes we'll also have detective controls that can kick in if preventative controls fail. An example of this at the technical level, let's say, might be an intrusion prevention system that doesn't detect suspicious activity that we then uncover later by reviewing log files. Other times, urgent incidents might have nothing to do specifically with technology. Rather, it might be something to deal with fraud. For example, Repo 105, which we might also term as Fraud 101 in joking terms. This is a term that was coined by the Lehman Brothers. It's an accounting fraudulent type of term. So it really deals with illegal financial statement manipulation where the perpetrators will record short-term loans as sales values to inflate figures. Now this is definitely a form of fraud, and this is one of the things that could be uncovered during the course of an IS audit. So why do people do this? Why would people partake in things like fraud? Well, naturally, greed plays a part in it, but often people think they can get away with it for the long term. Also, sometimes there are external pressure points such as shareholder and market expectations for things like quarterly financial reportings that will drive people to falsify financial documents in order to make sure they meet or exceed shareholder and market expectations. Either way, often these things can be uncovered during an IS audit. The key, though, is to report this type of serious incident that might get uncovered immediately to the appropriate stakeholders. One of the final phases of IS auditing is audit reporting, where there are two main purposes. The first of which is to educate stakeholders as to the position of security controls, at least for the audit scope, things that were looked at. The next is to remediate any weaknesses to protect assets. Remember, we're talking about a risk-based approach here to our IS audit. So with audit reporting, we could be looking at having a single report, or on a larger scale, depending on the scope and the audit objective, it could be numerous reports that are related, that are generated, even created by different audit team members. Some cases might also require certified signatures for some or all portions of the audit, such as those perhaps from chartered accountants, if that's the type of audit that we are looking at with processes for IS security. Always remember that when it comes to audit reporting, we need to be, as auditors, 100% objective. And what that means is, based on our findings, any conclusions that we draw will be based solely on evidence, nothing more, no opinions, not what we think should happen in terms of reporting the findings. So we need to clearly state the findings, conclusions that were drawn, and then any recommendations based on the findings and conclusions. We then should also clearly state any information sources that were used to come up with the findings and conclusions, such as running a network vulnerability scan or sending out a questionnaire to employees to learn more about who is responsible for which parts of a specific business process. Then we have to also provide fieldwork documentation. Now, this is crucial because it outlines the tools that were used in resulting in our findings and conclusions, as well as techniques that were used. So with audit reporting, we have to consider the recipients. This would be part of the original statement of work in terms of part of the deliverables, the timing on when reports are sent and to which parties. We should also determine whether an audit report has the ability to be copied, printed, or forwarded. Depending on the solution being used, this could be limited. Then we have to think about audit report file integrity to prevent tampering with the results. There have been documented cases that have made public headlines in the past, certainly where the results of an audit have been tampered with to look more favorable to the organization that was audited. And again, why would that happen? Well, greed. There's also meeting shareholder expectations and meeting quarterly projections for revenue and so on. The other part of audit reporting could involve documented management responses. So if we've made recommendations to implement certain types of remediations, we might require a formal response from management of the organization or the department that was audited that stipulates a timeline related to which specific controls will be implemented as per the audit report recommendations. Generally speaking, the overall purpose of an IS audit is to identify weaknesses in security controls and then to make recommendations to do something about it, to reduce those vulnerabilities. So the first thing to do is to perform the audit and then to report findings and conclusions based on evidence only, so this is objective, and then to make recommendations on how to improve the organization's security posture as related to the scope of what was covered by the audit. Finally, the auditing team needs to follow up, because if recommendations have been made, a follow-up needs to ensue to make sure that those recommendations have been put in place. So the Isaka Standard 2402, the auditing standard, is called follow-up activities. It's an important part of the IS audit process. And it really focuses on timely actions taken by management. Now, the management in this context is your client that you've performed the IS audit for. Timely actions taken by them based on your audit report recommendations. So timing for this is specified originally in the audit statement of work. So we have the scheduling for the commencement of the audit, periodic status reports and meetings, and of course the final deliverables and the deadline dates for that for the audit, and then of course a scheduled follow-up. Now the timing will vary, but again, that's what's stipulated in the statement of work. Sometimes what some organizations will do is conduct internal audits only to verify that the remediations have been put in place and that they're effective. So we might have a third-party external audit team perform a specific audit, and then based on their findings and recommendations, an internal audit team will then take over from there, where the scope will be just on the recommendations made by the initial audit team. So controls that fail testing then need to be dealt with. They need to be added to a near future testing list to be dealt with. Otherwise, it could expose the company to unacceptable risk. And in some cases, If the desired control that addresses a control objective is too complex or too expensive or somehow just not feasible, then we look to compensating controls that will still protect that asset and reduce risk. This exercise is all about the IS auditing process and controls. The first thing you will do is explain the purpose of information system or IS auditing. Following that, you'll provide an example for each of the following control types. You'll provide an example of a deterrent control, a preventative control, and also a corrective control. Finally, you'll provide an example of a control objective and a related control. Now's a good time to pause the video to think about each of these items carefully and then come back to see the solution. The purpose of IS auditing is to check that existing controls adequately protect assets. It identifies the current security posture of the organization to stakeholders within the scope of what was covered by the audit, of course. For control type examples, an example of a deterrent control would be a video surveillance camera. Even if it's a dummy one that doesn't actually work, it can deter malicious actors from perpetrating negative activity or crimes. Even computer sign-on banners that pop up when you sign on to a system could serve as a deterrent because there might be a warning that the system is only to be used for business purposes only, or else. Preventative controls come in the form of things like a firewall access control list, or ACL, that can prevent known bad traffic from entering a host or leaving a host or entering or leaving a network. Employee background checks can be preventative because if we do a thorough background check on a prospective hire and determine that they have an extensive criminal past, we could not continue with the hiring process and prevent potential fraud down the road. Corrective controls would include things like applying patches. There might be a deficiency in an app or in an operating system or even in firmware, and when we apply a patch, it corrects that issue. We could also use data backups to recover data if, for example, data becomes corrupted. So the corrective action here is recovering from the backup to get data back to a point where it's usable. A control objective is really a statement about something that must be done, but not how it is to be done. So as an example, maybe we need to make sure that an important database is available so people can still access the contents of the database, even in the event of a natural disaster like a flood or a fire or perhaps even a power outage. So the control that might address that control objective in this particular example might be to replicate that database to a different geographical region where you might have a data center or another branch office, or you might even be doing this in the public cloud by replicating to another geographical region where the cloud provider has a presence. IT governance is all about making sure that our IT solutions align with our business objectives. It also means that there needs to be some transparency to ensure that those technological solutions that drive the business processes can be trusted. With IT governance, we're talking about having a formal framework that aligns the technology with the business goals. And the responsibility in the end for the overall IT governance falls upon not the IT technicians, but rather to the board of directors and executive management within the organization. So why is IT governance so important? Well, first of all, to maintain data privacy. Also, to ensure transparent financial accountability, to make sure, for example, that financial documents are accurate and haven't been doctored to please shareholders, for example. We want to make sure that IT governance makes sure that systems are secure from beginning to end so that we don't have any fraud that might result due to the fact that there are shareholder and market pressures at play. There are plenty of different IT governance frameworks, and each organization will choose the one or ones that suit its needs the best. Now, these are generic frameworks that need to be tweaked for the specific organization, such as Itil. Itil is a service management strategy type of framework that is designed to result in the efficient delivery of IT services. Cobit is designed so that we can properly assess our control objectives. A control objective, for example, might state that we need to ensure data that's transmitted over a network is protected, whereas the control or controls that we put in place actually make that happen. So Cobit is a structured framework that allows us to look at risk and then look at the controls that are put in place to make sure that they're effective. Then we've got the ISO/IEC series of documents, such as 38500, the international standard for corporate governance of IT. Again, this is a set of practices that is designed to ensure that we have transparency, accountability, and to make sure that our IT solutions aren't just there for the sake of having the latest IT solutions and gadgets, but rather to support business processes. Cobit is an IT governance framework. It stands for Control Objectives for Information and Related Technology, where a control objective, for instance, might relate to ensuring that transmitted data over the network is protected. And dealing with the how. How do we actually do that? What type of encryption and devices will we use? That's more dealing with Itil. Now, Itil is more of a structured framework that's focused on the IT side of things, whereas Cobit is focused on the business perspective. So part of Cobit then is risk management, so that we can end up deriving as much value as possible from IT investments. And this is done through the constant improvement of our IT and business processes, which ends up reducing cost and waste. Cobit also deals with the constant improvement of IT system and data quality. And this means we end up with more informed decision making because we have more accurate data. So Cobit then can be applied to cloud computing within an organization or how it deals with enterprise mobile device security. With Cobit, we identify assets and risks. Next, we then need to identify stakeholder needs. Sometimes that will deal with regulatory compliance or taking a look at the details within a service level agreement to make sure that they align with business requirements. Stakeholder needs might also deal with things like availability. I need to make sure that a database is available as often as possible because the risk of it being unavailable is not acceptable. After identifying the business goals, because that's really what we're talking about the technology that drives the business processes that in the end together support the overall business goals, we can then identify any changes to how IT is dealt with currently, things that need to be addressed. Maybe not necessarily exactly how they should be addressed, but the fact that things need to be addressed. So imagine, for example, that what we need to do is make sure that a specific crucial database is made available. And maybe currently it's not. So if we have a failure of the database server, that's it. The database cannot be reached. And maybe the downtime normally associated with that is 2 hours. So what we might do then is make a recommendation for an IT change so that we make sure that the database is available. So the control objective would be to ensure that the database is available a specific amount of the time, maybe 99.99% of the time. And then we can focus using other frameworks like Itil on exactly how that is to be done, which controls would be used. And that's why you'll see a number of these frameworks often used together. They complement one another. Examples of that being Cobit and Itil. So you could use specific tools in order to map out, plan, and make recommendations for change in compliance with Cobit practices. You could even use something as simple as an Excel spreadsheet to record this type of information. Cobit 5 is the current version of the Cobit IT governance framework, and it's got a number of lifecycle phases, starting with drivers. So what is driving the need for changes? Usually it's because there's some kind of deficiencies. In our example, the database going down and being unavailable for 2 hours might be unacceptable. Then we need to take a look at our current state. Where are we right now with, in our example, making sure that the database is secure and highly available versus where do we want to be? What's our future state that we strive to be at? And then we can look at the difference between the two to start to determine what exactly are we going to do to make that happen? What are the plans and activities? Then we can start getting into details to start planning the execution of how we are going to get to that future state. And as with all of these IT governance frameworks, part of what needs to happen is monitoring so that we have improvement, whether we have periodic reassessment of any changes that have been made or whether it's a constant monitoring solution. Itil stands for Information Technology Infrastructure Library. It's an IT governance framework. So it's a collection of best practices for IT service management. It's all about doing this efficiently. You need to ask yourself, when you think about Itil and how it can make things more efficient, you must wonder, how do our IT solutions currently in place provide the best possible value in achieving business goals? So it's all about improving the quality and the reliability of our IT services. Because at the end of the day, having effective IT practices can have a positive impact on the organization's bottom line. The Itil lifecycle begins with Phase 1, Service Strategy. Service Strategy deals with financial and demand management, business relationship management, and even service automation, where service automation can reduce human error because we've got a repeatable, proven way of offering some kind of an IT solution, and it also can be even more efficient and allow us to get that specific process completed in a more timely fashion. Phase 2, Service Design, deals with service catalog management, ensuring that the appropriate IT services are made available to the end users that need them, making sure that we've got the appropriate capacity and availability requirements met. So, for example, making sure there's enough storage available to be provisioned as needed by end users or even specific departments that might request it from the IT team. And making sure things like crucial databases are made available so that a single server outage doesn't make that database unavailable. So it's all about really IT service continuity. We want to make things efficient and available or reliable. The third phase of the Itil lifecycle is service transition, which deals with things like proper change management procedures and going through an approval process and having a backup plan in case the change we introduce causes a negative impact. It also deals with things like release and deployment schedules for things like making custom code changes, and then making sure that any changes are tested thoroughly to ensure that they don't introduce new problems. In the Itil lifecycle phase 4, service operation, we're talking about ensuring that the IT services are monitored for operational health over the long term. It also deals with having an efficient incident management environment so that incident response is very effective and quick, and people in the incident response plan team know what their roles are. Service operation also means that we want to make sure that request fulfillment happens efficiently. So if a user, for example, requests something from the IT department, which could include help desk service tickets, that they are dealt with in a timely manner. Finally, in Phase 5 of the Itil lifecycle, we have continual service improvement. And that's a big milestone part of this, is to make sure that we are always striving to make things better, more efficient. So we need to be able to measure our service and service delivery to make sure that it meets business goals and that it's done cost effectively and quickly. So this continual assessment allows us to do that. It allows for continual improvement. So what's the relationship then between Itil and IS auditing? Well, the outcomes for both really lead to increased profitability. So it increases profitability for the organization because things are more efficient and there's less waste of time and resources. Increased service levels, which results in customer satisfaction, where the customer could even be within the same organization. We're talking about this from the IT technician or the IT service desk perspective. It also means that we can have more adherence to laws, regulations, and contractual obligations. ISO/IEC standards are just that. They are sets of standards that organizations can apply to their environments to improve efficiency or the quality of security within the organization. ISO stands for International Organization for Standardization, where IEC stands for International Electrotechnical Commission. So the ISO/IEC standards are related to IS planning, implementation, maintenance, and continual improvement. Specifically, if we look at the ISO/IEC 27000 family of standards, we would focus on the security of digital information assets. And it means that certification in the set of standards provides assurances in the supply chain. That means that if we have other organizations we're doing business with, maybe we've got a contract with another organization, if we are ISO compliant with a specific set of standards, then the other organization can remain confident that we have met certain specific thresholds, or there are certain policies in place, proper policies for IT governance to secure digital assets. ISO/IEC 27001:2013 deals with Information Security Management System, or ISMS, where we can apply the CIA Security Triad that deals with confidentiality. That's the C, dealing with things like encryption. The I is integrity, making sure that things haven't been tampered with, perhaps through digital signatures or file hashing. And the A is for availability, to make sure that things are always available, even in the event of some kind of a failure. So really, we're talking about managing the risk of things failing, or of things being tampered with, or things being transmitted over the network without being protected. So we're talking about vulnerabilities that we need to make sure that are managed properly. And in order to do that, part of being ISO compliant is conducting a risk assessment and applying the appropriate risk treatments. Now, in order to continually remain compliant with ISO standards, there needs to be periodic audits. Risk management is a monumental part of proper IT governance, and it starts with continuous risk identification. There will always be risk when using technology to support business processes. The key is managing it effectively. After we identify risks, we can then determine what the risk probability is, what's the likelihood of it happening, and what impact would it have should it occur. Then we can start looking at what ways we might possibly mitigate the risk. Maybe there's a security control we can put in place or change somehow to even reduce the risk level even further. Then there needs to be continuous risk monitoring, not only for risks that are currently known, but bear in mind that things change with technology and threats constantly. So we have to bear that in mind when it comes to continuous risk monitoring. There are numerous risk categories that we need to consider as IT technicians, as well as an IS auditor. The overall enterprise risk, seen at the top here in the diagram, can have a lot of underlying risk categories, such as environmental risk. What would happen, for instance, if there was a flood, or if there's storms that cause power outages for extended periods of time? How are we going to deal with the impact of that risk materializing? Maybe it would be dealt with by having alternate sites in alternate geographical locations. But then what about data? Well, maybe we need to have continual data replication between those sites to properly manage that risk. It really depends on the specific organization and their appetite for risk. Then we have to look at things like operational risk. What is the risk in operating, for example, a public website that collects personal user data and then stores it and perhaps processes it later? Well, if we're dealing with European Union citizens, then we have to deal with the Gdpr regulations that deal with how we can collect and use information related to European Union citizens. Then there's compliance risk. We need to make sure, based on the industry that we're in, for instance, that we are complying with specific laws and regulations. So one way to work with risk and manage it properly is to have a risk register. A risk register is a centralized list of identified risks. Now, this could be for the entire business unit or project, and normally an entire business itself, an organization, will have a collection of different risk registers for different business units or projects. Now, in the risk register, each risk that we've identified gets assigned a severity level. The severity level really comes from what the probability of that risk occurring is and the impact that it would have, whether it's a mild impact or a very high severity level type of impact should it occur. Then the risk owners are listed and risk mitigations are described. So this is really an organized and structured approach to identifying risks, looking at the likelihood and the impact of the risk, and trying to come up with cost-effective and efficient ways where we can reduce that risk. We know that risk management is a crucial part of dealing with IT solutions that support business processes. And we know that we can have a centralized risk register that identifies the risks along with their severities and possible mitigations. So let's focus on risk treatments. Now, risk treatments really focus on how we deal with the management of specific identified risks. And how that's done really depends on the organization's appetite for risk. We also need to define the risk owner, who is responsible for dealing with that risk should it materialize, and what is the impact of that risk. The first risk treatment is risk acceptance. This is also called risk retention. You're retaining the risk because you are accepting it as is. So the risk is known, and the loss, should that risk occur, is acceptable if it actually happens. So it means that we are looking at some kind of a risk, and there's always some inherent risk involved with doing business, and certainly with using underlying technology to support those business processes. So with risk acceptance, we accept the risk as is. An example of this might be the fact that we might always have employees that might commit fraud in conjunction with a specific business process. Well, that's a risk that we need to accept because that's always a potential possibility, despite our most thorough efforts conducting employee background checks. The next risk treatment we'll talk about is risk avoidance, where risk cannot be transferred to a third party, such as an insurance provider, and so the risk is deemed unacceptable to the organization. So in other words, the organization does not undertake that specific endeavor because they want to completely avoid the risk. So choosing not to engage in an activity or a project is an example of risk avoidance. The next risk treatment is risk reduction. This means that we are striving to lessen the risk frequency and also the impact of it should it occur. So this is risk mitigation. So we can implement a strong risk management framework to achieve risk reduction. But in order for this risk treatment to be effective with risk reduction, we need continuous monitoring of security controls. So an example of risk reduction would be to configure firewall rules or to have up-to-date anti-malware scanners running on your devices. The next risk treatment is risk transfer. This is also called sometimes risk sharing. And we would use this when mitigating the risk might not be feasible or desired. So in other words, we're talking about outsourcing the risk to another party. Now that might be through cloud computing, because when we partake in cloud computing, some of the responsibility, depending on what we're doing in the cloud, will remain with us as a cloud customer, but also some of the responsibility, such as uptime and maintaining hardware and so on, is the responsibility of the cloud provider. Same thing is true with subcontracting work out to subcontractors. We are outsourcing some of the risk to them. Now, at the same time, we want to make sure that we are diligent because we want to make sure that we have proper supply chain management and that we have security accreditations or certain standards that are met by these outsourcing parties. Another example of risk transfer would be insurance, whether it's insurance for things like fire and flood, or even cybersecurity insurance for protection against certain types of cybersecurity attacks. And in some cases, with some security providers, if you can prove that you've met certain security standards, so you've gone through proper risk assessment, you've implemented controls, there is continuous monitoring, you might even get a reduction in premiums on a monthly basis for that cybersecurity insurance. Bmis stands for Business Model for Information Security. So we're talking about IS security management from a business perspective, as the name implies. When we talk about information security, we're not simply talking about the technical controls that can protect us from malicious users like firewalls and intrusion detection systems and anti-malware scans. Now, while those controls are important, we also are talking here with Bmis about organizational security policies. In other words, making sure that people follow through with security best practices. That would even include things like user awareness and training, so people are aware of things like social engineering and what they should or should not be doing when it comes to security and the best interests of the organization. So we're really talking about the interaction of users, technology, and business processes. So the emphasis here is we aren't focused just on the technological security solutions. They're a part of what we need to consider, but it's not the focal point. How we use them is more important. So there was a common misconception then when it comes to business and IT security that security is somebody else's responsibility. They'll take care of things for us. When in fact, that is not the case. Even for small organizations that might wonder, why would malicious users be interested in my databases? Perhaps you store customer information in databases and it's only a small number of local customers in your community, but still, we still have to consider security. It's not somebody else's problem. Remember that these days, pretty much all businesses almost entirely rely in some way on IT solutions to support their business processes. Certainly there are exceptions, but generally speaking, this is the case. So with Bmis, we need a common definition of security among all departments within the organization. Everybody needs to speak the same language and be on the same page. There needs to be an understanding that security needs to be something that is thought of to support business processes. And of course, underlying that normally is technology. Organizations need to recognize that information security has related time and resources. Security isn't cheap. Security isn't something that should be reactive. It needs to be proactive. It needs to be budgeted for and dealt with, for example, through all phases of the development of a system, not just after the fact. So really, security needs to be a budgeting expense, an operating type of expense over time and continuously. We also need to have an overarching, holistic view of security and how it will support business objectives. So, for example, if part of our business objectives includes things like producing products and selling those products online and then supporting those products through a warranty type of system, then we want to make sure that we have security that's thought of at all phases. So naturally, security would include physical security in a location where we build these products, but also security that applies to business processes from end to end, such as segregation of duties and job rotation. And then, of course, technological solutions like firewalls to control traffic into and out of hosts and networks, and also making sure that we encrypt data at rest when we store customer information that we might gather through our website, and so on. But the key with the business model for information security is to tie security in with business processes and have all units within the organization speaking the same language and having the same definition for security. ITAF stands for Information Technology Assurance Framework. But assurance for what? Well, in our context, we're talking about an assurance during an IS audit that things are done properly. So we're talking about general standards, performance standards, and reporting standards. Let's talk about each of these in a bit more detail. General standards are really in reference in this context to the IS audit and assurance standards published by Isaka. That would include standards like 1001, Audit Charter 1005, Due Professional Care. General standards are all about the IS auditor's ethics and objectivity in drawing conclusions based solely on evidence, as well as the auditor or the audit team's competency. Performance standards once again refers to the Isaka published IS audit and assurance standards, specifically 1201 engagement planning, 1202 risk assessment in planning, because we know we're talking about a risk-based approach to an IS audit, 1204 materiality, so that if some urgent incident is discovered while conducting the audit, this needs to be communicated immediately to the relevant stakeholders. Reporting standards, as the other two standards, also refers to the Isaka Audit Assurance Framework. Specifically, 1401 for reporting and 1402 for follow-up activities. We're talking about follow-up activities after the audit completion to make sure that any recommendations have been put in place by management. It also deals with the types of reports that are generated and the communication between the audit team and the client. An IT Balanced Scorecard, otherwise called an ITBSC, was originally a performance management system that was used to convey information, usually on a single page, hence scorecard. Now, what's interesting about this is it's a common language used to convey the strategy related to how IT will support business processes. And again, it's normally on a single page. Sometimes less is more. So what we do then with an IT Balanced Scorecard is we can compare current performance for specific key performance indicators against previously benchmarked values. Examples of that might be how well the help desk deals with help desk tickets, which includes things like user satisfaction and dollar amounts such as how much cost is associated with the help desk servicing individual user calls on average, and what we want to do into the future. We want to project that into the future to see where improvements can be made. So here we have a sample software development scorecard where we can see at the top we have things related to profit growth. That can be done by increasing shareholder value and having more retained earnings. So that's more on the financial side of things. However, on the same scorecard, on the same page, we can have more information related to software development, such as an app that runs on multiple platforms. And maybe initiatives would include things like having high quality application support to support our user base. Next, on the internal side of things, we would have a continuous integration and delivery or CI/CD system whereby developers might be paid a bonus based on how efficiently they can add changes to code and test it and make it available so it can be released into production for constant improvement of an application, because here we are talking about a software development scorecard. Next, we could deal with learning and growth internally within the organization, such as developer training and the attending of industry conferences. So what we're talking about here are some initiatives like attending industry conferences and a bonus system. What you'll normally see on a scorecard as well are dollar values that go along with each of these. In other words, where we might be currently in terms of dollar or percentage values and where we want to be. So a balanced scorecard then is a nice, easy way on a single page to convey information about where we are in terms of efficiency with a business process supported by IT solutions. In this exercise, you'll start by describing IT governance. Next, you will explain the purpose of the Cobit IT governance framework. Following that, you will list Itil phases, and finally, you will list common risk treatment options. At this point, pause the video, think about each of these 4 items, and then come back to view the solutions. IT governance is about aligning IT or technological solutions with business needs. This way, organizations can get the absolute most value out of their IT investments. This is done through increasing efficiency of the IT solution and also how effective it is in meeting business objectives. We can reduce waste and also reduce cost. Cobit is an IT governance framework. It focuses on risk management, where we need to derive value from our IT investments to improve IT system and data quality. We need to define control objectives. An example of this would be, for instance, to make sure that a customer database is always online. Then we need to map that to one or more controls to make sure that that can actually happen. So Cobit is an IT governance framework based on risk management. Itil phases include service strategy, followed by service design, then service transition, where we deal with things like a proper change management process, and then service operation. And an important part of Itil is the efficient and effective delivery of IT services. And so in the 5th Itil phase, continual service improvement, we have continual monitoring to make sure that things are efficient and effective, because in IT, where it supports business processes, things change over time. And so what solution might have been effective at one point in time may no longer be effective after time has gone by. And therefore, we need continual monitoring for continual service improvement. Managing risk means dealing with risk treatments. For example, risk acceptance would be the acceptance of a risk as is. So we're choosing to engage in the activity that introduces that risk. Risk avoidance means that based on the organization's risk appetite, engaging in a particular activity is unacceptable because the risk is unacceptable. And so we avoid engaging in that activity. Risk reduction, also called risk mitigation, means that we can put controls in place to reduce the impact that a realized risk would have. Finally, we also have risk transfer, which means that we are transferring some, or in some cases, the largest majority of the risk to a third party. That can be done through insurance, or it can be done to a degree when we adopt cloud computing services. The CIA Security Triad is often an important part of an IS audit, where laws or regulations might stipulate that the CIA Security Triad or part of it be applied to protect assets. In the CIA Security Triad, the C stands for confidentiality, the I stands for integrity, and the A stands for availability. Let's take a look at each of these 3, starting with confidentiality. Confidentiality is all about protecting sensitive data from unauthorized parties, and often this is done through encryption. Encryption can be applied to data in transit as we're sending information across a network, or it can be applied to data at rest, data that's stored somewhere, such as a database containing customer transaction records stored on a hard disk. When we take plain text, the original data, and add an encryption key, which is then all fed into an encryption algorithm, the result is ciphertext. The ciphertext is the scrambled or the encrypted data, and you can't unscramble it or decrypt it unless you have the appropriate key. The integrity part of the CIA triad really means how trustworthy is data? Has it been tampered with in some way, or has it been corrupted? And one way to work with integrity is through hashing. Hashing allows us to feed data. So let's say a file at the bit level, all the zeros and ones, we're going to feed that data into a one-way hashing algorithm, whether it's MD5 as an algorithm or SHA-256. What happens is the output is a unique hash value based on the data that was fed in. And so what we can then do is store that unique hash value, and in the future, we can check the validity, in this example, of the file by doing the exact same thing, by feeding the file data at the binary level into the same one-way hashing algorithm. And if we get the same result again, it means nothing has changed. The file's not been modified, and it's also not been corrupted. Availability really means, can we get to the system or data that we need when we need it? And so often, we might have availability quoted in a percentage, such as a database being available 99.99% of the time, which really means very minimal downtime. Often availability is implemented through redundancy of some kind, such as for a facility. We might have an alternate location where business operations can continue if something happens at the primary location, such as the outbreak of a fire. Or we might have redundant network connections, which might be important to link offices together over the internet or to link a data center to a public cloud provider. So if one network connection fails, we have an alternate to fall back on if we need to have access to those cloud services. Then there's power redundancy, maybe using power generators that would kick in when the power goes out for an extended period of time, or even using uninterruptible power supplies, UPS systems, for short-term power supply through batteries. We might have redundancy implemented at the computing device level, such as having multiple servers in a cluster offering the same service, and if a server fails, other servers can pick up the slack and users would continue to have access to that system. We can also have redundancy at the disk level, maybe configuring a RAID disk array where we have a number of disks working together. For example, a disk mirrored solution within a server would mean that data written to the partition on one disk is also written to a partition on a second disk. And so if we have a failure of the first disk, the second disk already has everything up to date. So it's important to understand the CIA Security Triad because often it can be a part of what we look at during our IS audit. Legislators in countries around the world in recent years have begun to focus on data privacy. And when you look at the details within those various acts of legislation, you will see references to personally identifiable information, otherwise called PI, PII. PI is anything that can uniquely identify a person, whether it's one or more pieces of information together. And so when it comes to data privacy, we have to think about the collection of that data, the transmission of the data, how the data is stored, who it's shared with, and what the data is used for. For instance, many acts of legislation will require that data be collected only with the consent of an individual and only if it relates to what the business does. Examples of PI would include a web browser cookie, depending on the contents. Now, a web browser cookie is a small file that your web browser uses on your machine to store things about preferences for websites you visit or the current session you have with a website that perhaps that you've signed into. So whether or not a web browser cookie is personally identifiable information really depends on what's inside it. It's kind of like having a wallet. Is a wallet personally identifiable information? Well, not really. It depends what's in the wallet. If the wallet has a credit card in it, then yes, the wallet overall as a containment unit would be considered personally identifiable information. And the same kind of analogy can be applied to web browser cookies. Certainly things like a personal home address or an email address, that is considered PI. So is your credit card number, your IP address, or your GPS coordinates used for user location. Now bear in mind that even if we have this type of sensitive information that is encrypted, whether it's at rest or being transmitted over a network, it's still considered personally identifiable information. So even if it's in plain text, ciphertext, encrypted, doesn't matter, it's still Pci. We also have to think about how personally identifiable information relates to an IS audit. So part of an IS audit might include a Pci policy review. That means taking a look at the organization and which laws and regulations apply to that organization for data privacy, such as the Gdpr in the European Union. And then it's important then, as part of our IS audit, to take a look at how effective controls are to protect personally identifiable information. And then, of course, part of the IS audit is going to be to report on deficient Pci controls and make recommendations for remediation of those issues. PHI stands for Protected Health Information. This is similar to personally identifiable information, or Pci, except the difference here is that PHI is focused on the medical industry. So really, we're talking about past and current health information. It can also include future health details that might be related to future health care or payment for future health care. Examples of protected health information would include things like your name, which is also considered personally identifiable information, your social security number, any medical records, your blood type, your phone number, your email address, any account numbers, your IP address, lab test results. All of this is considered protected health information. And the reason that's relevant is there are laws and regulations in different parts of the world that detail how this type of information is to be treated and how it is to be protected when it comes to security controls. So we have to wonder in some cases whether or not protected health information is at play. Consider the example of a medical tracking device worn on a patient. Maybe it's something as simple as a pedometer that tracks how many steps you've taken or how far you've traveled. The question is the information being used, for example, by a healthcare provider, the information that results from the use of a medical tracking device? If the answer to that question is yes, the information from that medical tracking device is being used by a healthcare provider, then you would consider that data gathered from the tracking device, such as how far a person has walked, how many steps they've taken, it would then in that case be considered protected health information. So basically, as long as information cannot be traced to an individual, then it's not protected health information. So if all we have is a medical tracking device, we don't know who's got it, we just know that the information is being retrieved from that medical tracking device, but nothing is really being done with it specifically tied to a person, then in that case it's not protected health information. So it's important to understand when we can identify certain types of data that need to be protected versus do not need to be protected in accordance with laws and regulations. There are many acts of legislation around the world that deal with how to protect sensitive personal information. One such act of legislation is the General Data Protection Regulation, otherwise called GDPR, and this relates to the European Union. What it does is it strives to put the control of a person's personal data into their hands. So this is data privacy related to personally identifiable information, including the collection and retention of that data, the use of that data, and the sharing of that data. Now this is important because GDPR, for example, would be a consideration when you are planning an IS audit if the organization is affected by the GDPR, and we'll outline that in just a moment. So let's start by taking a look at the rules as per the GDPR as it applies to organizations that are collecting personal data. So first of all, we have to ask, is that organization within the European Union, and are they processing personal data? The other possibility is that the organization is outside of the European Union, but it is processing European Union citizen data, in which case GDPR rules would apply. Individuals have rights as related to how their data is collected, if at all, and what's done with it, if they're a EU citizen. So there needs to be clear communication to people about personal data collection and how it will be used. This could be in the form of being communicated verbally over a phone call, maybe during a survey, or on a website when you are filling in information. Also, the individual has a right to request that inaccurate personal data be corrected by the data holder, by the organization that is storing that data. Also, individuals have the right to gain full access to all of their collected personal data at any time. So it's important to look at this from both perspectives. What's required for organizations and what rights do individuals have? And of course, the intersection of both of these is what's going to be of interest to you as an IS auditor to determine what needs to be done and what controls need to be put in place. So when it comes to IS auditing and GDPR compliance, we have to think about the data processing practices for a specific organization. We then have to think about the efficacy, how effective are controls as it relates to the protection of GDPR encompassed data. And so part of an IS audit has to take a look at the GDPR rules, whether or not personal data is being collected and used in any way, and then which controls are in place to protect that data. IS auditors must take it upon themselves to be well versed in any laws or regulations that might apply to what's being audited through the audit scope. Here in this example, I've gone on the internet and opened up some documentation related to the European Union's General Data Protection Regulations, or GDPR. And if I search through that documentation for the word encrypt, then I can see there are references here for encryption and mitigating risk through the use of encryption. So as is often the case when it comes to laws and regulations and structured frameworks, often what we should do is mentioned, but not specifically how we should do it or which tools should be used. Here on my Windows system, I've got a number of files that I want to protect in accordance with the Gdpr. I'll actually just do a single file in this case. I'm going to right-click on it and choose AXCrypt. AXCrypt is a free third-party encryption tool that I've already downloaded and installed. There are many different tools out there to do the same type of thing, and there's even built-in Windows encryption through drive or volume encryption with BitLocker, or encrypting individual files on a Windows NTFS folder using an encrypting file system, but in this case, using a third-party one. Because remember, a lot of these laws, regulations, and frameworks will not stipulate exactly what should be used. So in this case, I'm going to choose encrypt, where I will enter and confirm a passphrase. And then I'll simply click OK, and we can see the icon has changed, the file extension has changed, and if I try to open the file, it first requires that I enter the correct passphrase. Now, isn't this nothing more than simple encryption and decryption? It is, but what's important here from the auditing perspective is we're doing this to align with rules that are required to be compliant, in this case, with the GDPR. Now, the other aspect is we have to look at other related items to this type of security control that mitigates risk. It's not just about the encryption. Certainly that's important here, according to the GDPR. But we should also think about, well, does that mean that we have to have people first logged in and accessing those files to encrypt them? And in this case, we might have Active Directory authentication with complex passwords or multi-factor authentication required first to gain access to a secured file server on a secured network, where then files can be encrypted in this manner. The other issue is, does everybody use the exact same encryption passphrase? That's not good. And the other thing also is, do people write down the passphrase on a sticky note and stick it to the side of their monitor in the office? So it's often not as simple as being black or white, yes or no, it's been done and we're compliant or not. There's usually a few things we have to look at to make that determination. Pci Dss stands for Payment Card Industry Data Security Standard. This is an international standard that is really applicable to merchants that deal with cardholder data, such as credit cards. So it strives to harden payment card processing environments. But the thing to bear in mind is that each card type, whether it's Visa, MasterCard, American Express, and so on, has its own specific compliance details that fall under the umbrella of Pci Dss. The first order of business is to identify cardholder data. This is something that we would do as part of an IS audit where this is applicable. After which, we can then assess controls that might be in place currently to protect cardholder data. Then we can make recommendations on remediations. What can we do to increase or better the security to further protect cardholder information? And with Pci Dss, we then have to submit compliance reports. So it's always important when we conduct an IS audit and it is affected by Pci Dss that we think about inventorying IT assets that are involved with processing and storing cardholder data. And when it comes to remediation, the other component to consider, and this is all specified in the Pci Dss standards, that if we don't need to store cardholder data, then we don't. That's just a risk that isn't necessary unless there's a specific business reason why that data is being retained in the first place. So here are a couple of examples of Pci Dss goals and controls that we might implement to address these items. So if the goal is to build and maintain a secure network, controls to do that might include firewalls and also changing system defaults. If the goal is to protect cardholder data, which is a general statement, controls might include things like storage data protection, if we are storing cardholder data at all, and network encryption over open or public networks. If the goal is to maintain a vulnerability management program, and remember, these goals come straight from the Pci Dss standards documentation. So if the goal is to maintain a vulnerability management program, maybe our control in response to that would be to have an antivirus solution that includes updates and also to apply security to all system development lifecycle phases. If the goal is to implement strong access control, how might we do that? Well, we would make sure that cardholder data is accessible only on a need-to-know basis. So we could implement controls to do that, such as file system ACLs. We could also make sure that we are using unique user accounts so we can track which users did what to specific types of data. We can also implement physical security controls, such as ensuring that storage devices are behind locked doors. If the goal is to regularly monitor and test networks, the control might be to have network host and application monitoring and periodic security testing, whether it's vulnerability scanning or penetration tests. If the goal is to maintain an information security policy, then we might have organizational security policies that are created and made known to employees to make sure that they are followed up on. So Pci Dss compliance then comes in a couple of different forms. We know that one way or another, some type of report needs to be submitted to attain Pci Dss compliance. One is called a self-assessment questionnaire, or an SAQ. And this is a validation tool that asks numerous questions for organizations that are eligible to do this. And so that is one way that this can be done. Or Pci Dss compliance might require a report on compliance, or an ROC, where we might have to have external auditors come in and perform an assessment to determine whether our practices are compliant with what is needed for Pci Dss. IS auditors are responsible for assessing risk and identifying inadequate controls and making recommendations on how to secure assets. And often that's done within the structured framework that's being used for the audit, and also in accordance with specific laws, regulations, and standards, such as Pci Dss, which is for anyone dealing with cardholder information. Specifically, in this example, Pci Dss requirement 5 is really focused on protecting systems from malware. So having regularly updated antivirus software or programs as part of this requirement. Although, as usual, we aren't told exactly what should be used or exactly how it should be configured. And this is where the IS auditor has to take a look at this type of requirement, take a look at the controls currently in place, and determine if those controls are adequate or not. There are plenty of tools out there that will let you inventory your network over time and monitor it for things like compliance with certain requirements, such as whether antivirus solutions are up to date or not. Here I'm using the free Spiceworks tool that I've installed and let run for a few days. Now, when I log into the Spiceworks web app on my local machine, I can see further down in the Security Center section the antivirus status, which in this case is relevant for us for Pci Dss Requirement 5. And I can see, according to the legend, that green means we've got up to date. So 25% of the detected hosts on the network are up to date, but then we've got server operating systems listed here as 75%. We can also see the name of the antivirus installations and the version that they're at and the number of occurrences, number of installs. So in this case, I'm going to click on my server operating system part of the pie graph. That gives me a list of servers. And if I click on one of the servers, down below I'll have some details. And what I'm interested in primarily are the alerts. Here I can see System Center Endpoint Protection, which is the software that we are using for anti-malware, is not up to date on that host. And so this is going to be important whether we're looking at the status of individual devices and whether they have malware protection or the overall status. And as an IS auditor, this type of tool becomes valuable not only because it gives us an overall sense of anti-malware protection, but it does this also over time. So we can let this run over time so that if things are compliant for a period, they might become non-compliant later in terms of keeping anti-malware up to date. So having a tool like this is important to determine whether or not an organization or a subset of the organization is compliant with specific laws, regulations, and rules. Hipaa stands for Health Insurance Portability and Accountability Act. It really focuses on limiting the disclosure of protected health information, or PHI, in the United States. So we want to make sure then that this type of protected health information, things like a person's blood type or lab results or their home address, is only disclosed where it makes sense and is legally allowed. So therefore, Hipaa applies to HIPAA-related entities, things like healthcare providers and any business associates, and the use of health plans. HIPAA compliance begins with becoming familiarity with protected health information and how it applies to HIPAA in the United States, to be specific. And this would be part of what needs to be done as part of an IS audit where HIPAA compliance needs to be checked. Now, an internal compliance audit can then take place to identify any gaps between what should be done and what currently is being done for dealing with protected health information. Now, to take it a next level up, that could also trigger a U.S. Office for Civil Rights, or OCR, audit to ensure HIPAA compliance. HIPAA compliance includes a number of potential security controls, such as strong user authentication to systems that make protected health information available. Also, device authentication on a network where that data is potentially accessible. Encryption of protected health information. Also, data integrity to ensure that it hasn't been tampered with, or if it is, that alarms are set off, perhaps through file system auditing. And also the continuous monitoring for security breaches, not just on hosts dealing with protected health information, but the networks on which those devices reside. The Federal Risk and Authorization Management Program, otherwise called FedRAMP, is related to the United States and the use of cloud computing for U.S. government federal agencies. So it's all about the secure usage of cloud service offerings. And as an IS auditor, if you are dealing with a U.S. government agency that falls under the requirements of FedRAMP, well, it's important to know some of the details that go along with that. One of those things to consider is who is responsible for security. In the case of cloud computing, it's usually split between the cloud service provider and, in this case, the specific government agency, the cloud customer. So, for example, the cloud service provider would be responsible for security at the underlying hardware infrastructure level and the physical data center facility security, but the U.S. government agency utilizing cloud services in that environment would be responsible for how their data is used and how it is stored and replicated. The data location doesn't matter with FedRAMP. It does not have to reside within the United States. But then we have to think about the FedRAMP certified infrastructure. So think a layered approach. So layered IT services are not automatically FedRAMP certified. What does that mean? Well, let's say that we've got a network in the cloud, so a virtual cloud network, that is FedRAMP certified. Well, just because we deploy a virtual machine with a database and a web application front end on that certified infrastructure does not by extension mean that our database, virtual machine, and web front end are automatically FedRAMP certified. So again, layered IT services are not automatically certified. FedRAMP requires that we use FIPS 140-2 cryptographic modules. These are considered to be trustworthy and secured by the U.S. government, using, for example, the Advanced Encryption Standard or the AES modules. So for encryption, maybe using AES 256-bit encryption. For hashing and digital signatures, maybe using SHA-256, and also using FIPS 140-2 cryptographic modules to authenticate users, devices, and software applications. Other requirements include the use of Transport Layer Security, or TLS, version 1.1 or higher. TLS supersedes the old SSL standard, Secure Sockets Layer. Both of these are standards that use a PKI certificate in order to secure network communications. However, SSL, even SSL version 3, is considered deprecated and not secure, so it should not be used. Same thing goes with TLS version 1.0 because there are known vulnerabilities. FedRAMP requirements also include the use of unique user accounts. There's no sharing of user accounts because then that gives us an issue when it comes to accountability. We should adhere to the principle of least privilege, where only the permissions required to do one's job are granted and nothing more. It's important that malware updates are kept applied all the time, and that we monitor for malware intrusions and send out alerts when they are detected. There are many different cloud providers internationally. Some examples of FedRAMP certified cloud providers would include Microsoft Azure, Amazon Web Services, otherwise called AWS, as well as Google Cloud. IS auditors will often approach the audit from a risk-based perspective, and so it's important to be able to identify assets and associated risks. Now, this begins with identifying assets to the organization, associating values with those assets, and then determining who the custodians responsible for those assets are. Following that, risks need to be identified, along with the likelihood of the risk materializing and the impact it would have if it did happen, and then identifying controls that are in place to determine if they are sufficient or not. The IT asset lifecycle begins with planning on what's needed and then procuring it. Now bear in mind, an asset doesn't necessarily have to be a tangible physical piece of equipment like a server or a storage array in the wiring closet. Instead, we could be talking about data that gets gathered over time. But IT physical assets, once they are procured, can be deployed, they are operated, including the application of updates, and then they are eventually decommissioned. Now, it's important to understand assets and risk management and risk calculations, because part of an IS audit is not only determining whether we've got the appropriate controls in place, but part of an IS audit is also determining if those controls are effective and efficient, even cost efficient. So some asset risk calculation items that we should be aware of are the exposure factor, or the EF. This is expressed as a percentage, and it's a percentage of an asset that could be affected by a single occurrence of a negative event, so the realization of a risk. The single loss expectancy, or the SLE, is the cost associated with the single negative event. So where the exposure factor is a percentage, the single loss expectancy is a dollar amount. The annual rate of occurrence, or the ARO, is how many negative incidents we expect to occur per year. Now that can be done based on industry standards along with past historical information within the organization. Then we have the annualized loss expectancy, or the ALE, which is calculated by multiplying the annual rate of occurrence by the single loss expectancy. Now, again, it's important that we think about this in the context of what the asset is. So even though a server might house a database that has a lot of valuable information, is the server an asset? Well, it is, but it probably pales in comparison when it comes to the value of a database asset containing, for example, customer purchase history information. So let's do a calculation example. Let's say we've got a database that's got a value of $500,000. So this is the data within the database. And we've determined that, generally speaking, if we have a database security breach, we could expect up to 5% of data value loss. Now, that might take into account how much data is actually compromised. It could also factor in things like consumer and shareholder confidence and reputation loss, all of those factors. But let's say it's 5% in this case. So in this case, we've got an exposure factor that is 0.05. 0.05 is 5%. Now, this also means that our single loss expectancy we can calculate by multiplying the asset value, AV, times the exposure factor. So in this case, the asset is $500,000, that's the database, multiplied by 5%. So we get $25,000 is the single loss expectancy if we have a single negative occurrence. Now let's say, based on industry trends and on our own past history within the organization, we suspect we might experience a database security breach once every 2 years. This means that our annual rate of occurrence then, or ARO, is 0.5, because if it happened once a year, the annual rate of occurrence would be 1. Next thing, we can do the calculation. So we can determine what the annual loss expectancy might be. So we're trying to account for materialized risk here for that database. We would multiply the annual rate of occurrence by the single loss expectancy. So we've got 0.5, so every 2 years, times $25,000, which equals $12,500. Now, what does that end value mean, $12,500? It means that if we put in place controls to protect that valuable database, and as long as those controls on an annual basis do not exceed the $12,500 value, that's the annual loss expectancy, then that security control might be worth implementing. But if we've got security controls or collection controls that we might put in place to protect the database that cost $20,000 a year, well, that doesn't make sense, because based on our calculations, we're expecting that we might have a cost of $12,500 per year if there is a problem, a security or a data breach. The annual loss expectancy, or ALE value, is a dollar amount that we can associate with an asset and any materialized risks that may come against that asset. And this is done on a yearly basis, an annual type of numeric value. And this is important for an IS auditor, because when we compare what the annual loss expectancy for a given asset is, we can compare that against the cost of any security mitigations for that particular asset. For example, it doesn't make sense to spend $8,000 annually to protect an asset where the annual loss expectancy for that same asset is only $1,000 a year. So there are many ways that we can calculate this, including using an online calculator like I'm going to do here. In order, though, to use tools like this, we have to have an understanding of the source numbers and, of course, know how to apply them. We have to have those values. The single loss expectancy is a dollar amount that we gauge against a single negative occurrence against an asset. So let's say we've got a $500,000 database. That's what the data inside the database is worth. And let's say that a single loss expectancy, so a single security breach by malicious users, might cost $5,000. I'll put in $5,000 for the single loss expectancy. Now, the exposure rate is a percentage that reflects the percent of the asset that would be affected by a single negative event. So let's say that's 5%. So I'm going to put in 5. And let's say that the annualized rate of occurrence, how many times a year might this happen, is once a year. So I'll put in 1. When I click Calc for Calculate, it will then determine what the annual loss expectancy would be. And we can see we've got the annual loss expectancy of $250, which tells us that we don't want to spend more than that on an annual basis to mitigate risks against this particular item. But the key is that we want to make sure that these values up above are accurate. Because if we made a mistake, for example, and determined that, well, actually the exposure rate is more like 20%, then if we choose 20% and recalculate, now our AL value, or annual loss expectancy, is up to $1,000. So we want to make sure that we have trustworthy, legitimate numbers that we are inputting here when we run our annual loss expectancy calculations. Conducting a network scan allows us to identify any systems that might be responsible for the processing or storage of valuable data. And as such, we can use tools such as the free Nmap tool in Windows with this ZenMap front end to do just that. So I'm going to go ahead and specify a target of my entire network, 192.168.0.1 through to .254. I'm not going to run an intense scan because that'll take more time than a quick scan. So I'm going to choose a quick scan because what I'm looking to do here is identify devices on the network. Now, why would I do this? Because part of doing proper risk management within an IS audit is to identify assets first and then to go further and look at the risks associated with those assets. So I'm going to go ahead and click the scan button to begin scanning the network for devices. Once we've got the scan results, we can see that we've got the IP addresses for the scan host and also any ports that are showing as being open. And so as we peruse through this information, for example, we might come across a host, let's say, that's got TCP port 80 open for HTTP. So there's a web server running there, and if we determine that that is an important application, whether it's for use internally or if it's a public-facing app, it's an important one, but it's not using an encrypted connection because that would be showing up here as port 443 normally, and the service will be HTTPS. And so as a result, this particular host might be non-compliant with any laws or regulations or frameworks that we are applying to our IS audit. And that's why sometimes using tools like this, tech tools to scan a network for hosts, can be important. In this exercise, the first thing you will do is describe the CIA Security Triad. Following that, you will provide examples of personally identifiable information, otherwise called PI. Next, you will provide examples of protected health information, PHI. And finally, you will explain how the annual loss expectancy, or the AL value, is calculated. Pause the video and think about each of these 4 items, and then come back to view the solutions. The CIA Security Triad begins with confidentiality, which normally takes the form of encryption. It's a mechanism by which we protect sensitive data from unauthorized party viewing. Next, we have integrity, which is used to assure that data is authentic and valid and has not been tampered with or modified by unauthorized parties. Finally, we have availability, to ensure that systems and data are available when they are requested, and often things must be put in redundant form so that availability is possible. Personally identifiable information, or PI, includes things such as a person's name, the street address, their bank account numbers. Whereas protected health information includes things such as blood type, lab test results, and medical insurance details. To calculate the annual loss expectancy, or the AL, you need a few values first, including the annual rate of occurrence, the ARO. This is how often during the time span of 1 year that a negative incident might occur, that a risk might be realized against an asset. So if it happens once a year, it's 1. If it happens every 2 years, it's 0.5. If it's 3 times a year, it's a value of 3. The single loss expectancy, or SLE value, is a dollar amount, a cost associated with the single occurrence of a negative event. And so we can calculate the AL, the annual loss expectancy, by simply multiplying the annual rate of occurrence by the single loss expectancy. Authentication is an important part of security. It occurs before authorization, because authorization is the ability, based on permissions granted, to use some kind of a resource. But before that happens, one must be authenticated. Authentication is proof of identity, and it can apply to a user account, to a device, or even to a piece of software that might need to talk to a back-end database on another host elsewhere. Authentication also refers to over the network, when we send messages, to ensure that messages are authentic and have not been tampered with. When it comes to authenticating, for example, a user to a system, there are many different authentication categories, including something you know, something you have, something you are, in other words, biometric authentication, as well as something you do. So we can strengthen authentication using complex passwords, using intruder lockout settings to ensure that after a number of subsequent incorrect login attempts, the account is locked. We can use multi-factor authentication. Multi-factor authentication uses multiple categories that we mentioned previously. So if we look back here to the authentication category, something you know might be a username and a password, but you might have to have a smart card with you additionally to authenticate. That would be something you have. Or you might know a username and a password, something you know, but you might have to also supply a fingerprint, that's something you are, to authenticate. So those are examples of multi-factor authentication, because we are combining more than just one of these authentication categories. Strengthening our authentication environment also means turning on auditing, so we can audit authentication failures, because that could indicate that there's some kind of malicious attack beginning. We should also consider that edge devices should forward authentication requests to centralized authentication servers. Now this means that edge devices, for example a wireless router then, should not do the authentication. They should be the connectivity point from the supplicant, like a user with a mobile phone that wants to get on a Wi-Fi network, but that should be forwarded off to a centralized authentication server elsewhere on a protected network. When it comes to security, one thing an IS auditor would often look out for is to ensure that each and every user that uses an information system has their own unique user accounts. And in this example, we're going to talk about and see how to work with Active Directory users and groups in an on-premises Active Directory environment. So here on my Windows server, I'm going to go into the Start menu and I'm going to fire up the Active Directory Users and Computers tool. Although managing users and groups in an Active Directory environment can also be accomplished using the Active Directory Administrative Center or even PowerShell commandlets. So here in the Active Directory Users and Computers tool, I've got a number of organizational units under my domain. My domain in this case is called fakedomain1.local, and I've got an OU, for example, called Boston. So here in Boston, I can create users and groups, which is exactly what I'm going to do. So to get started, here in Boston, I'll click the new user icon, and I'm going to create a user, Cody Blackwell. So as I fill this in, it's specifying the full name down below for me automatically, and I'm going to specify the user login name. Let's say is C Blackwell. Now your organization would have to have a specific naming standard that would be adhered to for ease of administration and identifying who is who. Then I'll click Next. The password is always important because depending on what this user account will be used for, complex password requirements might need to be put in place in order to protect assets correctly. So I'm going to specify a password for this account. I'm going to make sure the password is long and complex, meaning upper, lowercase letters, numbers, and symbols, and certainly not a word in a dictionary. The option is set here so that the user must change the password at next logon, so that makes sense. They can change it to what they want. However, I would have to communicate this password to them. And I'm going to go ahead and click OK and then Finish. And then we've got our user, Cody Blackwell, in Active Directory. So that account is now available to be logged into. Now I'm also going to create a group because normally groups are created to facilitate permissions assignment. So I'm going to go ahead and click the Create Group button, and I'm going to call this group Sales. And I'm then going to click OK. Now I want to make sure I add user Cody Blackwell as a member of the sales group, and there are a number of ways of doing it. As a matter of fact, if I select that user account here in Active Directory Users and Computers, notice I've got a little icon up here that allows me to add the selected user to a group. Now I could also go into the group and add the member there, so I'll just do it this way though with the little button. And I'm going to specify by typing in the sales group name. I'll check the name, it's good, it's underlined, it found it, and I'll click OK. And it says that the add to group operation was successfully completed. Let's go check the group. So if I go into the sales group, then I check the members tab. Indeed, we can see user Cody Black. If I double click on the sales group and then go into the members tab, we can see that Cody Black is indeed a member of the group. One of the things that we'd want to watch out for as IS auditors is, first of all, making sure that users are only in the groups they should be. So if Cody Blackwell is currently a sales associate, maybe it makes sense that currently he's in the sales group. But if he moves to another part in the organization and assumes a different job role, he's no longer a sales associate, then we want to make sure he is removed from this group. And that's definitely part of an audit because we don't want users in groups that get permissions that they really shouldn't be getting. These days, an IS auditor, when it comes to taking a look at users and groups and the permissions they've been assigned, has to contend not only with how that might be done on premises, but also in the cloud. So here in Microsoft Azure, in the GUI Web Portal tool, I'm going to go ahead and create a Microsoft Azure Active Directory user as well as a group. To get started here in the portal, I'm going to scroll down in the bottom of the left-hand navigator until I see Azure Active Directory. Here in Azure Active Directory, I can see that I've got a users and a groups option available in the properties blade. I'm going to go ahead and start with groups. Any existing groups will be shown over here on the right, but I'm going to click New Group to add a new one. The group type here will be a security group used to assign permissions within the Azure environment. Notice the other option is for Office 365. The group name here is going to be Sales. I could also enter a group description, and I can also determine the membership type, whether it's manually assigned or whether, based on the attributes of a user or a device, those attribute values would determine whether or not the user or the device is a member of the group. So I'm going to leave this on the standard manual assigned membership type, and I'm not going to add any members as of yet. So I'll click Create. Now after a moment, I will have created this group in Azure Active Directory. And as we know, it's easier to assign permissions to groups of users with the same needs through a group than rather doing it individually for each and every user. So I'm going to go ahead and refresh my list here. And after a moment, we'll see that we've got a sales group. So I'm going to go ahead and close this by clicking the X over on the right, and I'm going to go into the users area, where I can see existing user accounts here in Azure Active Directory. So it allows authenticating to Azure and also, of course, to Office 365 if required. So I'm going to click New User. I could build a new guest user by sending an invitation, for example, through email, but here I'm just going to build the user directly in Azure Active Directory. When I do that, I have to specify the details for this. So I'm going to build a user, Jonathan Gold. Now the username is going to be, in this case, jgold, according to my naming standards within the organization, and then the name of the Active Directory domain here in Azure Active Directory. Now if I don't know what that is, I can just close out of that, close out of the users, and go back to the overview of my directory, and I can take a look here at the default directory and the domain name up above. See here, and I can copy that. So now when I go to build a user, let's just do this again. We're going to do it for user Jonathan Gold. It's going to be jgold @ and then I'll just paste in that domain name. Now I could specify a few other details. So under profile, for example, first name and last name, the job title. So maybe here sales associate. The department, of course, would be sales. And I'll OK that. And over here, I can also put this user in one or more groups. I want to put this user in the sales group. So I'm going to go ahead and select sales. And it's been added here down at the bottom. So now I'll click select and I'll click show password because it's going to assign a default password to this account, which can be changed. I can also copy it and convey that to the user and then click create. And after a moment, indeed, we'll see our user, Jonathan Gold. Now, if we go back and check out the group membership, let's just double check this here. Let's go back to groups and let's open up sales, and then we'll click members. We'll see, in fact, that Jonathan Gold, in fact, is a member of that group. So we now have a valid account that can be used to sign in for Azure Active Directory purposes. We know that authentication is the proving of one's identity, such as users authenticating against their user account before they're given access to other resources. So multi-factor authentication includes additional authentication factors beyond just the standard things like a username and a password. Even though a username and a password are two separate things, they both fall under the single category of something you know. Hence, they are single-factor authentication and not multi-factor authentication. We can also use out-of-band authentication codes. And you might have experienced this if you've signed into various web services on the internet where, yes, you'll have to know a username and a password, but then your smartphone will be sent an SMS text message with a code. And that unique code you will also have to enter in addition to your username and password before gaining access to a system. So that's called out of band because it's not the same mechanism on that same computer that you're receiving the code. It's through alternative means, in this case an SMS text message sent to a smartphone. Multi-factor authentication then is considered to be much more secure than just username and password authentication. As an IS auditor, you need to consider these details if there are requirements due to laws or regulations and data privacy reasons that data needs to be protected with multi-factor authentication. Multi-factor authentication combines two or more authentication categories, such as something you know, like a password and a username, plus something you have, like a key fob with a numeric code that changes every 60 seconds before you can get into the VPN. Or it could be something you know plus something you are. The something you are is part of biometric authentication. It might be a retinal scan, a voice print, or even a fingerprint. Or you might have something you have plus something you do. the something you do would really be related to things like gesture-based type of authentication methods. Also, bear in mind that with multi-factor authentication, all of the factors are validated at the same time. Now compare that against multi-step authentication, where you have multiple authentication factors, but they're all validated individually. Now the problem with this really is that an invalid factor then is known when it fails. So therefore, multi-step authentication is not considered to be as secure as multi-factor authentication. And contrary to popular misconception, multi-factor and multi-step authentication are not synonymous. They're not the same thing. Multi-factor authentication, or MFA, is a great way to enhance the security related to user authentication. And in this case, we're going to enable that for a user account here in Microsoft Azure in the cloud. To get started here in the Azure Web Portal, in the left-hand navigator, I'm going to click on Azure Active Directory. Then I'm going to go ahead and click on Users. Here I have a list of Azure Active Directory users, but what I'm interested in doing in the bar at the top is clicking the button that's labeled Multi-Factor Authentication. That's going to open up a new web browser tab where I can put a check mark next to the accounts for which I want to enable MFA, or multi-factor authentication. Notice that for user Jonathan Gold, currently multi-factor authentication has a status listed as being disabled. So I've checked on that user account, and I'm going to click Enable over on the right to enable multi-factor authentication. So enable multi-factor authentication. It says it's now enabled for the selected accounts. Okay, close. So the next thing that we need to do then is to take a look at what we need to do to sign in as that user, Jonathan Gold, in Azure Active Directory. So now, if I attempt to log into portal.azure.com, I can specify that user account sign-in name. So I'll do that and click Next, and then I'll enter the password. And then I'll click Sign In. Now it tells me now that more information is required, and that's because I've enabled multi-factor authentication for this account. So that's fine. I'm going to go ahead and click Next. So it wants me to determine how I should be contacted, like an authentication phone number. So I'm going to go ahead and specify my country, and then I'll pop in my phone number, and I'm going to have it send me a code by text message for authentication. So I've entered the code that was sent to my phone through SMS text messaging, and it accepted it. So I'm going to go ahead and click Done. So at this point, every time that I log in using that account to Azure, I'm going to be prompted for multi-factor authentication. Now in this case, because it's the very first time I've signed in here, I've got to change my password. So I'm going to go ahead and do that. And after I've set a new password, we can now see that indeed we are signed in with user jgold through multi-factor authentication. One way to manage permissions in a cloud computing environment for assistant administrators is through roles. Here in Microsoft Azure, I'm going to start by going to the Azure Active Directory option on the left in the navigation bar, and I'm going to click Groups because I want to click New Group to add a group of type Security that will be called Azure Admins. And the membership type will be Manual or Assign, and I'll click Create. So I've added a new group, and I'm going to add a member to it, and then we will assign that group to a specific role that gives permissions here in the Azure administrative environment. So I'm going to close out of the group screen and go to my users. I've got a user here called Jonathan Gold, so I'm going to select that user. And currently that user is in a group called Sales, which I don't want. So I'm going to remove that user from the group because now this person is an Azure administrator. So if I refresh, there's no group memberships. I'm going to click Add, and I want this person a member of Azure Admins, so I'll select that group. And after a moment, we'll see that It's done. So we've added the user to the group Azure Admins. Now what I want to do is assign Azure administrative permissions to that group, Azure Admins. Now specifically, let's say I want members of that group to be able to work with virtual machines in the cloud for the entire subscription, not within a specific subset of Azure like a resource group. So up here in the top center, I'm going to select my pay-as-you-go subscription, and I'm going to click Access Control IAM, which stands for Identity and Access Management. I'm going to click the Add button, and I'm going to choose Add Role Assignment. Now the first thing I have to do is choose a role. And here we see a number of different roles for all of the various things that can be done here when deploying cloud resources in a Microsoft Azure cloud computing environment. And if I go all the way down to the V's, I'll see that we've got a virtual machine contributor role. That's the one I want. And I'm going to specify that I want that role to be assigned to a group called Azure Admins, of which our user, Jonathan Gold, is a member. And so if I click Save, it will save that role assignment. So what we're going to do is test this by signing in as user Jonathan Gold to ensure that virtual machine capabilities are present, but nothing else. So now I've signed into portal.azure.com as user jgold. And if I were, for example, to go to the virtual machines view, then we can see existing virtual machines, and if I click Add, I'll be able to go through the process of adding a new virtual machine because this user account is in a group that has been granted that built-in role, the virtual machine contributor role. Now here in the portal, if I were to go to Azure Active Directory, and let's pick on that group here, the Azure Admins group, we can see here we've got one user listed here as a member. We can click on members to see that. And from an auditing perspective, this is going to be important. But if I click on Azure Resources, while we're looking at the properties blade for our group, notice here we've got a resource, our pay-as-you-go subscription in Azure. I'll just click on that to open it up. And we can see that the virtual machine contributor role has been assigned to this group. So this is going to be important because from an IS auditing perspective, checking permissions and making sure people only have what they should have, we need a way to track what's already been done. It's one thing to know how to do it, but from an auditing perspective, we need to be able to trace it to verify what's been configured. Amazon Web Services, or AWS, is another popular public cloud computing platform in which we can build user accounts, groups, and we can assign permissions to users or groups as related to AWS cloud resources. And so to get started here, I've already created an AWS trial account and signed in, and I'm at the AWS Management Console, the web GUI. So viewing all AWS services, down below I see a lot of offerings, and I'm interested primarily under Security, Identity, and Compliance. I'm interested in the IAM option. This stands for Identity and Access Management, where we work with users and groups and permissions that are controlled through what are called policies, as we'll see. So I'm going to click on IAM. First thing I'm going to do is create a user. So I'll click Users on the left, then I'll click Add User. I'm going to create a user called jgold, and this user will be for AWS Management Console Access. The Management Console is what I'm using here for administering AWS Cloud Services. Now I'm going to click Next, where I can assign permissions to this user, but I won't do that. I'll click Next. I can add tagging values or metadata to this user account, but I'll skip that, and I'm just basically going to create the user. It automatically assigned a password to this cloud-based user, but I can click Show and copy it and communicate that to the user. I'll just click Close, because at any time I can also go back into that user account under Security Credentials, and I could manage the console password and reset it. Notice we can also enable multi-factor authentication, whether we want users to have a physical hardware device that has a changing code, or it could be an app on a smartphone. I'm going to click on Groups over on the left and create a new group. And this group is going to be called AWS_VM Admins. And then I'll click Next. I'm just going to continue through and create the group and not do anything beyond that. So here we've got our group, AWS VM Admins, and if I click on that, we can add users to the group, and I'm going to add user J Gold. You can also do that as you're building the group. I'm just doing it after the fact. But while we're here still looking at the properties of our group, we've got a Permissions tab. And here we can attach a policy. In AWS, a policy is a collection of related permissions. So I'm going to click Attach Policy, and we can see there's quite a lot of them available here, but we can filter out the list if we really want to. So I'm going to type in EC2 in the filter. EC2 is what virtual machine computing environments are called here in AWS, EC2. And so I'm going to scroll down, and I can see a role here called Amazon EC2 Full Access. In other words, full virtual machine capabilities at the administrative level here in the AWS cloud. So I'm going to attach that policy. Notice I can attach multiple policies, but I'll attach just that one to the group. So attach policy, and we can see it listed here. Now, if I were to go back to my user, J Gold, and open up his account, notice that we can see permissions come through a group membership here, AWS VM Admins. Specifically, the policy is called Amazon EC2 Full Access. So this way, we have a controlled manner through which we can assign cloud-based permissions to users in Amazon Web Services. Part of adhering to the principle of least privilege is ensuring that we only assign permissions required to perform a job function. And that is possible in a Microsoft Active Directory environment using delegated administration. In our example, we're going to go into Active Directory and ensure that members of a help desk group have limited permissions. We want them to be able to reset forgotten user passwords and that type of thing, but we don't want to give them full-blown access to everything. So let's get started here in Windows Server. I'm going to begin by going into the Active Directory Users and Computers tool. Now within Active Directory Users and Computers, we can see the hierarchy under our Active Directory domain. For example, here I've got a Las Vegas organizational unit in which I am organizing computer accounts, groups, and users. I've got a group here called Las Vegas Help Desk. I want to make sure members of that group can essentially manage users in the users OU. And when I say manage users, I don't mean creating and deleting them and all that, just basic help desk functionality, which means the resetting of passwords and so on. So to get started in making that happen, I'm going to go ahead and right-click on that OU, on the users OU under Las Vegas, and I'm going to choose Delegate Control. So this is going to start what's called the Delegation of Control wizard. I'll click Next. So first, I have to select who I want to grant control to. I'm going to click Add, and it's the Las Vegas. I'll just click Check Names, and it found the Help Desk group. That was a unique entry. So I'm going to click OK. Then I'll click Next. So what should the members of the Las Vegas Help Desk group be able to do here in Active Directory, specifically in the users OU? Create, delete, manage user accounts. No, that's too much. How about reset user passwords and force password change at next logon? I want that. Read all user information. Yeah. What about modifying group membership? That sounds like a standard help desk requirement, and let's assume it is in this particular case. And that's it. That's all I'm going to do. Then I'm going to click Next and Finish. Now, if I were to right-click on that OU, the user's OU, and go into the properties, then I would be able to go into the security part of the permissions for this part of Active Directory, so the permissions for the user's OU, and I can see here that the Las Vegas Help Desk group has been added here with, it's grayed out, but you can see here special permissions. If I click Advanced, we'll be able to drill down into that a little bit more. So see here, we've got entries for Las Vegas Help Desk for resetting the password, for reading all properties, and so on. And I could have added or edited the entries manually here. All the Delegation of Control wizard is doing is really making these changes based on my selection. But it's important because the last thing we want to do, and this happens a lot, and you might come across it in an IS audit, is that when we have an assistant or help desk staff that need some permissions, the lazy way to deal with that is simply to put them in an administrative level group in Active Directory, which gives them way too much power. It violates the principle of least privilege. Instead, if we've got other people that should be able to administer certain aspects of Active Directory, we should be using the delegation of control wizard. Identity federation is all about authentication for users, perhaps for devices, and even for software entities that need access to specific resources. With identity federation, we have accounts that are trusted across multiple systems or environments. This means essentially that we are connecting identity management systems. So what happens is identities such as a user account and all of the attributes that go along with that user, such as their email address, their logon name, the department they're in, their location, all of that stuff is stored only once. So there's no need to recreate user accounts in other systems in order for them to be authorized to access resources. So what happens then with identity federation is we also have the ability to enable single sign-on capabilities. Single sign-on is referred to as SSO. And as the name implies, it means that once we have the initial authenticated connection, when a user is accessing other applications that require authentication, they will simply take an authentication token because the user is already authenticated instead of prompting the user for credentials over and over again. Identity federation is based on trust. This means that a trusted identity provider, such as Microsoft Active Directory on premises or out on the internet, even Facebook or Google, could be considered a trusted identity provider where you might have an account. And when identity federation is set up, after you successfully authenticate to that identity provider, the identity provider will digitally sign what's called a token. Now, what this means is that trusting resource providers like other websites or other databases or apps that you want to access, they will verify the digital signature for the digitally signed token your station presents to that site or that app. And if identity federation has been set up correctly, then resource providers, where a resource is like a website or a server, will trust the signature from trusted identity providers. So how does this work? Well, what starts with a user accessing an app then translates to the user being authenticated to the identity provider. Now take note that the identity provider could be a totally different environment than the app that the user is trying to access. The identity provider then creates and digitally signs the token. Now, digital signatures occur using a unique private key. The token is then presented to an app, and then the user is authorized to use the app. Because the application running on that host will verify that digital signature, which was created with a private key, it'll verify it using the mathematically related public key to make sure that the message is authentic and hasn't been tampered with. Now, if we look at this from a visual perspective, here at the top of our diagram, we've got a user. On the right, we've got the identity provider that provides an authentication service. That might be Facebook, where you have an account, or Google, or it could be Microsoft Active Directory. Either way, it's considered an identity provider. On the far left of our diagram, we've got the service provider. Sometimes it's called a resource provider. Let's assume that's like a web application the user needs to be authorized to use. So in step one, the user requests connectivity to the service provider, to, let's say, a web app. What will happen is the web app will be configured to trust the identity provider. So that configuration has to be in place. So therefore, in step two, the service provider will redirect that authentication request so that the user is directed in step two to the identity provider. Now, the user doesn't see this happening. All the user knows is they're trying to access a particular web app and they're being prompted for some kind of credentials, perhaps a username and a password. Now, after successful authentication in step 3, so the user has entered the appropriate credentials, what happens is that the identity provider then responds with a digitally signed token. Now, depending on the environment and the specifics of the configuration, the token might contain other assertions, otherwise called claims, like a user's email address, maybe a date of birth, if they're connecting to an app that requires that type of thing. Now, that might be sent back in the form of a cookie to the user's web browser on the user's station. Either way, in step 5, the user is granted access to the application because they have a digitally signed token that is trusted by the service provider. Data tagging is an important concept for the IS auditor. Part of the audit might require verifying that data is being classified correctly, maybe for permissions management. Data tagging means we are adding metadata to existing, for example, data files or records in a database that provides further descriptive attributes or information. And we can use that metadata as data labels so that we can facilitate permissions management. So maybe if we have files stored on a file server that contain credit card information, maybe they would be flagged as personally identifiable information. And that can facilitate determining who should have access to that type of data. Data tagging facilitates security, especially on a larger scale. So we can determine classification labels that make sense, and consistency is the key here. Now, the classification label is also called metadata or a tag. Now, we might have to do this to be compliant with certain laws or regulations, such as dealing with personally identifiable information in a secured manner, or protected health information, PHI. It also could be used for data archival and destruction, such that if we have data that contains credit card information flagged as personally identifiable information that hasn't been accessed in more than 5 years, maybe it can be long-term archived at that point. The Microsoft File Server Resource Manager, or FSRM component of the Microsoft Server operating system, allows us to work with data classification, whereby file contents are examined. When we configure File Server Resource Manager, we tell it where to look in the file system, and that's how it knows which files should be examined. Now, when search criteria is encountered, the file is tagged. So imagine that we're telling File Server Resource Manager to search through drive J on a specific host, and we want it to look inside of files for the word Visa. And when it finds the word Visa, and we have what appears to be a credit card number, we want to flag those files with extra metadata or labels or tags that say that it's personally identifiable information. Next, software can manage files based on tags. So for example, we could set up permissions such that if something is flagged as personally identifiable information, only a small subset of users have read access, and an even smaller subset have write access to that type of file. So permissions can be managed based on those tags. As an example, imagine that we configure File Server Resource Manager to search a specific shared folder, so fileserver1/customers, for any file type containing social security numbers. And when found, tag the file with government. We might also search fileserver01 customers for any file type containing credit card numbers or banking information. And then when found, we could tag it maybe not as personally identifiable information, but maybe the word financial. It really depends on the organizations. But again, being consistent is going to be very important here. So then if we've got, let's say, a full-time employee working on government contracts in the city of Ottawa, and they attempt to access files tagged with government, we might allow read and write access. But if they try to access files flagged or tagged any differently, they will not have access. So for instance, if we have a full-time employee in the finance department that attempts to access files that are flagged as financial, then maybe we would allow only read access. So you can see then how classifying data can facilitate permissions management, especially on a larger scale. Having an understanding of how Windows file system permissions are assigned is crucial in case we have to perform a file system audit as part of our IS audit to make sure that the appropriate permissions have been assigned. Here in Windows, I'm going to start by going to the Start menu and opening up Active Directory users and computers. I want to take a look at existing users and groups within the Microsoft Active Directory environment. So my domain is called fakedomain1.local. I've got an organizational unit, or an OU, called Boston, in which I've created a user called Cody Blackwell. I've also got a group called Project Managers. I'm going to double click on Project Managers and look at the members, and indeed we can see user Cody Blackwell is a member of this group. Normally when we assign permissions, we do it at the group level. It's easier to manage on a larger scale rather than assigning permissions to individuals. So having seen that, let's close Active Directory users and computers, and let's go into the file system on this file server. I'm interested in drive C, where I've got a projects folder. It contains a few sample project files. I want to set permissions at the projects folder level, so I'm going to right click on it and I'm going to choose properties. Now there are two sets of permissions that we need to consider here. The sharing permissions, which apply when accessing this folder over the network, and then the local NTFS security permissions, which apply when accessing the data over the network, as well as even locally on this machine itself. Let's start by turning on sharing. So I'm going to go to the Sharing tab, click on Advanced Sharing, and then I'm going to share this folder. It'll pick up the same share name as the folder name in the local file system. That's what it will be seen as across the network on this server. Then I'm going to click Permissions. The default is that the built-in everyone group is added here with read permissions. The thing you have to bear in mind is that when you are combining share permissions, which is what we're looking at right now, and then the NTFS permissions we'll look at in a moment, when you combine the two of them, if there are collisions, meaning if we've got a user that's got, let's say, read permissions here at the share level, and the same user has read and write permissions at the NTFS security level, well, the most restrictive would apply. And so the user would end up only having read permissions. So commonly, what will be employed as a strategy by administrators here is they will add something like the everyone group or something else. For example, I'll click Add, and I'll look for, let's say, our project managers group. We would add it, for example, with full control. Now, you might say, well, I don't quite want them to have that many permissions necessarily to everything under the projects folder. Maybe some things, but not all. Well, the great thing is you can then go into the NTFS security permissions even for individual files, because you can't set these permissions at the file level. These are for shared folders. And then you could have lesser permissions, because remember, when you combine them, the most restrictive applies. So let's leave project managers here with full control, and OK. Let's go into security, and here, let me just remove the built-in users group. I'm going to click Edit, and I'm going to select that users group and remove it. It says you can't do it because it's being inherited from above. Oh, okay. Well, that's no problem. What we're going to do is go into Advanced and disable inheritance. And we're going to basically copy what would have been inherited from above to this level. So convert inherited permissions. Okay. And now I'm going to go into Edit again and going to select users and remove it because it now has been copied here as an individual explicit entry at this level. And what I want to do is add project managers. So I'm going to click check names. There's project managers. And for project managers, maybe I'll just leave read and execute and list folder contents and read. So there's no write permissions or anything like that. There's no modify, no full control. But what's interesting is, remember, at the share level, the same group for this same folder has full control. But the key is that when you combine the two types of permissions, the most restrictive applies. We're going to check that out because I'm going to click OK and close. So now let's go into a file in here because these files will have inherited what we just set at the project's folder level. So if I go, let's say, into Project C and right-click and go into Properties, and let's say we go into Security and Advanced, I want to look at the effective access for a user, like a user that we had added to the project managers group. And you'll recall that that user's name was Cody Blackwell. So I'm going to click Select a User. I'll just type in Cody. I'll click Check Names. Found the user. OK. And I want to view effective access. Down below, notice full control is not effective because the most restrictive of the two sets of permissions applies. But they have the ability to look through folders and basically read the file. So this is something to bear in mind when we are auditing file system access in the Windows environment. Sometimes when you're conducting an IS audit, you need to check the file system of a given host to check out the permission set, to make sure that the principle of least privilege is being followed so that people only have access that they actually require to do their jobs, especially when it comes to sensitive data. Here in Linux, I've got a folder I've already created called projects, and if I type ls to list the contents of that folder, I've got 4 sample project files. If I type ls-l for long listing, I see further details for each of these entries, including seeing the permission set. So let's take a look at the file here called project 2. Now we've got 3 permissions that we can work with potentially: read, write, and the one that we don't see here is X for execute, where read naturally allows reading the contents of a file, writing allows writing to it, including deleting it, and X would be to execute it if it's a binary program file, or perhaps even a shell script that you've written in Linux. Now the first 3 permission placeholders here apply to the owner of the file. In this case, user root would have read and write permissions to this file, project 2. The second potential set of 3 permissions applies to the group associated with the file, which is also called root. And everybody else would get the last 3 potential permissions. In this case, it's only read. Now we could change this. Let's say that we want the group root to have additional permissions, or we even want to change the group. Why don't we even change the group? Let's build a group here. I'm going to use the sudo prefix because I'm going to be running a series of commands here that require elevated permissions. So sudo group add, let's say I add a group called human resources, HR. So I've now got a group called HR. Now I also want to add a new user here, so I'm going to run user add. Let's say I add a user called user1, u1, and I want to add them to that group, so -ghr. Now notice I get a permission denied message because I didn't prefix the command with sudo. That's an elevated privilege type of command, adding a user account. So I'll use the arrow key to bring up the previous command and add sudo in front of it, and everything's hunky-dory. Now at this point, what I want to do is set the group association for project 2 from what it currently is, the root group, to the HR group. And we could do that using the change group command. So sudo chgrp change group HR, and I want to do that for the file here called project 2. So now if I do an ls-l, notice that HR is now listed as the group associated with the project 2 file, which means that members of the HR group now will assume the permissions assigned at the group level, the middle 3 permissions, which in this case is only read. We don't have write listed here. Now if I wanted to change the entire permission set for that file, I could do that using the change mode or chmod command. So let's say that what I want to do is change the permission so that the HR group has read and write, but the owner, which is listed here as user root, has read, write, and execute if we're an executable type of file. So now I'm going to add a 7. Now the number 7 means that we are assigning read, write, and execute, because in Linux, read always has a numeric value of 4, write 2, and execute 1. So 4 plus 2 plus 1 is 7. So I'm setting that, in this case, I will be, for the project 2 file. Currently only read and write, which has a value of 6, is set. The next thing I want to do is add a number 6, which is for the next permission set, which applies in this case to the group, HR. And 6 means I want not only read, because read has a value of 4, but also write, which has a value of 2. And of course, 4 plus 2 is 6. But then I want to add a 0 because I don't want any permissions assigned to anyone other than the root user and members of the HR group. So that's why I put a 0 there. Then the subject in this case is project 2. Now, of course, I could specify multiple files using wildcards or an entire subdirectory structure recursively, but here I'm doing it just to a single file, project 2. And if we take a look at that file with ls-l, first of all, it's green. This distribution of Linux turns files green when they are executable. And we can see here, read, write, and execute, that's 7, 4 plus 2 plus 1, is now applied to the owning user, which is root, and read and execute, value of 6, right, 4 plus 2, is now assigned for the HR group. So any members of the HR group will assume those permissions on that file. Classifying data, including files on file servers, is important at the enterprise level for proper IT governance and security management. Here on my Windows server, I've got a folder on drive C called Sensitive, in which I've got two sample files, the first of which contains nothing in this case, but the second of which contains some text, credit card number. What we're going to do is use the Windows File Server Resource Manager, FSRM, and we're going to configure it on a scheduled basis to come out and look at this location on the hard disk for files that contain credit card number and flag them as being sensitive. Now we can do that, which can even then further facilitate permissions management down the road later. So to get started here on the server, I need to make sure the File Server Resource Manager portion is installed. So to do that, I'm going to go to the Start menu on the server and fire up the Server Manager tool. Here in the Server Manager, I'm going to click Add Roles and Features for this local server. I'll click Next a few times to accept the defaults of installing it on this server. And on the Select Server Roles screen, I'm interested in File and Storage Services. And if I drill down under File and iSCSI Services, I'm primarily interested in the File Server Resource Manager. Notice that role service is already checked on, which means it's already installed, which is perfect. So I'm going to cancel out of here. The next thing I'll do under the Tools menu here is run the File Server Resource Manager GUI tool. I'm interested in Classification Management, where I'm going to go to Classification Rules. This is where we define where to look, what to look for, and how to flag or tag files accordingly. So I'm going to right-click on Classification Rules and choose Create Classification Rule. Now here it says there are no classification properties available. So we need to first create what's called a classification property right above. So if I right-click on Classification Property to create a local property, I can create something. So for example, I'm going to add an item here called Credit Card. This is a property, a resource property, and it's going to be a yes/no type of property. Although notice we've got other options, date and time, number, list, string. So either yes or no, it is a credit card type of sensitive file. So now that shows up in the list of our classification properties. Now this time, when we right-click on Classification Rules to build a new one, we have no problems. So I'm going to call this Seek Credit Card Info. And the scope in this case, let's say, will not be certain file types throughout the entire server, but rather I'll click Add, and I'll tell it that I'm only interested in looking at drive C, and in our particular example, in a folder called Sensitive, and I'll click OK. Then I'll click Classification. I'm going to look at the content within files in that location, and notice here we have our property now. That's why the property had to be built before we built this rule. So credit card will be set to yes, but upon which condition? Well, that's where I'm going to click Configure. And basically, I'm going to tell it that I want to look for a string, and specifically, I'm looking for credit card number within the file. Now, obviously, you have to be careful because this has to have been put into files consistently in order for this to work. But I'm looking for at least one occurrence of that within files in the location I specified, so I'll click OK. And at this point, I'll click OK. We've now got our classification rule. The next thing to consider is when will that be triggered? Because as you might imagine, the contents of a file server will be changed often as people are working, where they're adding, removing, or maybe even modifying files that already exist on the server. So here's our rule, Seek Credit Card Info. I could choose to manually run this at any point in time, or I could, of course, set a schedule for it. So over on the right, I've got Configure Classification Schedule, so I could do that and turn on the schedule and determine when I want this to run. But in this example, I'm simply going to choose to run classification with all rules, and I'll just choose wait for classification to complete in the foreground, and then I'll click OK. And we can see the activity down at the bottom. It's starting to process the file system locations looking for what we've configured it to look for. Once the classification rule has finished executing, we get this little HTML web report where we can see the classification for files under C sensitive. And it says that we've got one file that met that. And actually, if we flip out into the file system, and let's say we take a look at the first sample file, which contained nothing in it, and if we right-click and go into the properties, the classification tab is available because we installed the File Server Resource Manager role service. It was actually already installed, but notice credit card is set to a value of none. Of course, we can manually set it, but the whole point is to have this automated on a scheduled basis. And if I look at sample file 2 and its properties, and under classification, notice it's automatically been set to the credit card property with the value of yes, because it does contain what we were looking for. It contains the text credit card number. And so this is a simple example of how automating the classification of data can be very helpful, because at this point we could set permissions based on things that are flagged as credit card yes. We could write a script that would take those files and encrypt them or put them in a specific location, and so on. Microsoft Windows Server 2012 introduced a new feature called Dynamic Access Control, DAC, which really meant that we could look at attributes of things like Active Directory users to determine whether or not they should have specific permissions assigned to files in the file system. So to get started with this type of configuration here on my Windows server, I'm going to go to the Start menu, and I'm going to go down under my Windows Administrative Tools, and I'm going to fire up the Active Directory Administrative Center. So you can't use Active Directory users in computers, the older tool, to configure Dynamic Access Control. It's got to be this one. So you can see Dynamic Access Control is actually listed over here on the left. And there are a number of things that we need to be aware of here that we need to configure. I'm going to start with Resource Properties. Here we have a bunch of properties that are automatically included as part of the configuration of Active Directory, one of which is called Department. So let's say that we want to take a look at files flagged with a specific department value and then allow permissions based on that. So I'm going to right-click on Department and enable that property. And notice the icon changes to reflect that it is now enabled. Now on this same server, I'm going to go into the Server Manager tool. This is a file server, and I've already installed the File Server Resource Manager role service. So like if I were to go to Add Roles and Features and go through on this server, when I look at the Select Server Roles, under File and Storage Services, File and iSCSI Services, you can see clearly the File Server Resource Manager component, or role service, is installed. Now why is that relevant? Because we need that tool. If I go to the Tools menu and fire up the File Server Resource Manager, it will show me under Classification Management, Classification Properties, anything that's been configured for properties. And if I actually click refresh, notice that Department was just enabled in Active Directory. And so it shows up here. Why is that relevant? Well, because we can build classification rules to automate classifying files and flagging them with a certain department value. So for instance, if I go to classification rules, I'm going to right click and create a new one, and I'm going to put here seek sensitive data. And the scope here, let's say, is going to be to go onto drive C on this file server and to go looking beginning at the sensitive folder level. And for classification, I'm looking at the content of files, and what I want to do is select a department. Now these values come from Active Directory. I could have edited it, but remember how we enabled department in Active Directory? Well, it automatically includes these. So what I want to do here is I want to make sure I assign any data that is considered as sensitive to the finance department. Now I have to click configure to determine exactly what that means. So for example, I could use a string to look for something specific, or a regular expression if I'm looking for specific placeholders like social security numbers and whatnot. I'm going to look here for credit card number. That text must be in the file in order for it to be flagged as finance department. And after I've done that, I will click OK and OK. So now I've got this seek sensitive data rule, and I could schedule it by configuring a classification schedule, or I could just run the classification on the server right now with all rules, which I'm going to do. I'm going to manually run it. I'll click OK. I'm only manually running it so we can force it to happen now. Realistically, that should be scheduled to happen in an automated fashion. And we can see it's going through that location based on our criteria with our rules, and it's going to flag things accordingly. Once it's completed, we're going to check the file system just to make sure that any files that contained our criteria, credit card number, are flagged with Department of Finance. So it's just about done. Well, looks like it's starting to process files now, and then we'll be able to take a peek. So now that it's complete, it says it's not running. I'm going to go into the file system on this file server. Let's just go under drive C under that location sensitive. This first sample file doesn't have anything in it, and so if I look at the properties of that file under classification, credit card is set to none. Fair enough. Well, actually, credit card is not what we configured, was it? It was the department. The department is set to none. However, in our second file, which does contain our search criteria, credit card number, if we right-click and look at the properties of it under classification, well, department is set to finance. So that works. Now let's go back into the Active Directory Administrative Center tool. So we added department. We now know how it will flag files as Department of Finance. So now what I want to do is I want to configure a central access rule. So I'm going to go look at my central access rules. Now, by the way, what we could do here is view this in a tree form, so we can drill down this way. And I'm going to right-click and create a new central access rule. Now, what I want to do is set permissions for finance files. Okay, what's the target resource? Well, a resource in this context is a file or a folder in the file system. So I'm going to click Edit, and I'm going to add a condition. And notice here, it knows what's available, department that we configured here in Active Directory. So I can say if the department equals a value of, and then I can specify what I want here, finance. This is interesting. Okay, so what if we have files that are flagged as being in the Department of Finance? Okay, so what's going to happen now? Well, then I can set current permissions. So what I want to do is actually set the permissions based on the fact that those files are flagged as Finance Department. So let's just scroll down a little bit. I'll click Edit for the permissions. And maybe what I'll do is click Add, and I'll select a principal. Maybe I will check for the project managers group that I've created in Active Directory and make sure that those members have read and write. So that's very interesting. So I'm going to go ahead and click OK and OK. So if the file is flagged as being a finance department file, I want project managers to have read and write permissions to it. Perfect. Okay. Now the next thing I need to do is build a central access policy. So I'm going to right click on that. And what I'm going to do is say set finance permissions. What I have to do is add one or more of the rules such as we just created to this policy. This policy you can think of as an umbrella or a container that actually contains or consists of central access rules. So here we go, set permissions for finance. That's the rule we just made a moment ago. Okay, we've now got that. The last order of business is going to be to set some group policy settings to deploy this to the appropriate file servers we want affected with this permission granting scheme through dynamic access control. So I'm going to go into group policy management. I'll just fire that up here from within Server Manager. And I want this in the default domain policy, which will apply to all file servers by default in the entire domain. So I'll right-click and edit that. That should open the group policy editor where we can actually get to the individual settings to make the change. And the change I'm talking about here is at the computer configuration level. So if I expand policies, and then if I drill down under Windows settings, security settings, file system, central access policy, nothing's here. So I'm going to go ahead and manage my policies. Here it is, set finance permissions. It found it in Active Directory, add it, OK, done. So when group policy refreshes, in this case for the default domain policy for file servers in the domain, then these settings will be known. So that means that the members of the project managers group will have read and write access to files on all file servers flagged as department equals finance. In this exercise, you will first explain when identity federation should be used. Next, you will create a Microsoft Azure Active Directory user called Cody Blackwell. You will then enable multi-factor authentication for user Cody Blackwell in Microsoft Azure. The last thing you will do is use the Microsoft File Server Resource Manager component to flag files everywhere on Drive C that might contain the text blood type, and you will flag them with the label of PHI for protected health information. We want that set to a value of yes. So now's a good time to pause this video and think about each of these 4 items and then come back to view the solutions. Identity federation applies to authenticating users, devices, and even software entities, apps. It allows us to have trust established across multiple systems or environments. Now, what kind of trust are we talking about? Authentication trust, where a user authenticated in one environment is trusted to access resources in a different environment. So you could say that we are connecting identity management systems together in a sense of the word. Now, identities and attributes this way are stored only once. This means that if you've got 2 companies maybe that are in the process of merging together, well, if we need users in company A to access resources in company B, we don't necessarily have to recreate all the user accounts for those users in company A. We don't have to recreate them in company B. Instead, we can enable identity federation to establish that trust. So this way we don't have to recreate user accounts in the other system. And we can even enable single sign-on so that users don't have to keep entering their credentials as they access different resources. As long as they've successfully authenticated once, that can be configured to be all that is required. The next thing I need to do is to create a user named Cody Blackwell in Microsoft Azure Active Directory. So here in the Azure portal, I'm going to go to Azure Active Directory in the left-hand navigator, and I'll click on Users. I'm going to click New User, and this is where I'm going to specify user Cody Blackwell. So Cody Blackwell, and the username will be cblackwell@ and then the DNS domain name for our Active Directory instance. After I've done that, the password is set automatically here. I can choose to show it, and I can reset it at any time. And now I'll click Create. So we've now got a user created called Cody Blackwell. And if I click on that account, we can see everything looks good. We can see the full name. We can reset the password. The next thing I want to do is click Multi-Factor Authentication up at the top. Here we'll see who currently has it enabled versus who does not. So notice that user Jonathan Gold does have MFA, multi-factor authentication, enforced. Cody Blackwell does not. So I'm going to turn on Cody Blackwell, and I'll click Enable. Enable multi-factor authentication, and that's it. So the next time Cody Blackwell signs in, he will have to specify how he would like to be contacted, such as through a phone call or through an SMS text message, in addition to knowing a username and password, which is what gives us multi-factor authentication in this particular case. The next thing I need to do is use the File Server Resource Manager tool so that we can configure this file server to look for files on Drive C that contain the text blood type, and if so, label it as protected health information. So to get started, I'm going to go to Classification Properties and create a local property. And the local property I'm going to create is going to be called PHI for protected health information. So either a file is flagged as PHI yes or no. Perfect. That's what I want there. Now I have to build a rule that uses that classification property. So to do that, I'm going to right-click on Classification Rules and choose Create Classification Rule. What I want to do here is look for protected health information, PHI, the scope of which is going to include all of Drive C. So I'll click Add, and I want to look through all files on Drive C or wherever the location of the files might be. For classification, we are looking at the content of files And we are going to be setting Pci to a value of yes if a condition is met. And we go to configure down below to set that condition. So what we're going to be doing here is looking for a string of blood type. So I'm going to type in blood type. Notice you can also specify case-sensitive comparisons. And there's got to be at least one occurrence. Perfect, okay, and okay. Now the next thing we could do is configure a schedule on which that will be run, but I'm just going to manually run it right now. So I'll click Run Classification with all rules, run it in the background, okay. And we can kind of monitor the progress down below here and see how it's doing. Once the rule has been evaluated against the file system, if we take a look at a sample file here on drive C that's got, in this case, blood type, and if I right-click on it to view its properties, if I poke under the Classification tab, I'll see that it's automatically set Protected Health Information, or PHI, to a value of yes. A service level agreement, or an SLA, is a contractual document between a service provider and a service consumer. So it could be between a customer and a cloud service provider. Cloud service provider is also called a CSP. It could be between a customer and an internet service provider, an ISP. We could even have a service level agreement between the sales department and an organization and the IT department within that same organization for usage of internal IT resources. In the case of cloud computing, each cloud service has its own service level agreement. So cloud storage has an SLA that is separate and distinct from running virtual machines in that same cloud provider environment. Service level agreements are documents that have various sections. The first part of a service level agreement is a definition of terms. For terms such as uptime or downtime or a monthly uptime percentage, that type of thing. Service credits are then specified within the service level agreement, so that if the provider doesn't keep up their end of the bargain, such as 99.99% uptime on a monthly basis, then service credits are offered to the customer to reduce the cost for future use of cloud services. And often there might be further details that the customer has to redeem those service credits within a certain number of days and that they are non-transferable, and so on. Then there are SLA exclusions which will be listed. That normally includes things such as acts of nature, labor disputes, or acts of terrorism. Service level agreements are really about performance and reliability. And so the percentage of uptime within a calendar month or year is often expressed, such as 99.99%. So that if it turns out that we have less than 99.99%, we might end up getting, as a cloud customer, a 3-day service credit. Or if it's less than 95.00%, maybe a 7-day service credit for the use of cloud services. Part of an IS audit can sometimes encompass looking at how well things are performing, IT systems that support business processes. But before we can determine whether something is or is not performing properly, we have to know what's normal. What are the normal performance indicators that tell us things are running smoothly? And we do that by establishing a baseline of normal performance activity. And to do that here in the Windows Server environment, I'm going to start by going to the Start menu. And I'm going to search for PER, and I'm going to choose the Performance Monitor tool so that we can establish a baseline. To do that, I'm going to expand Data Collector Sets on the left. I'll right-click User Define, and I'll choose New Data Collector Set. I'm going to call it Establish Baseline. I'm going to create this manually, and then I'll choose Next. And I want to look at Performance Counter Logged Information. Then I'll click Next. And now I have to specify which specific performance counter metrics I am interested in looking at in order to gauge whether performance is acceptable or not, or in this case, to set up a baseline. So I'm going to click Add. And here I have an alphabetical list of counters. I'm interested in processor utilization, the total. So that's already selected here. I'll click Add. And from here I could continue scrolling through the list and then choosing the specific counters that I want to use to monitor to establish a baseline of normal activity. I'm also interested in physical disk performance. So maybe what I'll do is look at the average disk queue length. Disk queue length is important because it'll tell me how many disk I/O requests have been queued up because the disk subsystem is already busy. Naturally, a higher value is not a good thing. So I'm going to select that total average disk queue length and add that. So I would continue adding the counters that are of interest for establishing a baseline. I'm going to go with these two and I'll click OK. And what I want to do here is specify that the sampling interval, let's say, is every 15 minutes because I'll let it run for a while. I'll accept the default location where the data will be saved and I'll click Next. And I'm going to choose to open the properties for this data collector set and then I'll click Finish. So the properties have opened up, and why I did that is because I want to go into the scheduling. I want to determine when this is going to happen. So I'm going to specify a beginning date and an expiration date for gathering this information. So maybe we'll do it for a week to get a general sense of what those performance counters should look like under normal conditions. And it'll happen on every day of the week, so I'll click OK and OK. So now if I kind of take a look at my user-defined data collector sets on the left, you can see I've got the established baseline item here. Now, I could wait for the schedule, but of course, I could also start that data collector set at any point in time. So I can manually start it. We can see now it's actually begun. And of course, we wouldn't normally manually do this, but we can do it if we want to gather performance metrics now, and it takes time. So of course, what I can then do is click on that data collector set if I ever want to take a look and make changes to the configuration. Now, the results of running that will show up down here under Reports on the left. And if I go under User Defined, here's Established Baseline. Now, of course, the report's not going to be complete. We've just started it, but if I double-click to open it up, we can see it's telling us now that it's collecting data. So this is where we can go to view the result of determining what normal performance is, in our case for over a week, by looking at those specific performance counters. The Windows Server operating system has a number of built-in tools that allow you to monitor the performance of a variety of aspects of that particular host, whether it's a physical server or even a virtual machine. So the first thing I'm going to do here in my Windows Server environment is go to the Start menu, and I'm going to fire up the Performance Monitor tool. Now, in the Performance Monitor tool on the left under Monitoring Tools, I'm going to click on Performance Monitor. And here we can see a real-time graph where by default it is showing me information related to the percent processor time for all processors, so I get a sense of how busy that aspect of the machine is. And we can see here on the graph that we don't have a very busy server here. However, I can click the green plus sign at the top to add other counters that I'm interested in monitoring. So for instance, maybe I'll scroll up in this alphabetical list of counters, and under physical disk, I'm interested in what's called the average disk queue length. The disk queue is an area where disk I/O requests get placed when the disk subsystem is busy doing something right now. And having a high value for the average disk queue length is not great. It means you probably have too much disk I/O activity and your machine can't properly handle it. But the question is, what is that magic number? Does it mean if I have 10 for a value of average disk queue length, things are bad, or is it 10,000? And the answer is, there is no specific answer. It depends on what is acceptable for performance based on the workload running on that host. So I'm going to go ahead and add that counter, and I'll click OK. Now, if I scroll down at the bottom here in the legend, I can see the average disk queue length is listed here. However, it's also got a red line, which is going to make it hard to distinguish from the existing percent process utilization. So I'm going to double click on that and change the color, let's say to a dark blue. I can even change the width or the thickness of that line as it's graphed. And now we can see it's very, very low. Just for fun, why don't we generate some disk I/O activity to see how that affects what's being graphed here for performance. So I'm just going to go into the Windows Explorer on this host and copy a few files. So maybe I'll just go into this PC, maybe I'll just go into Drive C, and I'll just select perf logs, copy it, and then paste it a few times. So we're generating some disk I/O activity. And notice here, sure enough, it indicates with our dark blue line for the average disk queue length that there's some activity. Now, you might say, well, that's normal. The machine is working, it's doing what it should be doing, it's dealing with disk I/O requests, and that's correct. So this is important because what we're seeing here is that, well, if I've got a value of 60 in terms of the amount of items for percentage for average disk queue length, that is not a problem on this particular host. It's just doing what it should be doing. And so it's going to be important then to determine what are the acceptable ranges, because you have to know how to interpret what is being graphed. The other thing to bear in mind is that when I click the plus sign, the green plus sign to add performance counters I want to watch, by default I'm looking at the local computer. But depending on my network environment, I can specify other computers out on the network that will allow this kind of remote access. And so from a central host, for example, I might monitor the average disk queue length of multiple Windows servers. That way I could have it all in one place at one time. Now, of course, there are numerous other ways that we can centrally monitor performance metrics, enterprise class tools. Here we're just looking at what's built in to the Windows operating system. Just as the Windows operating system includes some built-in tools related to performance monitoring, so too does the Linux operating system. Here in Ubuntu Linux, we have a number of commands that we can issue to check out the performance of the host. Now, the first thing we should also be aware of is the viewing of manual or help pages in Linux, if you're not sure how to use a lot of these monitoring tools. Now, certainly Linux has performance monitoring tools that can run in the GUI, if you're running the GUI on Linux, but here we're going to focus on the command line. So the first thing I'm going to do here is run the man command for manual page space ps. ps is a built-in Linux command. What I'm trying to do here is get a help page that tells me how to use that command. Now when I do that, it tells me that the ps command gives me information about running processes, which can be very important to determine which of those processes, for example, might be using more CPU time slices or RAM than it should be using really, and that could be a problem with performance. So I can see here as I go down, it explains this command and how to use it. So I'm going to go ahead and press Q to quit out of there. Now if I simply type PS and press enter, then it lists the processes running within my current user login shell. So I can see my bash shell environment, which is my command line environment itself, in which I am working, as well as me running the PS command. But that's all I'm really seeing. I'm seeing that along with the terminal I'm connected to, so sudo terminal 0, the current terminal I'm in, and I can also see the process ID assigned by the Linux kernel for each of those running processes. But there's not really a whole lot there, is there? So what I'm going to do then is clear the screen, and I'm going to run ps space AUX. Now, these command line parameters means that I want to view all user processes, even those, though, that aren't tied to the user, that aren't tied to the user terminal. That's specifically what the X means. And I can find this out by looking at the man page for PS. The other thing to watch out for, of course, in Linux is remember that case sensitivity is an issue. So it's important that in this particular case, everything here be typed in lowercase letters. So I'm going to go ahead and run this, but I'm going to pipe it to the more command to stop after the first screen full of output, and I'll press enter. So now what we have is a list of all kinds of commands or running processes, and we can see a number of important items. Now, what does that mean? What do you mean important items? Well, one is the amount of CPU time it's using. Here, we don't have much going on. Nothing here is really using much CPU time. Also, notably, what's important is going to be the amount of memory, percentage amount of memory being used. So far, it doesn't look like we have anything that's too heavy on utilization. We have a couple of items here. So we've got a Python type of code module that seems to be using a bit of memory. We see the same thing also down here listed a bit further. So it's important to be able to look at this and to determine, well, what exactly is consuming resources if we're having performance issues here. I'm going to press Q to get out of that output, and I'll type clear to clear the screen. Another important command related to performance built into Linux is the top command. So I'm going to look at the manual page for the top command. And again, it tells me it displays Linux processes. And then as we go down through the manual page, it starts giving me all the details related to how to use this command. So I'm going to press Q to quit. I'll clear the screen again, and I'm simply going to run the top command. No parameters. So what happens is we get a lot of statistics up at the top, like the number of users connected to this host, the overall load average sample over the last few minutes, the number of tasks running in the background in total. We can also see some details like the overall CPU utilization, and also as we go through this, we can see the amount of memory that is available, the amount of free memory, the amount of memory that is being used, and down below we have a real-time updating list of a number of running processes. These are the top running processes that are consuming CPU and memory resources, as we can see here. So I can see the actual command. Notice it's changing in real time. I can see the command. I can see things like the process ID or the PID. That PID can be important because it uniquely identifies that process running right now. Now, the next time that process is launched on this host, it might have a different PID, but the PID can be important if you, for example, want to use the kill command to kill a specific process that you don't want running anymore because it's consuming too many resources. We can also see the user under which this is running, the specific process is running. Also, what we can do here is I can change the display items here. If I press, for example, the D for delay, I can change the delay from every 3 seconds, let's say, to every 1. Now it's updating every 1 second instead of the default of every 3, so the list is changing. So if I wanted to change that back, I could press D for delay and change that back to 3 so that the delay is now changed again. But also notice here the fields that we have available from left to right. The process ID, the user, we've got the priority value, what's called the nice value, virtual memory, and so on. Well, I might not care about some of these things, and so I can remove them from the display. I'm going to press F for fields. Now, any fields that currently have an asterisk to the left of them are currently being displayed. However, I can change that. So for example, I want to see the process ID and the user under which something is running, but I don't care about the priority value, so I'm going to highlight that using the arrow keys and press spacebar. Notice now it kind of dims out and we lose the asterisk. It will no longer be displayed. Same with the nice value and a lot of this other stuff I don't really want to see. So now I've got a very small limited number of items that I can control in the viewing output of the top command. Now if I press Q for quit to get back out to where I was previously, notice all I see is the process ID, the user under which a process is running, percent CPU and memory time, and the command itself. So this way it can facilitate me monitoring or looking at the performance of this host by only viewing the things that I deem are relevant. When you deploy resources like virtual machines in a cloud computing environment, you can not only go into the virtual machine itself, such as using SSH for Linux or RDP for Windows, and view the performance within the OS itself, but you can also view them externally using cloud provider supplied mechanisms. So here in Microsoft Azure, I'm going to start in the Azure portal, the web GUI, by clicking the virtual machines view over on the left. Here I've got a running virtual machine called WinServe 2016-1. I'm going to click on it. Now the first thing I notice is that when I click on it, it opens up the properties blade here on the left, and I'm looking at the overview of the virtual machine where I can see things like the fact that it's running its public and private IP address, the network it's deployed into, and so on. However, what I'm interested in also viewing here is scrolling down and looking at the performance data for this particular virtual machine. The default is it's showing me that information over the last hour, but certainly I can change it over 6, 12 hours, 1 day, 7 days, even 30 days. So I can see the CPU average, and here because I'm looking at it over the last hour, I can see the specific timestamps on today where that applies. I can also see the overall values of where that might be kicking in. And if I point to any of these specific data points, I can see exactly what those values were at a given point in time as it is graphed. Now at the same time, besides CPU average, I can also see the network traffic in and out at the total level for this particular virtual machine. And again, it's tied to a time. That can be very important when it comes to looking at the performance of a cloud virtual machine that might support an important line of business application. And I can also see the number of disk operations per second, which could be indicative of perhaps a problem with disk I/O, where we might have to essentially change the details for the virtual machine to use a faster underlying disk subsystem from the cloud provider. And of course, when you start making changes such as to make things quicker or faster, it means that you will be incurring more cost. But such is the nature of the beast. So we've got some of these items then that are available for us to view here over a period of time. And if I click on any one of these, like if I click on the CPU, then I can see the CPU average chart we have zoomed into. Now notice I've also got options where I can also change the chart type. So if I'm more interested, let's say, in an area chart, or if I want to view it as a bar chart, then we can also view it in numerous different ways. We also have the option of making sure that we are refreshing this and viewing the most up-to-date information. It's one thing to be able to dig into cloud resources to manually check out the performance of them, things like virtual machines or cloud-hosted web apps or cloud-based storage. But we also have the ability of configuring performance alerts. So based on our specific configuration in our particular environment, we might want to be notified when certain performance metrics exceed a configured threshold. So here in Microsoft Azure, I'm going to do that for a virtual machine and its CPU utilization. I'm going to start by going to the virtual machines view on the left, and I'm going to click on a running virtual machine. Now in the overview part of the properties blade, I can see I've got, among other things, the CPU average utilization that's been charted here. And I'm going to go ahead and click on it to zoom into that chart. What I can do is then click New Alert Rule. When I click that, I have to configure exactly what I'm interested in, such as the resource. Here, it's the virtual machine that we started this process from. Then, the condition must be specified. So I'm going to click Add a Condition, and I'm interested in the percentage CPU. Now, as I scroll further down, I have to determine what the operator is, greater than, less than, greater than or equal to. I'm going to say that if the average CPU utilization is greater than 85%, and I can also determine the period, which is here 5 minutes. Now it's going to check this every 1 minute. So if I've got that type of utilization beyond 85% over 5 minutes, that is my condition that is alarming in my example, in my particular case for that virtual machine. So I'm going to make sure that's the only condition I have there. Then I have to determine what action I want to occur. There's no action group, as it's called, configured. So I'm going to create a new action group to determine what I want to happen. I'll call it AG1 for action group 1. Same thing for the short name. And the next thing I'm going to do here is determine what the action is. So for the action type, I can send an email notification, an SMS text notification. I can trigger the execution of what's called an Azure function. That's a chunk of custom code I would have built in the Azure cloud. I can run a logic app, I can run a webhook, which is a URL, and so on. So I'm going to choose the email SMS notification type, and I'm going to type in email as the action name, and then over on the right I've got the details. So I'm going to put in notify admins via email. And at this point I'm going to turn on the check mark for email, and this is where I would specify the email addresses of the administrators. So I'm just going to fill in a sample email address that doesn't actually exist. And after I've done this, I can then click OK, and I will have configured my action group. I'll click OK again. So now we have configured a specific alert so that we will be notified once that threshold is violated, that CPU utilization. So now that we've got that done, let's go down and just configure this a little bit further. I'm going to call this CPU alert 1, that's the name of the alert details, and I'll just leave the default severity of 3. Enable the rule upon creation is set to yes, which is great. We definitely want to have that as being done. And then I'll just click Create Alert Rule, and it's now being created. The purpose of change management is to control risk related with implementing a change so that we minimize disruptions. From an IS auditor's perspective, we need to make sure that we review the change management process so that our auditee, our client, can rest assured that the change management process is done in a controlled manner, that it is continuously monitored, and also that it's compliant with good practices. But how do we make sure that this is true? We do it by enacting standard procedures for implementing change that are adhered to. So what this means is we end up with reduced risk related to IT changes because we have a structured approach as opposed to just a randomized ad hoc approach to implementing changes. Now, this also means increased efficiency with which the change is planned all the way through to implemented and evaluated and monitored. It also means we are better assured to be in a position to be compliant with related laws and regulations. It can also mean reduced IT-related downtime, because we don't have people randomly implementing changes without going through a proper, thorough procedure, which could result in downtime of a system as a result of a change. So the focus then, from the IS auditor's perspective, is on the process of implementing change. Is it a good process? Now, some types of IT changes would include to hardware, whether we're talking about making configuration changes, applying firmware updates, or swapping out hardware. We could also have changes to software, which could include reconfiguring stations or maybe introducing a new drive mapping to a certain select number of client stations or removing services that are no longer needed. We could also have procedural types of changes on how the help desk goes about resetting a user password or helping users troubleshoot printing issues. And of course, we could also have network types of changes, which might include changing firewall rules. And again, that's not something you just want randomly done without careful consideration, because if all of a sudden someone randomly changes firewall rules, an administrator, then it means it might block some traffic that legitimately might need to get in or out of a network or a host. So that's why we need a controlled, structured approach to making changes. So the change management event flow begins with a change request creation. And this can be done through an automated system, such as a ticketing system that might be used for the help desk, but that also allows things like change requests. Now, then we have change request evaluation. This is something that would be done by the parties that are responsible for ensuring that change requests are valid and should actually go through. And that means taking a look at the legitimacy of the change, what the benefit is and how it aligns with business goals, and of course, what the backup plan is. What if something negative happens? What's plan B to reduce downtime or inavailability of data? Next, assuming everything checks out, the change request board, which could be one or more persons tasked with doing just this, will take a look at that request and approve it so it can actually go ahead and be implemented, which is the next step. The next step is to implement the change now that it's been properly approved, and that change has to be implemented in accordance with the original change request plan, which has been approved. We don't want to stray from that. And then making a review of the change, such as performing some regression tests to ensure nothing else was affected by that change. There is a common misconception that change and configuration management are exactly the same thing, when in fact they are not. I came across this quote by Praveen Malik, a certified project management professional, that I thought was great to help easily distinguish the difference between the two, and I'll read it now. It says, a machine, for example a computer, is made up of components or parts. Each part is arranged in a specific configuration to make the machine whole, to make it usable. In simple terms, configuration means arrangement of the parts, while change means modification of the parts or the whole machine. So we can see the distinction. In other words, we might swap out entire network components like routers or switches. That's change management. But if we want to modify firewall rules on an existing router that's already out on the network, that would be configuration management. Configuration management components begin with the Configuration Management System, or CMS. This comes in the form of software, enterprise-class centralized software, that allows us to work with one or more configuration management databases, the next component, CMDBs. And inside the configuration management database, we have a number of configuration items, or CIs. So imagine that we've got a configuration management system that we use to centrally manage mobile devices. So we would have a CMS that does that, a product. We would have a CMDB that contains information about all of those mobile devices. The actual fact that we have a record of mobile devices and their inventory, those are configuration items or CIs within the CMDB. So if I've got 100 Android smartphones and 100 iPhones for a total of 200, I would have at least 200 CIs in the CMDB, one for each inventory device. And then if I have things like mobile device application configurations that I'm deploying through my CMS, those are other configuration items. If I import license information for those apps and the usage, that is another type of configuration item or CI. So depending on exactly which product you're using and how you're using it will determine the specific types of configuration items or CIs in the configuration management database. So configuration management then is important in that it's a centralized way to manage IT governance at some level, such as with mobile devices. And so there need to be defined responsibilities for configuration management tasks for administrators. And many configuration management systems will allow role-based administration. So that if I have a colleague that should only be able to query the app inventory on iPhones, I can configure that. They won't be able to do anything else. We also need a way to verify the validity of configuration items in the database. For example, do we want to have a record of mobile devices in the CMDB that were there 3 years ago but have been replaced and are no longer used? So we need some way to weed out older devices, and many configuration management systems will have an automated way to scavenge old records that have no activity and remove them from the database. Then we need a documentation trail of configuration changes that were implemented. This is usually built right into the configuration management system, sort of an audit trail, as you will, so that when you inventory new items, such as mobile phones, or deploy apps to them, that fact is already recorded. So as an IS auditor then, you need to be concerned with the specific processes of how the configuration management system is used, and specifically which aspects of that tool are used and the sequence of events with performing specific tasks, such as deploying software to a mobile device. When using a risk-based approach for IS audits, vulnerability management is very important. What we're talking about here is looking at IT or process weakness identification and mitigation that can result in reduced cost, reduced potential legal liabilities due to security and data breaches, and also improved compliance with laws, regulations, and contractual obligations. So IS auditors then must consider both internal threats to IT systems and business processes, as well as external threat actors. So again, this is a risk-based approach to IS auditing. But the question becomes, which vulnerabilities should be addressed first? Well, we need to first identify assets that have the highest value to the organization and look at the risks associated with them. Once we've identified any vulnerabilities, it's then very easy to prioritize which ones should be addressed first. We look at the vulnerabilities that are most likely to occur to the most valuable assets. Some examples of vulnerabilities could be software patches that are out of date, or the lack of encryption for sensitive data being stored, otherwise called data at rest, or maybe even the failure to disable user accounts when users leave the organization. Or another vulnerability would be sticking with the default configuration of an operating system or a network device like a router or a switch, or even with an IoT device. We also want to make sure that we don't have unneeded running network services that could potentially serve as an attack vector once attackers perform reconnaissance and see that that service is running. So why have more running that you don't need? Because all you're doing is increasing the attack surface when you do that. We only must run what is absolutely required, nothing more. But that takes diligence and work and continuous monitoring. So vulnerability management is helped along by looking at a history of attacks, both overall in the industry, but certainly within the specific organization. If we know that users have been fooled through social engineering scams through email to click on links which have unleashed worms or ransomware in the organization, then we know that the focus needs to be on user awareness and training. So that would be the gap, and that's a very important thing to identify through an IS audit. We also have to look at how much downtime has been experienced in the past due to these types of attacks. This also could mean a restructuring of organizational security policies if they aren't already being adhered to strongly. The user awareness and training is always the first step in ensuring that our IT solutions related to security are going to be effective. The best IT solutions are only limited in their effectiveness if users aren't aware of how easy it is to infect a network or to inadvertently allow attackers into a network. The vulnerability management program begins with continuous monitoring. A lot of these vulnerabilities sometimes are only exposed on a periodic basis, and they change almost daily. And so, because of that rapid pace, we need continuous monitoring. And what does that mean? That could mean running vulnerability scans on your network more frequently than you otherwise might. The question is, how frequent is frequent? Is it every day, every hour, every week? There is no good answer to that, but it has to be reasonable. So a lot of these vulnerability scanning tools are automated, where you can program them and schedule that to run on a periodic basis, and then perhaps have the resultant scan details with alerts emailed to administrators that can then address those issues. So alerting is also a part of this. If you're in the business of writing code, then adherence to secure coding practices is very important, because the lack of adhering to those secure coding practices is in and of itself a vulnerability. And of course, we also should be applying patches at the hardware and software level, as well as using things like web application firewalls. Maybe that's a part of our vulnerability management program for web applications, where the web application firewall is designed to look for web app-specific types of suspicious activity. The use of group policy in a Microsoft Active Directory environment is powerful indeed, because it allows administrators to centrally configure potentially thousands of settings that can then be applied to some or all users and devices in that Active Directory domain. So it's a big deal. Now, what we can do is we can set up delegated administration so that we can allow other administrators in the organization to work with GPOs, group policy objects, in which these settings are contained, but perhaps limit what else they can do in Active Directory. So to get started here on my Windows server, I'm going to go to the Start menu and fire up the Group Policy Management tool. Here we can see the default domain policy. We could right-click and edit that to get to the settings, but we can also create group policy objects, or GPOs, and apply it to other parts of the Active Directory hierarchy. So that is entirely an option. So for example, if I go to Group Policy Objects, notice we've got one here called Chicago Deploys Software. Well, if I go down under Chicago, it's not even been linked there yet. But we could right-click here, and we could actually link that GPO up to this OU, Chicago. So if I right-click on Chicago, I could say link an existing GPO, choose the Chicago Deploys Software GPO, and there it is. So now, because it's linked at that part of the hierarchy, whatever settings are in here, we could view them by right-clicking and editing, of course, or by viewing the settings here, will be applied to the users or computers in and under Chicago, depending on the settings that were configured. Now, what we're talking about is limiting which administrators can work with things like GPO links. So let's close out of here. And on my server, I'm going to go into the Active Directory Users and Computers tool. This will show me my Active Directory hierarchy, but it will also allow me to delegate Active Directory administrative tasks, including those related to group policy management. So for example, if I were to right-click on Chicago and choose Delegate Control and choose Next, I can then select users or groups that I want to give permissions to in Chicago. So I'm going to start by going to Add, and I'm going to use, let's say, the Las Vegas Help Desk group. So I'll just search for that. That's a group I've already created. Next, what should they be able to do? Should they be able to work with user accounts and set password changes? No. Nothing like that. All I want the members of the Las Vegas Help Desk group to do in this context are to manage group policy links. That means linking GPO's group policies, for example, as I did earlier, to the hierarchy in Active Directory. In this case, specifically, Chicago and OUs under it, because that's where I started assigning those delegated permissions. If I were to right-click on Chicago and go into Properties and then check out the Security tab, then I could go down under Advanced, and I would see that the Las Vegas Help Desk group has numerous other settings here, but it will also include the ability to work with group policy. So as I select each of these entries and choose Edit, I can see the exact options that are turned on here, such as reading and writing GP or group policy links. So it's important then to understand that we can limit the scope of administrative power when required, even to the granular level of managing group policy links. Configuration management includes adding software to existing devices out on the network. And to do that, we can use a centralized enterprise class tool to deploy software and track what's been done. Here I'm using Microsoft System Center Configuration Manager 2016. It's already been configured, and I've already launched the System Center Configuration Manager console tool. So in the left-hand panel area, in the bottom left, I'm going to click Software Library, and in the left-hand navigator, I'm going to drill down under Application Management and Applications. Any existing applications that have been configured here by administrators to be deployed on managed devices will be shown. Currently, there are none. So I'm going to go ahead and right-click on Applications and create an application. Now, depending on the managed device type, it could be something we're looking at for a Windows device, an MSI or Microsoft installer file, or it could be an app package for a mobile Windows device app, or it might be for iOS, or for Mac OS, could be a web application, could be a lot of different things. Here I'm going to choose Windows Installer MSI file. So I've got an installer that I want to centrally deploy to some managed devices instead of running around to each device or remote controlling each device and installing it one at a time. So it wants the location. It wants a network UNC path to where the installation files are available. So even though it's on this server itself, I'm going to specify the UNC path to this host, and down below I can see the shared folders. I've already configured a shared folder called Software, and here we can see the word Viewer MSI file. So I'm interested in specifying the location. So I'm going to go ahead and do that and choose that file. So now we can see it's been placed in here. Then I'll click Next. So it just gives me a little message. It can't determine who the publisher of that MSI file is. That's okay. I still want to import the settings from it. And it's talking about the settings, so the metadata, so the application name and so on. I'm going to click Next. So it's filled in the name. Here I could fill in other additional details if I so chose. We can see here the installation command is MSI exec, which is normal for Microsoft installer packages, /I for install. It's specifying the MSI, and then it's going to do that installation. I'm going to go ahead and click Next to continue, and Next. And before you know it, it'll be completed, at least this configuration. So really, we're just configuring the metadata about that software. And after a moment, the application will have been created here as a configuration item, or CI, in our Configuration Management Database, or CMDB. Here it is, Microsoft Office Word Viewer. So I'm going to right-click on it, and I'm going to choose to deploy it. Now, before we do that, we could distribute the content to servers in different areas to make sure that the installation files are physically near stations that require it. But when I go through the deployment wizard, if that's not been done, it will prompt me. The first thing I have to do is specify the collection I want this software deployed to. A collection you can think of as being similar to a group. For example, a group of computers that you want to receive this software. When I click Browse, I can look at both user and device collections. I'm going to choose device collections. So maybe I'm just going to choose a collection that I've created called Las Vegas, which has two members, two devices. That's the only place I want to deploy this software. So I'm going to go ahead and choose that. Then I'll choose Next. And this is where it says, well, you haven't distributed this content to a content distribution point server yet. No problem. I'm going to click Add, choose Distribution Point, and I'll choose a server that is available. So I've got one server here where that software installation source can be stored, and I'll choose Next. Then it says, well, what do you want to do? Do you want to install or uninstall? Well, I want to install that software. Do you want to make it available so people can elect to install it, or should it automatically be installed? Oh, I want it to be automatically installed, required. So I'm going to go ahead and do that, and I'll choose Next. I can also specify the schedule when I want this deployed. Here it says as soon as possible after the available time. That's fine. It's going to be available very shortly on today's date, although I could choose that specifically if I wanted to control it. That's fine. I want to display a notification in the Software Center. That's the agent that runs on managed computers that check in periodically with this configuration management system. And I'm just going to continue on and go through and set up this deployment. Now, we'll be able to check, I'll just close out of this, by selecting that app and then choosing deployments down at the bottom. And here we can see, indeed, it is deployed to the Las Vegas collection. Now, just for fun, if I go to the Assets and Compliance workspace, and if I look at my device collections, and if I go into Las Vegas, this is where we're going to see the stations that will be affected by our centralized software deployment. And it's a Windows 10 station and a Windows 7 station. In this particular case, those machines are not up and running and therefore are not checking in here, so they're showing as inactive. So in a production environment, if they must receive the software, we'd have to troubleshoot that further. But at this level, we can see that that deployment has been begun. We know that it's critically important that we apply software updates in a timely fashion. And depending on the enterprise standards, we might have to have a testing environment first before deploying new updates to make sure that they don't break anything. Now, we can manually on a Windows device check for updates. So here on my Windows server, if I go to the Start menu and if I type in up, then I can choose to check for updates, and I can manually do that and determine what should be installed. However, at the enterprise level, with proper IT governance, this just isn't feasible on a larger scale. It's too hard to do and to track. It's better to have a centralized way to configure software update deployment and then be able to monitor it centrally to make sure we know which devices have updates applied. One way to do that is using a tool such as Microsoft System Center Configuration Manager, which I've already installed. Here in the Config Manager console, I'm going to go to the Software Library panel in the bottom left, and then in the left-hand navigator, I'm going to expand Software Updates. I've already synchronized this installation with updates from Microsoft Update Online. So when I go to All Software Updates, I can see we've got the metadata for all kinds of Windows Defender anti-malware updates. Now, I could also add search criteria to look for anything that I'm interested in instead of looking at potentially thousands upon thousands of updates, which you'll see over time here. However, I'm just going to select a couple of these updates for Windows Defender, and I'm going to right-click to add them to a software update group. I'm going to call them Current Windows Defender Updates. And this is going to be, let's say, for the current month. And then I'm going to click Create. So all I've done is added the metadata information, not the actual updates, to a software update group. And I can see that software update group over here on the left. There it is. Now the next thing I can do is then use that software update group to deploy those specific updates. And I can right-click and start running the deployment wizard to do that. But I can also create what's called an automatic deployment rule, so that when we have new updates that are detected here, because we're synchronizing with Microsoft updates that are stored online, we could have updates also automatically deployed. But you have to be careful with that because your organization might first require that some testing take place to make sure the updates are good and don't break anything. However, back at software update groups, I'm going to right-click on that software update group, and I'm going to go ahead and choose Deploy. Now this is going to take me through a wizard where I'll have to answer numerous questions such as which collection should get these updates and how should that behave. So the first thing I'll do here is specify the collection. So I'm going to click Browse. Maybe I want these updates for Windows Defender to go to the Las Vegas collection, or maybe all systems that are applicable for these updates. I'll just choose Las Vegas, and then I'll click Next. The next thing it's going to want to know is whether these must be installed, it's required, or they're going to be available to be applied. I'm going to choose required. This is a big deal because we're talking about definition updates for an antivirus scanning engine. And I'm going to click Next after that. I can choose the date and timing for when this should be available and the installation deadline. I'm going to leave them on as soon as possible, and as soon as possible also for the installation. So availability and also installation deadline. I'm going to have them displayed in the Software Center agent that is required on managed devices for this kind of thing to happen, because the agent on the devices checks in periodically to see what's new here with this centralized configuration management system. I can also tell it to suppress restart if required by those updates, let's say on servers. So maybe I'll do that. I can also generate alerts, let's say if we've got compliance that falls below a certain percentage. So maybe generate alert if we are less than 95% compliant with the deployment of these particular updates. So I'll go ahead and click Next. And I'm just going to essentially go through to the point where I have to create a new deployment package. I'll call this DP1 for deployment package 1. What I have to do here is specify a location to store the updates, because all we've got so far is the metadata about those updates, not the actual binaries. So I need to have prepared a shared folder in which I can store the actual update binary files. Once I've specified the UNC path to download and store update files in, I'll then click Next. I then need to specify a distribution point, which is a server that actually will store those files that clients reach out to grab. So I'm going to go to Add Distribution Point, and I'll choose my one and only distribution point server here, and I'll click OK. Then I will click Next. So I'm going to choose to download the actual software updates from the internet. Otherwise, I could specify an alternate location where I might already have those updates, but I don't have them. So straight from the internet, it is. And Next. English is the language that's selected, so that's great. So I'm just going to continue on with the wizard by clicking Next. So at this point, it's bringing down the updates, and they will be deployed then as soon as possible to the collection that was specified. One important aspect of hardening hosts is to ensure that updates are applied regularly. Here in Ubuntu Linux, I'm going to start by using the less command to view the contents of a text file, specifically the file that retains a history of updates that have been applied on this host. So less, then /var/log/apt, and the file itself is called history.log. Now when I view that, I can see that I've got a lot of date and time information, so I see that listed up at the top, and I can see the command line here that was issued in order to install components and so on. And as I go down through this list, we get a list of the specific packages, the software packages on this host that have received updates. We can even see the versioning information, which is what is going to be very important when it comes to determining whether we've got an up-to-date software package installed on this particular host. Now also, I'm going to quit out of that by pressing Q. I'm going to type clear. So that's a log of packages that have been installed and the versioning information for it, which can be very important. However, I can also run the following command. Now, unless you're logged in with the Linux root account, which is all powerful, you'll have to prefix a lot of the privileged commands that you want to run with the word sudo. Now I'm going to do that. I'm going to run sudo, and I'm going to run apt space update space 2 ampersands, and then sudo space apt upgrade, and then -y for yes. So what this means is that the second command after the 2 ampersands will execute only if the first one succeeds. So what I want to do here with sudo apt update is make sure my software package repositories are up to date on this host, And then for anything that is installed on this host, I want to manually upgrade it. Now, depending on your Linux distribution, this might already happen, for instance, on a daily basis. However, I'm going to go ahead and run this command. And we can see it's going through and listing a variety of different repository URL links, and now it looks like it's running the get command to retrieve some packages that might require updating. And we know, again, that applying the latest updates is an important part of security at the operating system level. So we can see now at the bottom that we've got a progress bar that indicates how far through the process it is for updating packages for the ones that we already have installed on this Linux host. As an IS auditor, one thing that you want to look out for is how this is done on a larger scale, such as in the enterprise. Because if you have 100 Linux servers, you probably don't want to be running around and doing this all of the time. So depending on whether the Linux hosts are deployed on premises or in the cloud, will determine which type of solution can centrally be used to reach into each Linux host and to run these commands, or at least to check that this is configured to run daily from a security perspective. The other thing to bear in mind is you should expect to see in a cloud computing environment that there might be some additional software packages installed that normally are not present, and that might be used, for example, to allow a centralized cloud solution to reach into the virtual machine to run configurations or to monitor the performance of that host. Now, the last thing that we'll talk about is how to verify, in fact, that Linux is set to automatically run updates. Now, depending on the distribution of Linux, once again, will really determine exactly how this is done. And here we're using Ubuntu Linux version 18.04. So what I'm going to do then is simply take a look at a specific configuration file. And I'm going to do that by using the cat command. I'm going to cat/etc/apt.conf.d/20 auto upgrades. And I'm going to pipe that to the more command to stop after the first screen full. Now, what I'm interested in looking at here is this first directive, which talks about periodic update package lists, which has a value of 1, which means true. This is going to happen on a daily basis. So if I wanted to turn that off, which is not recommended, I would set that to a 0. But more importantly, if you take a look, if you're auditing a virtual machine running Linux or a physical one, and that is turned off, you probably want to turn it on unless there's some other mechanism at play that is ensuring updates are applied frequently. In this exercise, the first thing you will do is explain the purpose of a service level agreement, or SLA. Next, you will establish a performance baseline on Windows Server 2016. You can do that using a data collector set in the Performance Monitor tool. Next, you will enable Microsoft Group Policy GPO link delegation. So we only want some administrators to be able to configure GPO links in Active Directory and nothing more. Finally, you will use Microsoft System Center Configuration Manager, SCCM, to centrally deploy a web link to an intranet site. At this point, pause the video, think about each of these items, and then come back to view the solutions. A service level agreement, or an SLA, is a contract between a service provider and a service consumer. So for example, between a cloud service provider like Amazon Web Services or Microsoft Azure and us as a cloud customer. The purpose of the SLA is it's a document that guarantees a certain amount of uptime. And if the uptime for that service is not honored, then we as a customer will receive service credits that we can apply against future costs for the use, in this example, of cloud computing services. Next, in the Windows Server 2016 environment, we can establish a performance baseline by creating what's called a data collector set, otherwise called a DCS. Now, a DCS will allow you to specify certain performance metrics you want to look at over a period of time so you can determine what's normal. So here on my server, I'm going to go to the Start menu and fire up the Performance Monitor tool. Now in here, I can configure a data collector set and schedule it so maybe it'll run for 2 weeks or so we get a good sense of what average utilization is under normal conditions. So I'm going to click in the left-hand navigator, Data Collector Sets, and I'm going to right-click on User Defined and build a new one, which I will call Establish Normal Baseline. I'm going to create this manually, so I'll click Next, and I want to specify performance counter metrics I will look at. So Next, and I will click Add to add some specific performance counter metrics, like, for example, the total processor utilization, and any other specific performance metrics that I might be interested in. Now, because I've got SQL Server here installed, I've got some SQL Server metrics that I might be interested in taking a look at. So I'm just going to add some of those and click OK. Now I'm going to tell it that I want that to be sampled once every hour. And afterwards, we're going to schedule this so it keeps happening for, let's say, 2 weeks. So we get a good sense of what the average is. Then I'll click Next. I'll accept the default location for storage, and I will choose to open the properties, and then I'll click Finish. Now when it opens the properties, I want to go to the schedule, because this is where I can add a schedule, tell it where I want to begin. How about we start it on Monday the 22nd, and we'll have that continue on, let's say, for 2 weeks to the 6th of the following month. I can also specify exactly when I want it to launch on particular days. Now at this point, we've now got our established normal baseline data collector set. We just have to wait for the schedule to kick in, or we could start it manually by clicking the Run button. And the resultant report that we would want to look at after to determine what is normal in our baseline is going to be done under Reports User Defined, where we'll see the details related to our DCS, our data collector set. Of course, we don't see the results yet because it's still running, but this is where you would go to view the results. Next, I'm going to ensure that certain administrators, have the ability to administer group policy GPO links, but that's about it. So I can do that in the Active Directory Users and Computers tool using the Delegation of Control wizard. So the first thing I'm going to do in here is just check out in Boston any groups I might have. I'm going to add a new group called GPO link _ administrators. Of course, I would then add members to that group. Now what I want to do is make sure that the members of that group can modify GPO or group policy object links in the entire domain. So for example, I can right click on the domain and choose Delegate Control. Now I'm going to click Add because I want to specify my GPO administrative group here, GPO link administrators. And what I want to do is allow them to manage group policy links. And I'll just continue through and finish the wizard. So that has been set now at the domain level. So by default, that privilege will flow down to all of the OUs so that administrators that are in that group will have the ability to manage those GPO links. Now the last thing we have to do here is use System Center Configuration Manager to centrally deploy a link to a web app running on an intranet site. So here on my server, I'm going to fire up the SCCM Management Console. Now, while there are many tools that can do what I'm going to do here in the Microsoft SCCM tool, as an IS auditor, when we're performing an audit, we have to be familiar with the specific tools being used by the auditee. So we have a way of going in and checking on things to ensure compliance and also to view security controls and make sure that we are mitigating risk. So what I'm going to do here in the SCCM console is go to Software Library down in the bottom left. Then in the left-hand navigator, I'll drill down under Application Management and click Applications. I'm then going to right-click on Applications and create an application. I need to specify the application type, which in this case will be a web application. And I'm going to specify the location. So I'm just going to specify a fictitious URL, but this would be the URL that would point to an important intranet site that I want available on some stations. So I'm then going to click Next, and then that's it. So I can fill in additional details, but I won't. I'll just continue through here to the point where it creates this application object or configuration item, CI, here in my configuration management database. Now the next thing I have to do is actually deploy that to specific machines. So I'm going to right-click on it, and I'm going to choose Deploy. The collection in this case, let's say, is going to be a device collection, a built-in one called All Systems. I want all systems to have this link made available to that web application. And then, of course, I'll just continue on. I don't need to specify a distribution point because there's actually no file content here. It's just a URL link. And I'll click Next. I want it to install this link, and I want it made available. I don't want to force people to run it. And I'm just going to continue through with this. And then now it's done. So using a centralized configuration management tool such as SCCM allows us to centrally manage items that otherwise might take much longer if we did them individually on each and every device. There are many ways that cryptography can be used to secure data. And as an IS auditor, we need to be aware of these mechanisms because they might be required to be compliant with laws or regulations as part of the audit. So cryptography then can provide security through confidentiality, integrity, and source authentication. We're going to talk about each of these items. So cryptography can be used then for integrity and authentication through file hashing, through email digital signatures, by securing traffic over a public network using a VPN, or by using blockchain to authenticate financial transactions done using digital currency. Confidentiality can be used to encrypt files, folders, and disk volumes. This is one aspect of crypto. And we can also use it to encrypt email messages. Confidentiality, or encryption in this context, can also be used for VPN network traffic. We might want to, for example, link two offices over the internet, but we want to make sure we have an encrypted tunnel linking those two offices. We could use a site-to-site VPN. Or we might have a remote traveling user that needs to access a private corporate network over the internet. Again, we could use a client-to-site VPN in that example. We might even use encryption for a mobile device, so that if a mobile device falls into the wrong hands, without knowing a way to decrypt, so knowing a passphrase or having a PKI certificate to decrypt that content, the data is scrambled and therefore is still protected. With encryption, an encryption key is acquired, and there are many different ways that we can get a key, such as through a PKI certificate. Once we have an encryption key, we can then feed the key and the data that we want to encrypt. Now, before it's encrypted, that data is called plain text. We can feed that into an encryption algorithm, and there are many different types of encryption algorithms. The result is called ciphertext. It's the encrypted or scrambled data, and you would need the key in order to go through decryption to result back to the original plain text. Hashing provides file integrity when it comes to working in the file system, and we can use it to detect any unauthorized file modifications. It can also be used for digital evidence admissibility in a court of law. Now, there are a number of different hashing algorithms, such as the older MD5, Message Digest 5 algorithm, and the newer SHA-256, where SHA stands for Secure Hashing Algorithm. So where you have a choice, you would use SHA-256 then over MD5. With file hashing, the first thing that happens is the raw data bits of a file are fed into a one-way hashing algorithm. This results then in a unique value, and that unique value is what we refer to as either the hash or the message digest. It's the same thing. Now what happens is we can then run a hash again in the future to see if anything has changed. So with file hashing, we generate the hash in the future to see if anything changed from the original hash. We compare the current hash to the originally taken hash. In the Linux environment, we might use file hashing through the MD5 sum command and then specify the file name. In a Microsoft PowerShell environment, we can use the get-filehash PowerShell commandlet and give it, for example, the name of a file, and also specify the algorithm using -algorithm, where the default algorithm would be SHA-256, but if you need to generate a hash, for example, for MD5, you could specify that on the command line. Another aspect of cryptography that uses hashing is digital signatures, and often we'll see this used when sending network transmissions. We might even do this when we are sending an electronic or email message over the network. So what happens is we use a hashing algorithm, such as SHA-256, to create a hash value of the message content. So think email. We would click perhaps a button that would digitally sign the message, and the hashing algorithm generates a hash value based on the content in that email message. Next, our private key, we are the sender, is used to encrypt that hash value. Now, the recipient of our digitally signed email message then verifies the signature with a public key. So digital signatures then provide message authenticity. We know the message came from. We know that the sender cannot refute having sent it, which is called non-repudiation, because only the sender has their private key. Nobody else has it. Also, the signature, as we know, is verified using the mathematically related public key, which anybody can have. So only the sender has their private key, but anybody can use the public key to verify signatures. There are two primary types of encryption, being symmetric and asymmetric encryption. Symmetric encryption is used for data confidentiality. In other words, the protection of data by encrypting it. The original data, before it's encrypted, is referred to as plain text, but after it's encrypted, it's called ciphertext. The encryption process begins by feeding the plain text data with an encryption key into an encryption algorithm, the result of which is encrypted data. It's scrambled, otherwise called ciphertext. But with symmetric encryption, we are using a single unique key. So one key is used to encrypt as well as to decrypt, hence symmetry or symmetric. The key is often called a secret key, but the problem with this mechanism is, on a large scale, how can we securely distribute the key over a network? Because everyone needs the same key. Also, if that same key is compromised, everything is compromised. Now, there are many different types of common symmetric algorithms, such as AES, the Advanced Encryption Standard, at 128 bits, 192, or even 256 bits. The more bits you have with a symmetric algorithm, generally speaking, the more difficult it would be to crack that encryption algorithm. Then we've got older standards like Triple Dss or 3 Dss. So when you have the choice between 3 Dss and AES 256, for example, you would choose AES 256. There are other symmetric algorithms like RC4, Twofish, and Blowfish. With asymmetric encryption, a public and a private key pair are used. So we've got two keys, unlike the single key, the secret key that's used with symmetric encryption. So asymmetric uses two keys, and the keys are mathematically related. Often you'll hear technicians refer to asymmetric encryption as public key encryption. And this is a valid term, even though a private key is also involved. Now, these keys are generated when a PKI certificate is issued to a user or a device or to a software app. PKI stands for Public Key Infrastructure. It's a hierarchy of digital security certificates, and that's where these key pairs are issued. Now, when it comes to asymmetric encryption and securely distributing keys, we have an easy way to do it. So we don't have an issue as we do with symmetric encryption. And the reason is because with asymmetric encryption, we have a public and a private key pair for every entity. And so the public key is called public because it is designed to be made publicly available to anybody. However, the private key cannot be shared. It is designed so that only the owner of the key pair has access to the private key, hence private. So with asymmetric encryption, the sender requires the recipient's public key. Imagine that you are the sender. You're sending an encrypted email message to a colleague. In order for you to send it to them as an encrypted message, you need their public key, not yours, theirs. Now, on the other end, decryption occurs with the recipient's related private key. So you used your colleague's public key to encrypt the message to them. They will use their mathematically related private key to decrypt the message. Now, with modern software, such as email programs, this happens automatically in the background. Digital signatures are used so that the recipient can be assured the message is authentic and hasn't been tampered with. Digital signatures create a hash value of a message and then encrypt it with the private key of the sender. The recipient will verify the signature's validity using the related public key. Common asymmetric algorithms include RSA, LGML, and ECC. PKI stands for Public Key Infrastructure. It is a hierarchy of digital security certificates. These certificates get issued and managed by what's called a certificate authority, or a CA. We can have our own private CA within our organization that we configure ourselves to issue and manage our own certificates for security purposes, or we could acquire certificates over the internet from a public CA. Now, depending on what your requirements are, will determine which direction you take. For example, if you've got a public website that you want to secure using HTTPS, you need a PKI certificate. But in order for that to be trusted around the world by web browsers on different types of devices, you would need to have that certificate issued from a public CA, not a private one. The PKI hierarchy begins at the top with the root certificate authority, or the root CA, under which you can then optionally create subordinate CAs. You might do this for different geographical regions or different business units, for example. The subordinate CAs could then issue and manage certificates. Now, you don't have to do this because you could have just a single root CA that directly issues certificates itself. With the PKI hierarchy, the issuing certificate authority digitally signs all the certificates that it issues. Now, this establishes a digital chain of trust. In other words, if we've got a web browser that trusts a certificate authority and it encounters a website with a certificate from that authority, it will trust that certificate for that website because by extension it trusts the CA. Root certificate authorities should be brought offline when they're not being used. The reason is because we don't want it accessible from a security perspective, because a compromised root CA would mean that all certificates are compromised. If we're using subordinate CAs, a compromised subordinate CA would only mean in that case that certificates issued by it would be compromised. So PKI certificates then are issued by a certificate authority. They can be issued to a user, to a device, or to a software application. And they are issued for the purposes of encryption or integrity to make sure things haven't been tampered with, or authentication so that, for example, the recipient of a digitally signed message can be assured it really did come from who it says it came from. Now, PKI certificates can be stored in a file, or they could be burned onto a smart card. In a PKI certificate, you'll find numerous items like the X509 version number, where X509 is the PKI certificate standard. You'll have the digital signature of the certificate authority and the signature algorithm used. You'll have a certificate serial number, when the certificate was issued and when it expires, the intended use of the certificate, such as perhaps only file encryption. You'll have the subject name, which might be a user email address or a website URL. And then, of course, you'll have public and private key pairs. Depending on the PKI implementation, the private key might not be stored within the PKI certificate. It might be stored externally separately. Public keys can be shared publicly with any user or device. That's why they're called public. Now, the recipient public key is what's used when we encrypt the message. So if you're sending an email to somebody, you need their public key. Also, the public key is used to verify a digital signature. So if somebody digitally signs an email message and sends it to you, they use their private key as that signature, but you will use their related public key to verify the validity of that signature. So private keys then need to be only made available to the owner of the key, unlike public keys. They can be embedded in cards, And encrypted messages are decrypted using this key, and again, the private key is used to create a digital signature. So overall, how do we use PKI? What is it for? Well, if we have a need of email confidentiality, then the PKI-related solution would be to encrypt the message with the recipient's public key. If we need email authenticity integrity, then we would generate a message hash and encrypt that hash with the sender's private key. If we need to secure network communication to a web server, we would use a PKI certificate. Ideally, the server would be configured to use Transport Layer Security or TLS version 1.1 or higher, along with HTTPS. Anything prior to TLS version 1.1 is considered hackable. What if we need multi-factor authentication to a VPN? Well, in addition to a username and password, users might need to possess a smart card that has an embedded private key to fulfill authentication requirements for the VPN. What if we need a single common access card for facility access, so to get into a building, but also to log on to a computer? Well, we might use a common access card with embedded private keys. So there are many ways that we can use PKI certificates to secure our environments. PKI certificates have a life cycle. As an IS auditor, we need to be aware of any controls related to how certificates are issued. For example, if we're going to issue a private key within a PKI certificate that's going to be used to access buildings on a property, we might have a control in place such that people must physically come to the IT department with picture ID before a smart card is given to them. Then there are key management controls. So how are private keys kept safe? For example, when we store private keys in a file on a disk, we might have a requirement that a complex passphrase is used to protect that private key file. Then there are certificate retirement controls. What mechanisms are in place to retire certificates at the end of their life? The PKI lifecycle begins with a certificate authority, or a CA, issuing a certificate, either to a user, to a device, or to a piece of software. Then the certificate is used based on its intended uses, such as to encrypt files or digitally signed email messages. Next, finally, the certificate will either be renewed before it expires so it can continue to be used, or it will expire, or it will be revoked. Now, depending on the environment in which PKI is being used and the requirements, will determine, for example, when issued certificates are set to expire. So, for example, the standard within an organization might be such that when PKI certificates are issued to users, they are good for 1 year, after which they will automatically expire unless they are renewed. It's similar to how a driver's license or a national passport at some point will expire for security purposes, and it must be renewed. PKI certificate lifecycle management begins with assigning PKI administrative roles. Depending on the software being used will determine exactly how that is done. But ideally, we want to make sure that we have administrators that might be able to renew certificates before they expire, but perhaps not have the ability to issue brand new certificates. The software that we use in our PKI environment ideally will support auditing, so we can track who issued certificates to which parties and when. We should also have a way to automatically monitor certificate expiry dates. The last thing that we want, if we've got a PKI certificate, let's say on a website, is for everyone to forget when that certificate expires, and then all of a sudden, secured communication to that web server no longer works because no one's been paying attention to the expiry date on the certificate. So there needs to be some mechanism in place where expiry dates are tracked ahead of time, and that technicians can do something about certificates that will expire soon before it becomes a problem and severs communications. We should also consider mobile device remote wipe. Now, what this has to do with PKI is that many organizations will issue PKI certificates for users that might be stored on a mobile device. And if a mobile device is lost or stolen, we've got that PKI certificate, which might normally be used to authenticate to a VPN. Now, of course, it would also require additional factors like a username and password in that case. However, we still don't want devices out there with PKI certificates. So we could remotely wipe a device to ensure that whoever has that mobile device doesn't have access to the PKI certificate. At the same time, it's a good management practice to revoke PKI certificates on devices that are lost or stolen. You can deploy a private certificate authority when you need to issue your own PKI certificates within your own internal environment. Here in Microsoft Windows Server, I'm in the Server Manager tool, where I'm going to begin by installing the Certification Authority server role. So to do that, from Server Manager, I'm going to click Add Roles and Features, and I'll go through the first couple of screens of the wizard, because I'm specifying that I want to install this on the server where I'm running this tool. And on the Select Server Role screen, I'm going to turn on the checkmark for Active Directory Certificate Services, and I'll click Add Features, and then I will click Next. So I'll proceed through the wizard up to the screen where it says Select Role Services. The only thing I need to do here is ensure that the Certification Authority role service is enabled, so it's checked on, which it is by default. So I'm just going to continue by clicking Next and then Install. Now after this is done, the next step would be to actually configure a certification authority, because all we're doing at this point is installing the support files to make that happen. After the files are installed, we can close out of the installation screen, and here in the upper right of the Server Manager by the flag, the notification area, we can see that we've got a post-deployment configuration that's required for configuring Active Directory Certificate Services. So I'm going to go ahead and click on that link to begin that process. So the first thing I'll do then is click Next. I'm going to turn on the check mark to configure Certification Authority, then I'll click Next again. So we're going to configure an Enterprise CA because we've got an Active Directory domain controller. So I'm going to go ahead and click Next. It's going to be a root CA. We can't build a subordinate CA until we first have a root CA. And all I'm going to configure here is the root certification authority. So I'm going to go ahead and click Next. We're going to create a new private key. You would only use an existing private key if you were recovering from some kind of a disaster and reconfiguring a certification authority environment. But we're setting it up from scratch. I'm going to leave the default cryptographic provider here for SHA-256 for signing certificates, and I'll click Next. I'll leave the default common name for the certificate authority, and everything else will be left the same. The validity period for the certificate authority will be 5 years. I'll leave the default for the database locations, and finally, I will click on Configure. So at this point, we have installed the files required for the Certification Authority role service. We've gone through and configured our Enterprise root CA. Here in Server Manager, if I go to the Tools menu, and if I fire up the Certification Authority tool, we can see on the left that indeed we do have our newly created certificate authority, and we don't yet have any issued certificates. PKI certificates are issued from a certification authority, otherwise called a CA. And we can use a blueprint or a template that has specific configured settings within it that is used when creating a certificate. And sometimes you might have to tweak templates and configure them in specific ways to remain compliant with certain laws or regulations. So here in the Microsoft Windows Server Manager GUI tool, I'm going to start by going to the Tools menu, and I'm going to fire up the Certification Authority tool. Now within here, what we can see on the left is that we've got a certification authority. So we've got something that's ready to issue certificates, but if I expand that in the left-hand navigator and click on Certificate Templates, we can see the default security templates that are available here. If I want to customize them, I can right-click on Certificate Templates and then choose Manage, which opens up a new tool where I have an alphabetical listing of all of the various templates that are available. I'm going to press W because down here there's a default web server template. And if I double-click on it, notice a lot of the things are grayed out. I can't change them. So the way that you customize this is by right-clicking on an existing template and choosing Duplicate Template. And you make the changes in the duplicate, which I will do now, starting by going to the General tab and I'm just going to call this custom web server. The default validity period for web server certificates that are issued is 2 years, but I'm going to reduce that to 1, which means that the certificate will expire in 1 year from when it's issued. And so we want to make sure that we know that, because when that certificate expires, the website will no longer support HTTPS secured communications. I'm going to go to the subject name. When people connect to a secured web server, the PKI certificate in use has to have a subject name that matches the name people are connecting to, the URL in the web browser address bar. So that can be supplied manually, or because we've got a Microsoft Active Directory domain environment, web servers requesting certificates can simply have the subject name built from Active Directory information for that computer. Specifically, I'll choose the DNS name. I'll also choose DNS name for the alternate subject name within the certificate. Now, there are many other settings here that could be configured specifically for how this template gets used. For instance, if I go to security, I might want to make sure that authenticated users, which includes everyone, has the ability to enroll for certificates using this template. I'm going to go ahead and click OK. So now we see the custom web server template. So I'm going to close out this tool. And back in the previous tool here, the Certification Authority, I'm going to right-click in the left-hand navigator on Certificate Templates, and I'm going to choose New Certificate Template to Issue, because notice our custom web server template isn't automatically available to be used until we complete the following steps. So, New Certificate Template to Issue. I'm just going to go down and choose Custom Web Server and OK. And now we see the custom web server template is here, so it can now be used to issue PKI certificates. When it comes to PKI, public key infrastructure, part of an IS audit can include taking a look at the life cycle, such as how are PKI certificates issued. In this example, I'm going to manually request a PKI certificate for a web server. So here at the web server computer, which is running the Microsoft Windows Server operating system, I'm going to begin by going to the Start menu and running the MMC tool, Microsoft Management Console. Within MMC, I'm going to then go to the File menu and choose Add Remove Snap-in. Snap-ins are like plugins that give us administrative capabilities. And what I'm looking for here is the Certificates snap-in. So I'll choose Certificates, and I'll click Add. I want to look at computer certificates, so I'm going to choose Computer Account next, and it's for the local computer where I'm running this tool. So I'll choose Finish and OK. So in the left-hand navigator, I'm going to drill down under Certificates, Personal, and then Certificates again. Here we can see that we've got the Certificate Authority, or the CA certificate, because this server is hosting the Certification Authority, but we don't yet have an actual server certificate. So what I'm going to do then is right-click on Certificates and choose All Tasks, Request New Certificate. Then I'll click Next and Next. So because the server is joined to a Microsoft Active Directory domain, any configured templates will be shown here, templates that are made available and that this user or computer has permissions to issue certificates from. So here we've got one called Custom Web Server. So I'm going to go ahead and choose that. Now I could expand the details if I needed to take a look at how the certificate is designed to be used once it's issued, perhaps even click on Properties if there are things that I want to fill in, like the friendly name. Maybe this is for website 1, so I'll put that in as a friendly name for the certificate. I don't have to do that. I'm going to click Enroll, and we can see that the status is that it's succeeded. So that means we should have a certificate listed here, which we do. The certificate template that issued the certificate was configured so that it would extract the DNS name of the computer, as we see here, from Microsoft Active Directory. So we can see that the certificate was issued to this server name and issued by our Certification Authority, or CA. When conducting an IS audit, there are times you're going to come across a requirement to secure network traffic. However, often exactly how to do that or which tools to use is not specified. And so it's important then, as an auditor, to have a sense of some common standards used to secure network traffic. Secure Sockets Layer, or SSL, is now considered deprecated due to many known vulnerabilities. SSL uses a PKI certificate, which in turn would contain things like public and private keys used to secure network communications. And there was a time when SSL was widely used. However, you will still see it in use on private networks and certainly still out on the internet, even though it shouldn't be used because of security reasons. So we have the ability then to disable SSL functionality in client apps like web browsers, as well as server-side operating systems that will host websites. Transport Layer Security, or TLS, supersedes the old SSL network security standard. TLS version 1.0, however, is deprecated and not considered secure. However, TLS versions 1.1, 1.2, and the newer version 1.3 as of August 2018 are considered secure. So TLS then is used with a PKI certificate. Now we want to be careful here because you'll often hear technicians refer to SSL certificates, which is technically a misnomer. It's a PKI certificate, but it can be used with SSL to secure network communications. Now we shouldn't be doing that because we know SSL is deprecated. Really, we should be using TLS. So you might hear people call certificates TLS certificates. Again, technically it's a PKI certificate used with the TLS protocol. TLS, just like SSL, can be enabled or disabled client-side, such as in a web browser, and also in the server-side operating system. Securing network traffic with TLS version 1.1 or higher is sometimes crucial if you want to be compliant with certain security standards, such as with Pci Dss, which is a set of security standards or requirements for companies dealing with cardholder data like Visa credit cards. Also, if you're using SMIME, Secure Multi-Purpose Internet Mail Exchange, for mail security, it uses a PKI certificate to optionally encrypt and digitally sign email messages. We can also secure network traffic using a completely different protocol called IPsec, which stands for IP security. IPsec can be used to secure any type of network traffic. So where we might use TLS to secure website traffic, IPsec can be used to encrypt anything, even ping traffic over the network if you're pinging something, or FTPing, or just everything. So it does not imply using a VPN. Now, a lot of people will associate IPsec along with a VPN, and that's fine. You can use IPsec with a VPN, but it doesn't have to be used with a VPN. Encapsulating security payload, otherwise called ESP, is a protocol for IPsec that is used to encrypt the payload of the packet, or the actual data of the packet. However, it does not encrypt the entire packet. We've also got another configuration option for IPsec called Authentication Header, or AH. This one is used to authenticate the network packet to make sure that it came from who it says it came from and it's not been tampered with. However, when we enable authentication headers, we are not encrypting the packet payload. So you could use both encapsulating security payload along with authentication header to get the best of both worlds when it comes to security. SSL, or Secure Sockets Layer, is a network security protocol that's long been used to secure things like websites. However, SSL is now considered deprecated. It's got a lot of known vulnerabilities, and so it should never be used. So we can control whether SSL is enabled or disabled, both on the client side in the web browser, as well as on the server. So for example, here in Windows, I'm just going to go into Internet Explorer, and I'm going to go into the Tools menu. So I'm going to press Alt-T, and I'm going to go down to Internet Options. And under Advanced, if I scroll down far enough, I'll come to the point where I determine whether SSL is being used or not in this browser. Notice that Use SSL 3.0 is unchecked, so it's not being used. Also, I've unchecked Use TLS 1.0. TLS, Transport Layer Security, supersedes SSL. But like SSL having vulnerabilities, so too does TLS version 1.0, so it should be avoided where possible. However, we can also configure whether SSL is used or not server-side. To do that here on the Windows platform, I go into the Registry Editor to do it. So I'm going to go to my Start menu here in Windows and type regedit to start, the registry editing tool. What I need to do here is navigate under HK Local Machine System, Current Control Set, Control. Then I need to drill all the way down to Security Providers, S-Channel for Secure Channel, Protocols, and then SSL 3.0. If you don't have that key, you can right-click on Protocols and choose New Key. Now within SSL 3.0, the next thing I need to do is build a new key called Server. And within Server, I'm going to right-click and build a new dword value called Enabled. And what I need to do is make sure that that is set to a value of 0. Now by doing this and then restarting the server, I am effectively disabling SSL version 3 support on this host. So I'm going to go ahead and click OK, and I'll close down the registry editor. You can configure a web server, if it's not already been done, with an HTTPS binding for security. The S stands for secure, and it means that we are configuring a PKI certificate to be used with the web server. So you have to have already acquired a PKI certificate from either a public certification authority, if the web server needs to be trusted internationally outside of the organization, or you can use a private certificate authority to issue your own web server certificate if it only needs to be trusted internally. You still have to configure all of your organizational devices to trust your CA. So here I'm going to enable an HTTPS connection to encrypt communications to my web server on the Microsoft Windows platform. So to start on the server, I'm going to go into the Start menu, and I'm going to drill down under Windows Administrative Tools. What I'm looking for here is the Internet Information Services, or the IIS Manager tool. This tool lets us administer our Microsoft IIS website. I can see the name of the server on the left, so I'll drill down under that, and I'll drill down under Sites, where I can see we've got a default website. Now we could have a multitude of different websites listening on different IP addresses or port numbers, and all it really matters here is we need to right-click on the one that we want to enable HTTPS for. So in this case, it's the default website. I'm going to right-click, going to choose Edit Bindings, where we can see that right now all we've got is an HTTP port 80 binding. Now that will still allow connectivity to the web site, however, the communication is not encrypted. So I'm going to go ahead and click the Add button on the right. I'm going to set the binding type to HTTPS, and notice when I do that, it automatically sets the port number to 443. That's normally what's used for HTTPS connectivity. It can be changed, but that is the norm. Down below, I need to select a certificate. Now here it says SSL certificate, which is technically a misnomer. Really, it should say PKI certificate, because we might not even be using the SSL network security protocol in favor of its successor, TLS. But as long as we know the difference, it doesn't really matter. So we do know the difference now, so I'm going to open that drop-down list, and I'm going to choose a certificate, a PKI certificate that I've already acquired on this host. It's got a friendly name of Website 1, although it doesn't have to have a friendly name. And I'm going to click OK, and we can now see we've got our HTTPS port 443 binding. So I'm going to go ahead and close that out. Now that should take effect immediately. So I'm going to shut down the IIS Manager tool, and I'm going to fire up a browser, let's say the old Internet Explorer browser, and I'm going to connect to HTTPS, and I'm going to connect to this host itself. So I'm going to put in its full DNS name, because it's important that you specify the entire DNS name that matches what's in the certificate when it was issued to the host. So once I've done that, notice there are no security messages. And often you'll get a security message because perhaps the certificate is expired, or maybe the name that you've connected to up here does not match what's in the certificate, any such reasons like that, or perhaps your web browser does not trust the certificate authority that issued that certificate. But none of those issues have occurred here because this machine does trust the private certificate authority that issued that certificate. And so we simply get the web page popped up over an HTTPS encrypted connection. Configuring a web server with an HTTPS binding by using a PKI certificate enhances security because now connections to the web server will be encrypted. However, we aren't limiting the audience of which users are able to connect. And there are many ways to do that, such as by requiring authentication, so username and password, for example. But another option is to configure the website to require PKI client certificates, which means every client device that wants to connect has to have a trusted PKI certificate. So in order to do that, we have to configure that on the web server side. Here on my Windows server, I'm going to go to the Start menu, and then I'm going to drill down under Windows Administrative Tools, and I'm going to select Internet Information Services, or IIS Manager. Here in the IIS Manager on the left, I'm going to drill down under my server name, and then I'm going to select my default website. What I want to do over on the right is double-click on SSL Settings. Now here, I'm going to turn on Require SSL, and I'm also going to require Client Certificates. Now by doing this, clients that connect, whether from a mobile device or a laptop or desktop, it doesn't matter, they're going to have been issued a PKI certificate that is trusted by the web server. Now, if I take a look here, first of all, let me click Apply to apply that change. If I take a look at the web server bindings for this site, so if I right-click on the default website and choose Edit Bindings, we can see we've got a port 443 HTTPS binding. If I click Edit, we can see here the certificate is configured, and if I view the certificate, notice that it was issued to the web server by, and we can see the name of the certificate authority. So it's going to be important, for example, that clients are issued a certificate that is trusted, and one example of that would be client device certificates issued by this certificate authority, whether the certificates are issued to client devices or even individual users using those devices, because PKI certificates can be issued to users or devices. So I'm going to go ahead and close out of that and shut down the IIS Manager. Now I'm going to fire up a web browser and attempt to make an HTTPS connection to this server. When I do that, I get an HTTP error 403.7 forbidden. And it's telling me that my browser does not have an SSL client certificate that the web server recognizes. So the web server doesn't trust me. So what I need to do then is make sure that I have a client certificate that is trusted by the web server. So let's close down the browser. And on this same host, we're going to act as the client, even though it also is the web server. I'm going to go into the Start menu and run MMC, the Microsoft Management Console, because I'm going to request a client certificate for this machine. So I need to go into the File menu and choose Add, Remove, Snap-in. And when I choose Add, Remove, Snap-in, I'm interested in the certificates snap-in. So I'll click Add. And in this case, I'm going to leave it on my user account. I want a user certificate. Then I'll click OK. Now if I drill down under Certificates Current User and go under Personal, I can then click on Certificates. And when I do that, I'll see any issued certificates here for users, for the current user to be specific. We don't see anything here. Well, that's why we're not making a connection to the website over HTTPS. So I'm going to manually request one. I'm going to right-click on Certificates. I'm going to choose All Tasks, Request New Certificate, and I'll choose Next and Next. Now, because this computer is joined to Active Directory, then I see any certificate templates made available through the Active Directory enrollment policy. There's one here by default that's available called User. So I'm going to turn that check mark on. Now, I could go into details to view the details about that template that will be used to create my certificate. For example, I can see the validity period will be 1 year, after which the certificate will no longer work. That's all fine. I'm going to go ahead and click Enroll. And after a moment, we can see the status is that it says Succeeded. And I'll click Finish. And indeed, we can see the current username, I'm logged in with the administrator account, has been issued a certificate from our certificate authority within our organization. So now that that's been done, when I go into the web browser on this particular computer where that user certificate is installed, and when I attempt to make a connection again over HTTPS, it should allow me to get in. It might even prompt me to select the certificate if I haven't already configured it in the past, if I haven't made a connection using a user certificate. Sure enough, it's prompting me. It says that the site needs my credentials. Okay, so it knows I've got an administrator certificate now issued by my certificate authority, so I'm just going to go ahead, click OK. Now I am led into the website. Windows Encrypting File System, otherwise called EFS, allows users to encrypt individual files and folders on NTFS volumes. Now you have to be careful because depending on the specific Windows operating system you're using, such as if you're using Windows 10 Home Edition, it won't support some features like encrypting file system. And also, the files need to be on an NTFS formatted disk volume. So here I've got a couple of sample project files which indeed are on a Windows server on an NTFS volume. And one way to encrypt with EFS is using the Windows GUI environment. Now bear in mind that when you encrypt with encrypting file system, it's done based on the currently logged in user. So I'm going to right click on one of these files here, these sample project files, and go into the properties, where I can then click the advanced button and I can choose to encrypt the file, encrypt contents to secure data. Notice if I attempt to also compress the file, it doesn't allow the encryption. And if I go back and click on encryption, it turns off compression. So it's one or the other, but not both. I'll go ahead and click OK and OK. It asks if I want to encrypt the file and the folder it's in. I don't. I only want to encrypt the file only, so I'll choose File Only and OK. And we get this tiny little gold padlock icon, which implies that the file is encrypted. Now, I could also have encrypted the entire folder, and therefore anything created in the folder would also be encrypted. But let's flip over to the command prompt environment where I'm currently in the same location, the project's folder. If I type dir, of course, we can see our 3 project files. But if you want to work with the EFS encryption status of those files, then you would use the cipher command. So if I just type cipher, I can see the files here, and notice that the first 2 have a U, which implies that they are unencrypted. And I've got an E for the third file, which implies it is encrypted. So if I were to run cipher/E, let's say project_A, the first file, after a moment it tells me that it was encrypted. And if I clear the screen and run cipher by itself again, indeed, we can now see the first file is encrypted. You can also run cipher with /D if you want to decrypt the file at the command line. So let's say I want to decrypt project A, so I'll go ahead and do that, and then I'll just run cipher by itself again so we can just check our work. And notice that the project A text file once again is showing as being unencrypted. Microsoft BitLocker is a security solution built into some Windows operating system editions that allows for the encryption of an entire disk volume. And when you're running an IS audit, if you need to verify compliance with the setting that requires the protection of data at rest, BitLocker is one way that that can be achieved. So here in Windows, I've got a USB thumb drive plugged in. It shows up here on my machine as removable disk drive K. So what I want to do then is enable BitLocker encryption for that USB thumb drive. I'm going to go into my Start menu and type in the word Bit, and I'll choose Manage BitLocker. We can enable BitLocker for our operating system drive or any additional data drives on the host. Currently, BitLocker is off for those. However, my removable data drive shows up here as well, and when we talk about BitLocker for a removable data drive, we refer to it as BitLocker to go. Now, if I look at the details for that, we have a link to turn on BitLocker for the USB removable media. So I'm going to go ahead and click on that. So it's going to initialize the drive and then prompt me as to how the drive should be unlocked, because it will be encrypted, whether we're going to use a password or whether a smart card will be used. So we see the password and the smart card options here. So I'm going to go ahead and enter a password, and I'm going to verify that exact same password by typing it in again, so I'm confirming it, and that will be used to unlock the drive. The next thing, when I go to the next part of the wizard, is to either print the recovery key in case we forget the password or to save it to a file. So I'm going to choose to save it to a file, and I'm going to save this on the local machine, but we need to make sure we store it elsewhere and also back it up for safekeeping. Then I'll click Next. I can then choose whether I want to encrypt used disk space only or encrypt the entire drive. So I'm going to choose Encrypt the entire drive, and then I'll choose Next. It says, are you ready to encrypt? This could take a while. I'm going to choose Start Encrypting. And it's now in the process of encrypting that USB thumb drive. Now this means if we plug that USB thumb drive into another computer, a Windows computer that understands BitLocker will have to specify the password to unlock the drive so we can get to its contents. Now, we could do that individually as we've just done on a single Windows host, but you can also enforce this centrally in a Microsoft Active Directory environment using group policy. So here on a Windows server that is running Microsoft Active Directory, it is a domain controller. I'm going to go into my Start menu, and I'm going to fire up, under the Windows Administrative Tools, the Group Policy Management tool. So Group Policy Management. Now within Group Policy Management, I'm just going to right-click on the default domain policy and edit it, where that policy by default applies to all users and devices in the domain. What I want to do here is under the computer configuration is expand policies, and I'm just going to right-click on administrative templates and choose filter options. I can filter the many settings that show up here normally on something specific like BitLocker, so I'll click OK. And the idea is that I will now see a list of filtered options that are really specific only to BitLocker. It may take a moment for that to filter. Once the filter is enabled, you're going to see a little gray filter icon. And if I click on all settings, I see nothing but BitLocker related settings. And if I go down into the Ds, I've got an interesting one here. It's called Deny Write Access to Removable Drives Not Protected by BitLocker. I can go ahead and enable that setting, and what that will mean is for all machines affected by this setting, that by default in this case is in the default domain policy, so that's all machines in the domain unless otherwise configured, then it means that if a file is tried to be copied to a removable USB thumb drive, for example, removable media, if it's not protected with BitLocker, that request will be denied. So this is a good idea in order to safeguard data at rest on removable media, especially to enforce the requirement that it be encrypted with BitLocker. File hashing is used to detect if any unauthorized changes have occurred with regards to a file. Here in Windows, I've already started the PowerShell environment, and next thing I'm going to do here is type dir to get a listing of some sample files I've got created here, one of which is called sample file 1.txt. Now if I run Notepad against that sample file to open it up, we can see it's got just some sample information, sample data on line 1. What I'm going to do here is use the get file hash PowerShell commandlet to generate a hash of that sample file. But before we do, it's important to understand that in PowerShell we can use get-help followed by the name of a specific commandlet such as get-file hash, and we can even ask for detail, so detailed help, and I'll pipe that to more to stop after the first screenful. So here we see it says it computes the hash value for a file using a specified hash algorithm, the default of which is SHA-256. But notice the variations we have, including using the old MD5 message digest hashing algorithm for backwards compatibility if we have to generate that type of hash. So I'm going to press Q to quit out of help. I'm going to clear the screen. I'm going to run get-file hash followed by the name of my sample file. Now the default is it uses the SHA-256 algorithm, which is good. And we can see here the unique hash that was generated. Now this needs to be stored somewhere so we can compare it in the future to see if changes were made. Why don't we make a change to the file? Why don't I run Notepad again to open up the sample file, and let's make a change. So maybe what I'll do is add some text here, sample data on line 2. And we're going to close and save that to the file. So we've got a change that's been written there. I'll use my up arrow key to bring up the get file hash statement against that same file, and notice this time that the hash value is different than what we took originally. And that's to be expected. It's not going to be the same because the file has been modified, and so the hash is different. If the hash were the same, it would be telling us that the file has not been modified since that original hash was changed. And this can be important sometimes when collecting forensic evidence and ensuring that we follow the proper chain of custody for evidence admissibility in a court of law. In this exercise, the first thing you will do is distinguish the difference between symmetric and asymmetric encryption. Next, you will describe the digital signing process, after which you will define the relationship between HTTPS and PKI certificates. Finally, you will create a file hash using Microsoft PowerShell. At this point, pause the video to give yourself a chance to think about each of these 4 items, and then come back to view the solutions. Symmetric encryption uses a single key to both encrypt and decrypt, unlike asymmetric encryption, which uses a key pair, public and private keys. So a public key of a recipient, for example, the recipient of a message, would be used to encrypt that message for them. They would then use their private key to decrypt that message. Digital signatures use hashing. The idea is that the message content in a message uses a hashing algorithm which results in a hash value. That hash value is a unique value that represents the message content. The hash value then gets encrypted with the sender's private key. The recipient then can verify the validity of that signature using the sender's related public key. HTTPS is a secured protocol used for web server access, and it uses TCP port 443. In order to enable HTTPS to secure communications to a web server, a PKI certificate needs to be specified in order to allow for that encrypted communication. The last thing I'll do here is generate a file hash for a file using PowerShell. So here I've started PowerShell on my machine, and I'm in a sample files folder where if I type dir to do a directory listing, I've got a couple of sample files. One is a JPEG image of a dog. What I'd like to do is generate a unique hash value of that file. And in PowerShell, I can do that using the get-filehash PowerShell commandlet. And in here, I'll just specify the name of the file, which is dog JPEG. And when I press enter, we can see the unique hash value that was generated based on that file. So in the future, I can do this again and look at the hash value to see if it's the same as this or not. If in the future I get a different hash value, it means that that file content has changed. Virtualization refers to some kind of emulation of a computing environment, and there are some key terms that we need to be aware of, including hypervisors, operating system virtualization, application virtualization, and desktop virtualization. Let's talk about each of these in more detail, starting with hypervisors. A hypervisor is a physical host. It's a physical server that runs a hypervisor operating system that is designed to run multiple virtual machines at the same time. And so because we can have multiple virtual machines running on one piece of hardware, hypervisors can increase server density within a data center. We can also cluster hypervisors that run virtual machines to provide virtual machine high availability. Also, hypervisors can be backed up, as well as the individual virtual machines running on it. So we could have a backup agent running in the hypervisor operating system that backs up everything, including virtual machine files. But instead of that, or in addition to that also, we could have backup agents running within each virtualized operating system for even more granular backup and restore options. Application virtualization means that the application files that allow an app to run are not actually installed on the host computer. However, the app runs on that host computer. Now, this is interesting because it allows us to run multiple versions of the same app at the same time, where otherwise that might not be possible if they were actually installed on the machine. This can also be used if we want to run legacy apps that normally will not run in a modern operating system. When you create an image of a machine operating system, it ends up consuming less disk space if you don't have all of the apps actually installed within that operating system. So from a modular approach, we can deploy an operating system image, for example, to a laptop computer, and then allow virtualized apps to be deployed on that machine. Virtualized apps are not the same as an application container, but it does require a special software agent that allows the app to run on the host machine. And usually that software agent will create a logical drive letter that shows up in the host computer where the app files are actually installed. Operating system virtualization is a virtual machine, otherwise called a guest, that is assigned virtual hardware, such as a specific number of virtual CPUs, a specific amount of RAM, virtual hard disks, and so on. So the operating system then runs within the virtual machine, as it would on a physical computer, except in this case, it's not. It's a virtual machine. Now, generally speaking, virtualizing operating systems provides better overall hardware utilization. So if we've got 3 physical servers and each of them is only used 65% of the time overall utilization, we might be better off virtualizing those as 3 virtual machines on 1 physical host that can accommodate the processing requirements. So the great thing about operating system virtualization, as we've mentioned, is we can increase the server density in the data center by allowing multiple VMs to run on a single hypervisor machine. Then we've got desktop virtualization. This means that user desktop environments are running on a centralized server. That means that depending on the number of concurrent virtual desktops that will be used will determine how much horsepower is needed on that centralized server. So client stations then only need to be what are called thin clients that access the virtual desktop. A thin client is a machine with minimal processing capabilities, and in some cases it might only use firmware type of storage and not actually support hard disks, because it might not need to. All the storage might happen centrally on the centralized server. So centralization, of course, means more control for administrators of the desktop environment and the software that runs within it. It also means an easier way to apply updates because everything's centralized instead of deploying updates over the network to a multitude of client stations. It also means easier backups because everything is stored in one central place. There are 2 primary types of hypervisors related to virtualization, Type 1 and Type 2. A Type 1 hypervisor runs directly on the physical hardware, so it is the operating system. You'll also hear references to a bare metal hypervisor. This is a Type 1 hypervisor. It's called bare metal because it runs directly on the physical hardware. It doesn't need an existing operating system because it is the operating system. You'll find that Type 1 hypervisors generally provide better performance and stability than Type 2 hypervisors, which we'll discuss in a moment. And so you'll find Type 1 hypervisors well suited for enterprise use. Type 2 hypervisors are an app that runs within an operating system, such as VMware Workstation or VMware Fusion or Oracle VM VirtualBox. They're apps that require an existing operating system to already be present and running. So what this means then is that any performance problems we have at the operating system level can also negatively affect our running virtual machines, because we're talking about having an underlying operating system that is designed to do many other things beyond simply hosting virtual machines like a Type 1 hypervisor operating system is. So therefore, Type 2 hypervisors are better suited for smaller scale use, such as on a developer station or on an IT technician station where it might be used to test various configurations. So what can we do to secure a hypervisor? Plenty of things. First of all, we should be using a Type 1 hypervisor where possible because it increases availability. We should not install any other software on the machine being used as a hypervisor. We want to have all of the resources dedicated to be used for running virtual machines. We should apply updates on a frequent basis to ensure that any security holes are remedied and also to ensure any performance glitches might be fixed through the application of those updates. The hypervisor should be kept behind locked doors. We don't want to allow physical access because that provides a whole other array of ways to circumvent security. We should place the hypervisor on a dedicated protected network. For instance, you might consider at least 2 network interface cards physically in the hypervisor hardware. One that connects to a network where virtual machines need to communicate out on the network normally, but a second network interface card that's dedicated and used as a management network interface card. That's what we would use to make a remote connection to the hypervisor to manage it. We can also configure hypervisor clustering. This is a good idea because if we've only got a single hypervisor that's, say, running 5 virtual machines, if that physical hypervisor goes down, we've just lost access to 5 virtual machines. So if they are crucial in any way, we might configure clustering at the hypervisor level so that a failed hypervisor doesn't mean we lose access to the virtual machines. The virtual machines it was running before it failed can be failed over to a remaining cluster node. We can also, depending on the solution that we are using, enable encryption for virtual machines. This way, we've got limited access in terms of starting up virtual machines. Only hosts with the appropriate security credentials will be able to fire up those VMs. And secondly, it can also prevent administrators from gaining access to the contents of the VM, while they might be able to manage it in terms of allocating virtual hardware or starting and stopping the virtual machine. Then we get virtual machine security. Much like a regular operating system running on a physical host, we should have updates that are applied to that OS. We should disable any unnecessary items. We should configure a firewall, a malware scanner, as well as configuring backups. Now, we might be backing up at the hypervisor level, which backs up all virtual machine files, but for more granularity, we might install a backup agent within the VM itself and then treat that as if we were backing up a physical machine. We should also consider the virtual network switch, or switches, perhaps more than one, that the virtual machine connects to. If a virtual machine has more than one virtual network card, each of those can connect to a different virtual network switch, which in turn can either be used internally within the hypervisor, or if it requires external connectivity, it can actually be linked to an external network. We should also consider setting virtual machine resource reservations. So this can also be done at the hypervisor level, where we can reserve a certain amount of hardware resources that are always available to run the hypervisor, but then for high priority virtual machines, we can also set a higher value or priority on them so they receive more RAM and more CPU cycles than other virtual machines running on that same hypervisor. In order to host virtual machines, you need a hypervisor. In this demonstration, I'm going to be installing the Microsoft Hyper-V hypervisor. Here on my Windows server, I'm going to start by going into the Start menu, where I'm going to fire up the Server Manager. Server Manager is a graphical-based tool whereby, among other things, we have the ability to install Windows Server components, such as Hyper-V. So to get started here in the Server Manager, I'm going to click Add Roles and Features, and I'm going to proceed through the wizard, because I want to install it on this server where I am running the tool, up to the point where I get to the Select Server Roles screen. And I'm going to look down in the H's where I can see Hyper-V. So I'm going to turn the check mark on. It pops up with a list of server admin tools I'll want to install also. So I'm going to go to choose Add Features, and then I'll click Next. I'm going to continue on through the features screen by clicking Next. I'll just keep going through this. I'm then asked if I want to create a virtual switch, a virtual network switch. It wants here to use my physical network adapter to build a virtual network switch. However, I'm not going to do that at this point. I can work with virtual switches at any point, even after I've installed the Hyper-V product. So I'm just going to click Next. And I'm going to accept the defaults for things like the storage location for virtual machine hard disks and configuration files. And again, I can change this up after the fact. I'll click Next, and then I'll click Install. So it's currently installing the binary files for the Microsoft Hyper-V hypervisor. Now that the role has been installed, I'm going to go ahead and click on close, what that will do is allow me to go to the Tools menu or even the Start menu to fire up the Microsoft Hyper-V administrative tool. Now don't worry if you don't see the Hyper-V tool listed here, because in the notification area up here in Server Manager, it says that a restart is pending on this server before the installation will complete. So I'm going to go ahead and restart this host. Alright, now I've restarted that host, so if I go into the Start menu and type in the word Hyper, we can see the Hyper-V Manager tool. So I'm going to go ahead and fire that up. Now this is one way that we can work with Microsoft Hyper-V. The other way would be to use PowerShell commandlets. So here we can see in the left-hand navigator the name of our host, which in this case is a server called Apollo. That's our physical machine on which this Hyper-V hypervisor is running. And we can see in the middle, in fact, that we have no virtual machines yet configured. Also, over on the far right in the action panel, if I click on Virtual Switch Manager, we see we have the ability to create either external, internal, or private network switches, depending on what our needs are, whether we need virtual machines to talk only amongst one another on this host, or along with the host, or even externally to other physical networks. So if I were to go into my Start menu, let's say, and then fire up Windows PowerShell, we would then be able to get a list of commandlets available in the Hyper-V module. So for instance, if I were to say get-command, which is used to show me PowerShell commandlets, but in this case I'm going to limit it to a module, so dash module, called Hyper-V, and I'll pipe that to more so it stops after the first screen fold. If I go ahead and press enter, we can see we have a number of PowerShell commandlets related to managing our Hyper-V environment. So we see we have the ability, for example, to add things like virtual machine or VM network adapters. And as we get through here, we can see all the other things like importing virtual machines, getting VM storage paths, so the location of where the config and files are stored for that virtual machine, and so on. So at this point, we have successfully installed the Microsoft Hyper-V hypervisor. When working with a hypervisor, you have to consider the underlying network configuration, the virtual network configuration that will be used by virtual machine guests. Here on my Windows server, where I've already installed Microsoft Hyper-V, I'm going to start by taking a look at some PowerShell commandlets related to virtual switch management. So here in PowerShell, I'm going to type in the command get-command, and I'll use an asterisk wildcard around the word switch. So one at the beginning, one at the end. And I'm going to tell it I want to look at a module, that's module, called Hyper-V. The Hyper-V module is essentially like a library or a collection of Hyper-V related PowerShell commandlets. And if I press enter, we can see we've got a number of switch related commandlets, like adding a VM switch or getting VM switch, new VM switch, remove VM switch. So for instance, if I were to run get-VM switch, we won't get anything listed yet because I've yet to create a virtual machine switch. So what I'm going to do then is start the Microsoft Hyper-V Manager tool. Of course, we could also use PowerShell commandlets to build a new virtual machine switch, but I'm going to do it this way in the GUI. Here in the Hyper-V Manager over on the far right, you'll see that you've got an option called Virtual Switch Manager. Each Hyper-V virtual machine needs to be connected to a virtual switch if it's got a virtual network card for network capabilities. So I'm going to click Virtual Switch Manager. Now over on the left, I can see I don't have any virtual switches. All it says instead is New Virtual Network Switch. And on the right, I've got three types. I've got an external virtual switch. You need to use this one if your virtual machine needs connectivity outside of this Hyper-V host, such as on a real network. Now, for production workloads running in a virtual machine, that's a must. We've also got this option for internal. So the idea with this is it allows virtual machines to communicate with one another on this Hyper-V host, if you've got more than one virtual machines, and also along with the physical computer on which they are running, so the hypervisor in this case. However, it does tell us here down at the bottom in the description that it doesn't provide external connectivity to a physical network. That's what we would use an external virtual switch for. If I were to choose a private one, it tells me down below that this is a virtual switch that is only used by the virtual machines that run on this physical computer. So it allows connectivity between them. That would be useful perhaps for testing purposes where we don't want the virtual machines to communicate with the Hyper-V host, nor do we want them to communicate with the physical network to which this Hyper-V host is connected. So I'm going to start by creating an external virtual switch. I'll select external and I'll choose create virtual switch. And for the name, I will call it the real world since it's connecting to our real network. And down below, I have to select the appropriate network adapter, the physical network adapter on the hypervisor that I want this to link to. That's why it's ideal in a production environment where you're going to be running a lot of virtual machines to have a number of physical network interfaces on your Hyper-V host. So you could assign different virtual networks that are of type external to each of them. However, here I've only got one. That's okay. It's also helpful to have a separate physical network interface as a management point so you can make remote management connections through that specific network interface. So it wouldn't be connected to a regular network that everyone else is connected to. It would be a dedicated management VLAN, for example. So I'm going to go ahead and select that network adapter. And at this point, I'm going to click Apply in the bottom right. So it's applying the changes, and we can see in the left-hand navigator within the Virtual Switch Manager window that we've got our external network called the real world. Now, after this is created, we're also going to create a private as well as an internal type of switch. So I lost my network connectivity because I'm using remote desktop into my Hyper-V host. I lost that connectivity for a moment, which is to be expected as it begins reconfiguring your network interfaces. Now, what's interesting is if we go and take a look at our network interfaces. So let me fire up the control panel here on my hypervisor. Let me go into Network and Internet, and I'm interested in the Network and Sharing Center, and finally, change adapter settings. So notice here, our physical network interface here, I've named it wired. It's an Intel gigabit network adapter, but notice we've got our virtual switch showing here as a network interface in the hypervisor operating system, and it's got the name of our virtual switch. Here it's called the real world. So what has happened is if we were to take a look at the properties of our physical network interface card, I'm going to right click on it and go into properties. Notice that TCP/IP v4 is not even enabled. Oh, but it was previously. That's because we've now got that virtual Ethernet network switch, so it shows up here as an adapter for our external network connectivity, and if we right click on it and go into the properties, it is where our TCP/IP configuration now resides. And that's important to know from an IP management standpoint on the physical hypervisor host. However, let's flip back into our Hyper-V manager where I want to create a new virtual switch. Now, we left off looking at the virtual switch that we just created, the real world. I'm going to create a new virtual switch, so I'll choose that and I'll choose internal, and then I'll click create virtual switch. I'm going to call this VMs and host just for clarity. It's internal network, that's the type, so I'll click apply to create that virtual network, and then I'll click new virtual network switch again. This time it'll be private. I'll choose create virtual network switch, and I'll call this one VMs only. Now, you don't have to create each type of virtual network switch, only if you need it. And notice that they do show up here over on the left. So when we start configuring virtual machines, we then can tie the virtual network interfaces in the virtual machines to a specific virtual switch. When you install Microsoft Hyper-V on premises, it also installs the Hyper-V PowerShell module, which you can use to manage your Hyper-V environment. So for example, here in PowerShell on my Hyper-V machine, if I were to run get-command -module hyper-v, and maybe I'll pipe that to more, we see a list of all of the PowerShell commandlets that are available for us to manage our environment. And notice, for example, we've got options like new-vm for new virtual machine. So if I were to run get-help new-vm, I'll even ask for, let's say, detail, and I'll pipe that to more. Then we get the details related to using the syntax for the new-vm commandlet. And because we asked for the details down below, we see some extra information about how to use that. However, here I'm going to switch over to the Hyper-V Manager tool to build a new virtual machine here in the GUI. So we see currently we have no virtual machines on this hypervisor. So I'm going to click New over on the right, and I'm going to choose virtual machine. Now notice if I just cancel out of that, you also can choose new hard disk or floppy disk. So what's interesting is if we already have a virtual machine hard disk, we can actually build the virtual machine and use that existing hard disk. However, here we're going to do everything from scratch. So new virtual machine. It wants a name. I'm going to call this Linux 1. It's going to be a Linux-based virtual machine. When Hyper-V was installed, a default path for the storage location of the files for virtual machines was specified, and it's shown down here. But I can override that at any point in time. However, in this example, I will stick with the default, although often it's helpful to have a separate disk to store only your virtual machine files, and in a clustered environment, that also might be shared network storage. Here I'll accept the default and I'll click Next. Now I get to choose whether I want a Generation 1 or Generation 2 Hyper-V virtual machine. Generation 2 supports a lot of more modern features like secure boot, SCSI boot, Pci boot using a standard network adapter, and so on. But it does say that here you need to be running at least Windows Server 2012 or Windows 8 64-bit versions, any of those and above. Here, because I'm going to be running Linux, I don't necessarily need any of those specific feature sets available, so I'm going to leave it on Generation 1, and I'll click Next. I'm going to assign 1024 megabytes, or approximately 1 gigabyte of memory, and I'm going to tell it to use dynamic memory for this virtual machine, so that if the virtual machine doesn't need all of that RAM, it can be allocated and used by other VMs running on this host. So that's definitely an important part of proper IT governance, is the efficient utilization of available resources. Then I'll click Next. This is where I get to determine if I want to have a network connection for this virtual machine. And I can always change this after the fact too. So from the drop-down list, what I'm looking at here is a list of virtual network switches in Hyper-V that were previously created. None of these are there by default. So I've got one here called the Real World, which links to a physical network. I've got VMs and host, which allows virtual machines to communicate with each other and also with the physical hypervisor host, and also just virtual machines only, which is great for testing where you don't need them to have any type of external network connectivity. I want this one connected to the real world, so I'm going to choose that virtual network name, and from here I can then proceed through the wizard. So I'll go ahead and click Next. It wants to create a new virtual hard disk to house the operating system for this virtual machine. And we can see the VHDX file extension, the location, and the size of it. I'm going to accept all of those defaults. Of course, we could change the storage location or the file name or the size. We can also use an existing virtual hard disk if we're rebuilding a virtual machine, or we could deal with that later. So I'm going to go ahead and choose Next. Then we have the option of determining if we want to install the operating system later or install it from an ISO image or from a bootable floppy disk. Well, we don't see that as an option very often anymore, and also installing the operating system from a network-based installation server. So I'm going to choose install an operating system from a bootable CD, DVD-ROM, and then I'm going to choose image file where I can click the browse button to choose that ISO image. After I've made that selection, I can then click Next to proceed through the wizard. Here I've got a summary of my options that I've selected during this wizard. I'm going to go ahead and click Finish. So we can see in the background, it's creating the Linux 1 virtual machine here in Hyper-V. And it's currently mounting the ISO image, so it is available to that virtual machine. Now we are manually creating this virtual machine. In a production environment, such as with an on-premises private cloud, you might even configure it such that you've got a web-based portal that allows users to easily select from some predefined operating system images for virtual machines to quickly deploy VMs. Now to do that, we could use additional tools like Microsoft System Center and its variety of options to make that happen. After a moment, we can see we've got our virtual machine listed and its state is currently off. If I were to right-click on that virtual machine, I could choose Settings, which I could also choose down here in the bottom right in the Actions area. You see the same options here: Connect, Settings, Start, Checkpoint, and so on. So if I were to click Settings, here on the left, I can see my configuration, including the virtual hardware, such as the BIOS to boot from CD, the amount of memory, which is changeable, and the fact that dynamic memory is enabled. I can also see I've got one virtual hard disk here. It's listed by file name and path. We can also add additional ones because you'll notice, for example, that when we click Add Hardware in the upper left here in the settings for the virtual machine, we can select the category of hardware we want to add, and we can choose Add. However, I'm not going to do that. Here again is our network adapter, which in this case is linked to a virtual switch called the Real World. Now, if I were to click on the virtual switch manager on the right, indeed, we can see there is the Real World, and of course the other two virtual network switches that were available. So at this point, what I'm going to do is double click to open up a console window for that virtual machine. And from here, I can now start the virtual machine. Now, because we've specified an ISO boot image, we can see it's booting into that disk image. And from here, it's business as usual, which means whatever you would normally do to install the operating system, in this case, manually with Linux, we would then follow through with to build this virtual machine. Now, when I'm finished with the virtual machine, of course, I have the option of turning it off. If you're going to be responsible for managing or conducting an IS audit that involves hypervisors, it's important to understand what can be done to harden that host. Now, bear in mind, a hypervisor will host multiple virtual machine guests, so we really want to make sure that it's hardened properly. Otherwise, a security breach of the hypervisor could lead to a security breach potentially of all of the virtual machine guests running on it. So the first thing to bear in mind is here we've got a Microsoft Hyper-V installation, and we've got a single Linux virtual machine running. So what can we do to harden this host? The first option is to take a look at the Windows Firewall in this case, because that's the version of the OS that we've got running here. So I'm going to choose Windows Firewall with Advanced Security. Now, the first thing we want to do is make sure that the Windows Firewall is on for all network profiles, whether this server is connected to a domain network, an Active Directory environment, a private network, or public. Now, because it's a server, chances are you're not going to be carrying the server to different locations and connecting to different networks. The exception would be if it's a developer station and you're running Hyper-V on a laptop for testing purposes, as an example. But here, this is actually a fixed physical server in a server room that will not move around. So because it's joined to an Active Directory domain, I'm primarily interested in the domain profile. Now, if I look at the inbound rules, here I see the type of traffic that's allowed in to this host. The key strategy to working with firewall rule sets, in this case at the host level, is to deny everything except for what is absolutely required. So what I might do is make sure that I go through and peruse through this list of firewall rules and right-click and disable or even delete the rules I know I no longer need. Now, this is important. We need to make sure that we talk to anyone else that has an interest in this server, that might have workloads that are running. We don't want to cut them off by building a firewall rule that prevents connectivity. So you might want to make sure, for example, if you're going to use remote desktop protocol, that you allow RDP traffic into this particular host. Now, of course, if you're running a virtual machine that hosts a website on port 443 and that virtual machine is connected to the physical network through Hyper-V, through a virtual switch, then you're going to want to make sure that you allow that kind of inbound traffic as well. So building a firewall rule, of course, can be done in PowerShell, or it can be done, of course, here in the GUI, as well as using the netsh command at the Windows command prompt. Either way, when I build a new rule, I have to determine whether it's a specific program, a port, or a predefined type of traffic that is commonly used that I want to either allow or deny with this rule. So for example, for remote desktop, that's pretty standard. I can choose that from the list here. I could proceed through, and I could turn on the remote desktop traffic types I want to allow, and then determine if I want to allow the connection, block it, or only allow it if it's secure, such as through an IPsec encrypted connection. So it's important then, when we harden a hypervisor, to take a look at both the inbound and the outbound rules, to make sure that we are only allowing incoming and outgoing traffic that is absolutely required. And the best way to deal with that is to start by blocking everything and only opening up the types of traffic that absolutely need to come in or go out. Now, naturally, the location of the physical hypervisor host is important, because when we talk about hardening, this should also include physical security. You don't want to leave the physical hypervisor plugged into a wall jack at the end of the hallway by the water cooler in the office. Instead, it needs to be behind locked doors, because if a malicious user gains physical access to a host, they can do a lot to it. They can boot using alternative means, potentially rip out hard drives and access data that might not have been encrypted for protection of data at rest, and so on. So it's important that physically this be in a locked server room, or if it's in a data center, behind a locked server rack. Now, other things that we can also do is make sure that we remove any services that are not needed on this host. So what I'm going to do is go into Windows PowerShell, where I'm going to issue this command, get-Windows feature. Now, when I run this PowerShell command by itself, what it will do is show me all of the Windows features on this server, and the ones that are installed currently will have an X through them. We see some of them have an X, some of them don't. But what we could do is filter that list of services so we only see what's installed. Because the goal here is we want to get a list of what's installed to determine what can be removed. Part of hardening a host, including a hypervisor, is reducing the attack surface. So that means removing stuff that isn't absolutely required. So let's bring up our previous command here using the up arrow key. That command was get Windows feature. And what I'm going to do is use the vertical bar to pipe the result of that command into something else. Question mark, which is an alias for where object. It's a filter here in PowerShell. Open squiggly bracket, $_, which is a built-in placeholder variable. Because remember, when you run get Windows feature, it returns a lot of different features. We need to process each and every one of them to see whether or not it's installed. And how do you refer to each and every item one at a time as you process a collection of them? You use the built-in variable $_. So that's why I've done that. Then I'm going to separate that object reference with the installed property. And I'll close it up. So I only want to see things that are installed. And then I'll press enter. So now I have a much smaller list of items that are installed. That's all I'm seeing. I'm not seeing stuff that is not installed. And if there's something here that I don't need, so maybe I don't need the file server component installed, then I have the option of uninstalling that, either using the Server Manager GUI, or I could use the remove -Windows feature commandlet. So I can get help on that, get-help, remove -Windows feature, and it explains how I can use that tool. So we have a number of different ways then that we can harden the hypervisor to protect it from attacks. Other methods would include installing an anti-malware tool or placing the host on an isolated VLAN or network segment where only the traffic that needs to get to that Hyper-V host is allowed into that network. Cloud computing use has increased exponentially in recent years for both individuals and enterprises. Clouds have specific characteristics, one of which is metered usage, which means that our usage of cloud services like storage or running virtual machines is tracked, and we pay for what we use. Resource pooling means the cloud provider pools all of the underlying infrastructure together that can then be provisioned as required by cloud customers. Cloud services are accessible from anywhere over a network. Elasticity is a part of this, which means that we can provision resources as we need them or deprovision them as we don't need them. So it's elastic in that sense. We can grow or shrink our usage of cloud services based on requirements. Self-provisioning is another cloud computing characteristic, which means normally that we'll have some kind of a web-based GUI portal where we can provision and deprovision our cloud services and configure and manage them. Of course, this can also be done programmatically and at the command line. One type of cloud is a public cloud, which is accessible to anyone over the internet. Now, it might require the user to sign up with an account, but it is potentially available to everybody. Public cloud providers have worldwide geographic locations, so they have data centers in different parts of the world. Hardware is the cloud provider's responsibility, so ensuring that physical hypervisors are up and running and able to run virtual machines that we might deploy in the cloud, and that there is enough storage to accommodate what we might configure as cloud storage, that type of thing. The Service Level Agreement, or SLA, is a contractual document in this context between the public cloud provider and the cloud customer, And each cloud service will have its own SLA that stipulates uptime that is guaranteed. A private cloud is accessible only to a single organization, but it still adheres to the standard cloud characteristics. So that means that we've got organization-owned hardware infrastructure, and that's the resource pooling that makes all of these services available only to the organization. So we still have all the cloud characteristics like metered usage, elasticity, self-provisioning, all of that still applies. So for example, we could have self-provisioned rapid elasticity of pooled IT resources, such as increasing the amount of storage that is being used within the organization, perhaps by a specific department. And we can also take advantage of the metered usage cloud characteristic, where the usage of IT services is tracked to a granular degree, and that could even be used for departmental chargeback within the organization. A hybrid cloud essentially is the best of both worlds, where we have some IT services running on premises and also some IT services running in the cloud. Now bear in mind that if we're in the midst of a migration to the cloud, this can take some time. And so often a hybrid cloud will result during cloud migration. However, it could be more longer term as well. So examples of a hybrid cloud would be that we've got data stored on premises that is replicated and also stored in the cloud. Or we could have a hardware VPN that links our on-premises network to a cloud VPN. Essentially, we are extending our on-premises network into the cloud computing environment. That's considered a hybrid cloud. A community cloud means that we've got the same requirements for multiple tenants. Now, these requirements might deal with things like sensitive data encryption and compliance with other specific industry regulations. Or it might require, for example, in the United States, that the cloud services are managed by United States citizens. It might also require certain compliance accreditations, such as being FedRAMP compliant for U.S. government cloud computing usage. So FedRAMP, of course, is the Federal Risk and Authorization Management Program that stipulates how to secure the use of cloud computing for U.S. federal government departments. There are different cloud service models for the variety of cloud service offerings. They correlate to the type of cloud service, such as virtual machines, databases, or websites, or even storage hosted in the cloud. One example of a cloud service model is infrastructure as a service, otherwise called IaaS. This would apply to things like virtual machines or cloud storage or the creation of cloud virtual networks, where, for example, the deployment of a virtual machine in the cloud is our responsibility as a cloud customer, just like it would be to patch the virtual machine OS and configure it accordingly. Platform as a service, or PaaS, is normally something that would be of interest to developers because it includes things that can be easily provisioned in the cloud, such as databases or search facilities or cluster-based processing for big data analytics and programming components that are cloud-based, things like application programming interfaces, APIs, or message queues, where one software component can drop a message into a location that is read by another software component. Another cloud service model is software as a service, SaaS. This primarily deals with end-user productivity software like cloud storage interface tools, cloud-based email, and also cloud office productivity tools such as Office 365. The adoption of cloud computing means carefully mapping available cloud solutions to business needs. We also have to think about the compliance in the organization with laws, regulations, and even contractual obligations. We've got to make sure that cloud solutions meet these types of requirements. We also have to consider the cloud provider compliance with certain accreditations such as Hipaa, Gdpr, or Pci Dss, to list just a few. Common cloud service offerings fall into the category of storage, where we might require encryption of data at rest, or perhaps data replication to other geographical regions for high availability of that data. We might also use a Content Delivery Network, or a CDN, which is used to replicate content to different geographical areas to place it near users that will be requesting it, such as large files that are part of a website. We also have to consider compliance with data wiping techniques so that when data is removed from the cloud, there are no artifacts that remain that can be recovered. We might have a requirement also for specific data backup and archiving and retention policies. So that would be something that we would have to check that was available in our cloud provider. Other offerings are based on virtual machines, or VMs, where we can determine the image used to create the VM. The image here simply refers to an operating system image type, whether it's Windows-based or Linux-based, and it might even have additional software components installed in it depending on the image that's used. We can also configure the virtual machine instance type or sizing. This means the hardware, the virtualized hardware horsepower, how much RAM is available, how many virtual CPUs, how fast are the disks, how fast is the networking, that type of thing. Naturally, faster means more cost. Then we have to consider the IP addressing for those virtual machines, whether we want to use public IP addresses that are accessible from the internet or only private IP addresses to be used internally within the cloud virtual network. And of course, network placement of virtual machines. For instance, we might have a single virtual machine in the cloud that's got a public IP that serves as what's called a jump box. So we can connect to that jump box from the internet because it's got a public IP, and from it then connect to other hosts in the virtual network cloud that only have private IP addresses. Then we have to consider the use of databases in the cloud, as well as firewall configurations and developer offerings like cloud APIs. That would be provided by the cloud provider that allows programmatic access to cloud services, but also developers having the ability to create custom functions that are hosted in the cloud, and having message queues to allow the transfer of messages between various software components, and even configuring an IoT centralized hub where we can register IoT devices and process their messages. Public cloud providers normally offer a wide array of security options for their customers, and that's no exception here with Microsoft Azure. I've already signed into the Microsoft Azure portal. One of the things I need to be aware of from a cloud security standpoint is in the left-hand navigator towards the bottom, I have the option of going into the Security Center. The Microsoft Azure Security Center is like one-stop shopping where you can get a sense of your overall cloud security posture. So as I take a look here, I can see various standards like ISO 27001 compliance and how many of my cloud deployed resources have passed security controls to be compliant with that standard. I've got a number of security recommendations, and I can even click on these things to get further details down below. So enabling multi-factor authentication or MFA, or applying disk encryption, and so on. So I can take action based on these Azure Security Center recommendations. The other thing that we should be aware of is working with network security groups. So I'm going to go to all resources here. Now, network security groups are important because they essentially control in and outbound traffic, whether you assign them to a subnet, a virtual cloud subnet that you create, or even a virtual machine network interface here in the cloud. So here we can see we've got a network security group, and of course we could always build a brand new one, which is actually what we're going to do in this example. So I'm going to click Create a Resource, and I'm going to choose Networking as the category, and then over on the right, if I scroll down within that category, I see Network Security Group. So I'm going to go ahead and create this. I'm going to call it NSG for Network Security Group Test. And I'm going to deploy this in an existing resource group. A resource group is simply used to organize related Azure items that you might deploy together. I can determine the physical region where this will be deployed, so I'll select that and I will click Create. Now, after the network security group is created, what's important is that we determine specific rules within that group. It's kind of like a firewall ACL, access control list, that we can control traffic coming into or out of virtual machines or subnets. So it says deployment succeeded. I'll click go to resource. Here I am now in the properties blade for the network security group. And notice we have an option to look at inbound security rules. There are some default rules here to allow inbound traffic from other virtual networks or VNets in the Azure cloud or load balancer traffic. And finally, if those aren't met, then deny all inbound. Now, I could also hide those default rules if I don't want to see them by clicking the default rules button. For outbound security rules, you'll also see a couple of default rules, and at the bottom here, deny all outbound. When you look at firewall rules here, they get processed from top down. And so if there is no match with traffic coming in, or in this case going out, then deny kicks in. So I'm going to build an inbound security rule under the assumption that we're going to be hosting a web server through this network security group. So I'm going to click add. Now I have to determine the source location. Do I want to specify certain IP addresses from which we want to allow traffic, but also with the understanding that it's very easy to spoof IP addresses? I'm going to choose just any location here. The source port range can be any port, but the destination here I can specify as a virtual network, IP addresses, and so on. I'm going to choose a virtual network. Now we could specify that information, or we could specify that it's a specific IP address where we specify the range and the destination port values. So for example, if we know that we've got a specific IP address range that is being used, then we can specify it even here in CIDR notation, CIDR. So here I've got network 11.1.0.0/16. So the /16 is telling me that the network address portion here is 11-1. So you have to know the networking environment. And that's why it's important when conducting an IS audit to make sure you have that type of related documentation for what the scope of the audit will encompass. Now the destination port range, if it's a secured web server over HTTPS, normally would be port 443. And that's TCP based, so I can configure that. And I determine whether I want to allow or deny it. The priority rule is important because remember that these firewall rules get parsed from top to bottom. So rule 100, for example, would be higher up in the list than 65,000 and 65,001. And finally, I have to give a name to this. I'm going to call it allow inbound HTTPS. Now notice it gives me a little red message here that says, well, you can't have spaces with all of these items. It has to begin with a letter or a number and so on. Okay. So if I start changing this by adding, for example, underscores, just so it's still a little bit more readable, then that error message goes away and we have a green check mark. So we've passed the validation test for the name of this inbound security rule. So I'm going to go ahead and click add. Now after a moment, we're going to see that we've got our newly created security rule shown in the list. Sometimes you have to wait a moment for it to refresh. But we can see here it pretty much shows up immediately. Now, the other thing that's important is we have to determine whether we are associating this network security group with either a specific network interface, so we can associate it with a virtual machine network interface, or with an entire subnet. So if I know I've got a subnet containing a bunch of web servers or web applications that are being hosted there, then I could go to the subnet and associate it there. When I click associate, it's just a matter, in this case, of selecting the virtual network and then the appropriate subnet. And then once we've done that, we'll see the association here, and the firewall rules, whether they're in or outbound, are now in effect for resources deployed, in this case, in subnet 1. Virtual machines are sometimes used to be the underlying supporting technology that support a business process. And those virtual machines can sometimes be deployed in a public cloud provider environment. In this demonstration, I'll be deploying a Windows virtual machine in the Microsoft Azure cloud. So here at the Microsoft Azure portal in my web browser, I'm going to begin in the left-hand navigator by clicking the plus sign to add a new cloud resource. I want to add a Windows Server 2016 virtual machine, so that is available here from the list, and I'll simply click to get the process started. I'm going to have to answer a number of questions, such as tying this deployment to a specific subscription for Microsoft Azure, and also deploying it into what's called a resource group, which allows me to group related cloud resources into one unit. I've already got a resource group called RG1 that I'll deploy this virtual machine into, and I'm going to call it WinServe 2016-1. Now, whenever you're typing something in, it'll tell you whether or not it's a valid name or if you've used an illegal character. I'm going to put this in a geographical region near where I am, and depending on what will be hosted in this virtual machine, certain types of data, and depending on which laws and regulations apply, might dictate that you have to specify a region that is within certain national boundaries. Having done that, I'm going to scroll down even further and fill in the username and the password for this cloud-based virtual machine. Down below, I'm then going to specify that I want to allow some inbound traffic. So we've got firewall settings available here. I want to allow inbound RDP traffic on port 3389. Now that would make sense if I want to allow direct administration using the remote desktop protocol client into this virtual machine. So I'm going to turn that on. And down further, I'll then click Next for the disk setup for this virtual machine. I'll leave the default disk setup. Then for the networking, I will let it use the existing virtual network I've already got created in the cloud along with the subnet. It's going to make a new public IP address. You don't have to have a public IP unless this virtual machine needs to be directly reachable from the internet. And I do want it to be, so I'm going to leave that. And essentially everything else I'm going to leave as a default. I'll click Next for management. Again, I'm not changing anything here. And then I can click Next and add some tags here. Tagging information is used for organizing multiple resources. It might be tied to a project or a department, and even facilitates grouping things together for billing purposes. So if this virtual machine, let's say, is for a specific project, maybe I'll put in Project A as being the project that it's tied to. Now these are popping up because I've already filled in these tags previously. Then I'll click Next, and on the review screen, it's going to run a validation to make sure that all the settings are correct, and it looks like this deployment will succeed. It says validation passed. That's great. So I'm going to click Create to build this virtual machine in the cloud. And after a moment, I'll get a message about the deployment being complete. So now if I click on the virtual machines icon on the left, I can see I've got my new virtual machine, WinServe 2016-1, and its current status is listed as being running. The next important thing that we should know is how to make a connection to it. So if we're performing an IS audit and we need to jump into a virtual machine to check out its config or see what's running or what type of data is hosted within it, then we need to know its public IP address and how to make that connection. So I'm going to click on the virtual machine, which opens up what's called a properties blade here. And I can see the public IP address listed here over on the right. So I'm going to copy that to my clipboard. Then on my on-premises station, I'll start the remote desktop connection client and I'll pop that public IP address into the computer name field and then I'll click Connect. I'm then prompted for credentials. This is the user name and password I specified when I deployed that virtual machine. So I'll go ahead and click OK. I'll trust the certificate, and it's going to take me into a remote desktop session into that Windows Server virtual machine running in the Microsoft Azure cloud. Linux is a popular operating system that's used both on-premises as well as in the public cloud computing environment. As such, with an IS audit, there are times when you're going to need to check into Linux hosts, whether they're physical or virtual machines, to ensure that they are compliant with certain rules. So in this example, we're going to see how to deploy a Linux-based virtual machine in the Microsoft Azure cloud. So I've already got an Azure subscription created. So here in the Azure web portal, I'm going to start by clicking Create a Resource in the upper left in the navigator. And over on the right, I can see I've got an option for an Ubuntu server. Well, that is a Linux distribution, and that's what I actually want to deploy. So I'm going to go ahead and click on that to start the process. I'm going to deploy this into a resource group called RG1. A resource group in Azure allows you to group Azure Cloud resources together as one manageable unit. And for the name, I'm going to call it Ubuntu-Serve1. And I'm going to deploy this into a specific geographical region where it makes sense for my deployment, and certain laws or regulations might require that that be within national boundaries. I'm going to go further down here through the list, and I'm going to specify password authentication. Now, SSH public key authentication means that you have to have generated a public and private key pair, and you would paste the public key portion here. You would keep the related private key safeguarded on your machine. However, I'm going to use password authentication here, but depending on how this virtual machine is being used, that might not be acceptable. Because generally speaking, SSH public key authentication is considered more secure, because in addition to knowing a username, you also have to possess the private key. Whereas with password authentication, it's single factor. It's just knowledge of a username and password. However, for this example, that is what we're going to do. Once I've specified that, I'm going to go down to my inbound port rules, and I want to allow inbound SSH traffic directly to this host, which implies we'll also have a public IP address. And I'm really going to accept the defaults for everything else, so I'm just going to click the Review and Create button. It'll run a validation check just to make sure that everything looks like it will deploy correctly. It says validation passed, so I'll go ahead and click Create to begin the deployment of this Linux virtual machine in the Azure cloud. And before you know it, the Linux virtual machine is now deployed in the Azure cloud. Let's just check that out by clicking the virtual machines view over on the left. And here we can see our Ubuntu Linux server is actually up and running. If I click on the link for that, it'll open the properties blade for that virtual machine. And I'm interested in the public IP address because I want to open an SSH connection to it. So that way I would be able to browse through that virtual machine to check out its configuration and any data it might house. So I'm going to copy its public IP address. Next, I'm going to use the free PuTTY or PutTTY tool that I've downloaded to make that SSH session, where I've popped in the public IP address of my Linux virtual machine in the cloud. Port 22 SSH is what we want, so I'm going to go ahead and open that connection. The first time I do this, I get a message stating that do we want to trust the unique digital fingerprint of this host. I'm going to choose yes, after which I'm asked to log in. So this is where I'm going to put in the credentials I specified when I deployed this virtual machine. And after I put those credentials in, we're going to be into the operating system. Essentially, I'm on premises, but I'm reaching into the cloud, into the virtual machine. And if I needed to, for example, view things on the root of the file system using the ls or list command, I could run ls space / and I'll see what's in the file system, and I could carry on from this point. One great feature about using Microsoft Azure with cloud computing is the Azure Security Center. In the left-hand navigator, if we scroll down at the bottom, we'll see that we have a link for the Security Center. What happens with this is that we have a one-stop shopping type of place that we can refer to when it comes to security issues for all of our deployed cloud resources. So for example, if we scroll down here, we can see Resource Security Hygiene, and we've got some high severity items listed here. It says we've got 7 unhealthy resources from a security perspective. So naturally, I'm going to go ahead and click on that link to dive into that in more details. Here I have a listing of security recommendations. So I should enable MFA, multi-factor authentication. I should enable network security groups on subnets, which are used to filter incoming and outgoing network traffic. And even I've got an option here, or recommendation rather, that states we should install endpoint protection software on virtual machines. If I actually click on that, I can see the 2 virtual machines it's talking about, my 2 Windows Server virtual machines. Well, this is a problem. A lack of endpoint protection means that we are not dealing with an anti-malware solution on those deployed virtual machines. And certainly to remain compliant with just about anything, including things like Pci Dss, you've got to have endpoint anti-malware protection running. So what I'm going to do then is go to virtual machines on the left. Let's say I open up one of those virtual machines. In the properties blade, you'll notice that there's something here called extensions. And here are any existing extensions, which are essentially plugins, they're agents that run within the virtual machine OS, will be listed here. Now, it says none are found because none are configured. But when I click the Add button, from here I'll be able to select from a number of different extensions that would give me additional capabilities, including options for things like anti-malware solutions. Or, of course, I could simply remote into that virtual machine given that I connect using its public IP address, if it's got one, which it does, and I could simply install an anti-malware solution manually as I would on any computer. But either way, it's important to take note of some of these tools, such as the Azure Security Center, where you can go to a single central place to get a sense of your security posture. This way you can focus your energy on what needs to be done to harden the environment. In this exercise, you'll start by distinguishing the difference between a Type 1 and a Type 2 hypervisor, along with risks associated with them. Next, you will explain risks introduced with cloud computing adoption. You will then define the purpose of a private cloud, and finally, you will explain the benefit of using a cloud jump box. Pause the video and think about each of these 4 items, and then come back to view the solutions. A Type 1 hypervisor is a bare metal hypervisor, which means it's installed directly on the hardware. It is the operating system. We can use network isolation for management interfaces to secure management access to the hypervisor. Type 2 hypervisors run as applications within an operating system, and so any OS instability can then negatively affect any running virtual machines. The adoption of cloud computing is not without some risks, one of which is vendor lock-in, meaning that you're tied into specific cloud solutions that might not be offered with other cloud providers. And if the cloud provider goes out of business, you need to have a backout plan where you can at least export data and system configurations and reuse them elsewhere. You need redundant internet connections if you have a single connection that allows access to crucial resources that you have deployed in the cloud. You then have to consider shared responsibility, where essentially you are outsourcing to the cloud provider. You're using their hardware and trusting that they're keeping it configured properly and secure. A private cloud is accessible only to a single organization. It's the organization's hardware assets that are used to build the underlying cloud infrastructure. However, it still adheres to standard cloud characteristics such as self-provisioned rapid elasticity of pooled IT resources. Often, departmental chargeback is used within a private cloud for billing purposes. A jump box allows connectivity from the internet, so it is a virtual machine that we could deploy into the cloud that has a public IP address that is reachable from the internet. Ideally, it will only allow connections from a limited range of IP addresses. Now, once we've gained access to the jump box, we can then gain access to other hosts on the cloud-based network, other hosts that might only have private IP addresses. Successful organizations are all about efficiency. And when we talk about IT maturity models, we're really talking about the marriage of technological solutions and how they provide business value to the organization. So it's all about being effective and efficient. So it's important as an IS auditor then that we audit the current IT environment using the IT maturity model. This way we can make an assessment on what's currently happening and where improvements could take place. So we need to think about where are we now from the perspective of the organization versus where do we want to be. By identifying the starting point and the ending point, we can then determine what the gap is and how to bridge that gap. With IT maturity models, there are 3 primary components. They are people, processes used to achieve business objectives, and the technology that allows that to happen. The Capability Maturity Model Integration, or CMMI, really allows us as an IS auditor to consider business processes as assets. And so it has a number of performance levels. The first being initial state, which is a lack of process efficiency when it comes to business processes. Remember, what can often enhance the efficiency of a business process is technology. Now, the next performance level is managed, where we think about doing things like configuration management in a centralized manner, controlled service delivery, such as strong access control mechanisms. Thirdly, we have a performance level of defined. This deals with things like policies in the organization that might need to be assessed and then tweaked. So things like the incident response policy, the security policies, disaster recovery policies, and related items like user training and awareness to those policies, as well as performing a risk management. The idea is to make sure we have the most effective outcome when we use these different types of policies. The last performance level here is quantitative management, where it deals with things that have quantities, like baselines and performance metrics, to make sure that we have an alignment of the technological solution and the reported metrics and the business objectives. Now remember that baselines are related to quantitative management because we're really talking about setting some kind of a standardization bar to identify what is normal. And that could be for the amount of time it takes to complete an entire business transaction using a given process, or the amount of traffic that is normally on the network for an e-commerce website, and so on. Finally, we have optimization. This deals with continuous process improvement, and this is possible with the periodic reassessment of all of the other performance levels listed above. With IT maturity assessment, we are using this to identify gaps between the current state and the desired state where the organization wants to be. And we know now that we can determine the direction based on this that we need to take to reach the desired state. That could also include specific security controls that need to be reconfigured, enhanced, or completely replaced with more effective security controls to make things secure while business processes are being conducted. An example of this would be, for example, taking a look at something like IT hardware and software procurement. So if we need to, let's say, upgrade to a new operating system for client devices, that might require new hardware. So maybe the procurement of the hardware and the software for that purpose might take too long and cost too much. And so as an alternative solution, at least on the server side, we might consider outsourcing this to a public cloud provider. And that can be the result of assessing how things are currently done, looking at where we want to be, and then coming up with a way to make it happen. Most organizations will have a set of security policies that would apply to everyone in the organization, whether it's a standard user using a smartphone to do their work, or whether it's an IT technician, a sales associate, a business executive, and so on. And these security policies are normally driven by things like laws, regulations for a specific industry, and contractual obligations. In other words, rules that must be adhered to keep things secure, such as business processes, private or confidential information, and network transmissions and data at rest. So often, security policies are also driven by the requirement to align technological solutions that are kept secure with business objectives. But all of this is pretty much useless if there's not a strong user awareness within the organization, and users within the organization are trained about how to use technology in a secured manner. This also means making sure that the standard user base is aware of scams and other threats related to social engineering, and of course are aware of acceptable use policies, whether it's acceptable use for VPNs or web browsing, when we can or cannot use social media within the organization, and so on. Often this is a part of user onboarding. So we're really talking about organizational security policies then that are dealing with risk management. We're really looking at risks and how to address them. The other thing to consider is the issues that are addressed, such as the allowable use of technology, definition of what a conflict of interest would be, auditing of system and data access, which means that date and timestamps have to be accurate across time zones. Also reducing legal liability, such as making sure that confidential customer information doesn't fall into the wrong hands, so that we don't have data disclosure issues. Also, security policies can help counter reputation loss due to a security breach. The other things that they might also specify is where responsibility falls. If we've got a security policy related to the use of a public cloud provider, specifically let's say public cloud storage, then the responsibility of where encryption should occur could either be on the consumer side, the cloud customer side, to encrypt data before it's sent up to the cloud, or it could be on the cloud provider, depending on the cloud provider solution we're using and whether the service level agreement or SLA stipulates that things will be encrypted. Now, there are many different types of organizational security policies. Here we have a few listed, such as a data privacy policy, which might stipulate that under no circumstances, without written authorization from the organization, should sensitive data or organizational trade secrets be shared through social media in any way. We've got VPN security policies, email, web browsing, social media use, equipment disposal, building access, incident response, web server configuration, user station reimaging. There are plenty of different security policies, so it's not as if we have a single document that's all encompassing. But the thing that's important for an IS auditor is that there needs to be a periodic review. So there needs to be a risk assessment conducted and then a periodic review of existing security policies along with incidents that might have cropped up, such as through the help desk, to ensure that the policies that are in place are effective. Oftentimes, security policies are effective at the time they're implemented, as long as they are made known to the user base and they are enforced. But over time, changes are required. And this is where you, as the IS auditor, come in. The OSI model is a 7-layer conceptual model that is recognized internationally. It allows us to map communication, hardware, and software to each layer within this model. But the thing to remember is that not all technology, so not all hardware and software, maps perfectly neatly to specific OSI model layers. OSI, by the way, stands for Open Systems Interconnect. The first layer of the OSI model is the physical layer, followed by the data link layer, next the network layer, the transport layer, the session layer, presentation layer, and finally the application layer. So layer 1 is the physical layer, and then we have layer 7, the application layer. Now this is conceptual, it's not tangible or physical, so that when you have two devices communicating on the network, imagine that the communication begins on the sending device, going up through the physical layer, all the way down to the application layer, and then in reverse on the receiving end. So the first 3 layers, physical, data link, and network, are generally considered to be hardware layers. Now we say it's hardware for the most part because you would have something like a router that routes IP packets that would apply to layer 3. It's physical hardware, but it also deals with software or IP addresses. Now when you look at layers 4 through to 7, so the transport layer through to the application layer, those deal with software. The other thing to consider is some of the characteristics for each of the 7 layers. The physical layer really deals with things like electrical specifications and cable types and connector types and equipment like a hub that is used as a central connectivity device for multiple other network devices or network interface cards, otherwise called NICs. The data link layer essentially deals with getting bits on the wire, so getting the transmission happening, whether it's physical wire transmission media or radio waves through the air, such as with cellular technology or with Wi-Fi. So it deals with things like MAC addresses. Network switches would be something that applies to layer 2, the data link layer, as well as network interface cards, which, as you might recall, also map to layer 1, the physical layer. Layer 3, the network layer, deals with things like IP addresses, and we've mentioned that routers would apply at layer 3 of the OSI model, as would layer 3 switches. A layer 2 switch really is a central connectivity point that efficiently only allows traffic to flow between 2 communicating devices. But layer 3 switches add routing capability on top of what layer 2 switches already do. Layer 4, the transport layer, deals with the transmission of data, whether it's reliable and acknowledged like TCP or unreliable and unacknowledged yet more quickly sent, such as UDP. And it deals with things like port addresses, such as a web server listening on TCP port 80. The session layer of the OSI model deals with the creation, maintenance, and termination of network sessions. That doesn't necessarily imply, though, that we have a user login session that the user would interact with, but that would be included. The presentation layer is how data is presented between two communicating nodes on a network, such as dealing with different character sets, whether something is encrypted and decrypted or compressed or decompressed. Finally, we have layer 7, the application layer, which deals with higher layer protocols such as HTTP, FTP, SMTP, and so on. The other thing to bear in mind is that the OSI model relates to security, and that's why we're talking about it. It is something important to consider as an IS auditor. One of the reasons is because to comply with laws and regulations and contractual obligations, we sometimes might have details that specify OSI model layers. Now, you might wonder, how is that possible? Well, because we might require a layer 7 firewall, which is going to be much more sophisticated and be able to delve much more deeply into a network packet than a layer 3 firewall. The other thing is that network traffic is easily forged with tools that are out there that anyone can download and use. So just because we have network traffic that we can map to the OSI model, we can view it, it doesn't necessarily mean it's legitimate because it's easily forged. So when we talk about layer 2 items, we're really talking about security solutions like MAC address filtering, because MAC addresses apply to layer 2 of the OSI model. If we've got a reference to an OSI layer 3 or 4 firewall, we're really talking about a packet filtering firewall, which can look at things like source and destination IP addresses and port numbers, but that's about it. Whereas a layer 7 firewall is called a content filtering or a deep packet inspection firewall because it can look not only at the packet headers that contain the IP addresses and the port numbers, but also at the actual data being transmitted in the payload or the data part of the packet. Depending on the nature and scope of an IS audit, you might sometimes be required to assess password and user account management settings to determine if they are acceptable in mitigating risk. And that would include authentication, which often comes in the form of single factors, such as one category like something you know, like a username and a password. Despite the fact that it's 2 items, they're both something you know. So single factor authentication, and that might not be acceptable. At the same time, we want to make sure that password policies and user account management settings are set in such a way that they protect user accounts. So the other consideration that we have to think about are unique user accounts to make sure people aren't all sharing one login account. The use of unique or different user accounts, everyone having their own, means that we can provide accountability when it comes to resource usage. Intruder lockout allows us to determine when multiple passwords are entered incorrectly, one after another. And depending on our configuration settings, we can then lock out the account for a period of time, or the user might contact the help desk and go through the appropriate procedure to have a help desk technician verify that the user is who they say they are and to unlock the account. The other consideration is the principle of least privilege, therefore only granting the permissions that are needed to perform a specific task and not granting additional permissions. Password settings come in the form of things like password length. So having a longer password can sometimes make it more difficult to crack, but it's not simply the length of the password, it's also the complexity of it. So using letters, symbols, upper and lowercase letters, numbers, all in conjunction together. The other thing to consider is password expiration to make sure the passwords need to be changed on a periodic basis. And then making sure that passwords can't be reused, that there's always a different password. While this is inconvenient for users, it does enhance security. Another way to enhance user account security is through the use of multi-factor authentication, MFA. where we have multiple categories of authentication. So instead of just something you know, like a username and a password, we might also configure a requirement such as a smart card. So that would be something you have. The user must possess the smart card in addition to having the knowledge of the username and password. Altogether, that constitutes multi-factor authentication, just like a username and a password and an SMS text message PIN sent to a user's smartphone would also constitute multi-factor authentication. Another way to ensure that password policies provide enough protection for user accounts is also to think about those default usernames and passwords built into hardware, like IoT devices, and software. The reality is that there are plenty of default password lists available out there on the internet, and they're constantly being updated. So this is there for the taking by anybody. And so sticking with the default username and password means that it's very easy for an attacker to scan a network to determine which model of a device might be being used, and then to try default usernames or passwords to get into that device. Lookup tables are used also to break into user accounts, where passwords are tried against user accounts from a password dictionary, which could come from multiple languages or different types of dictionaries, like legal and medical dictionaries. Another option is having a hash lookup table, where a hash for each potential password that is commonly used is generated. A hash is a unique output based on passing, in this case, a password through a one-way hashing algorithm. So, when we have hash lookup tables, the hash of the password and the original plain text password are stored together. And then that can be compared if an attacker can get their hands on password hashes. There are plenty of websites out there, such as the one pictured here, where you can enter in a password hash if you can gain access to it from some kind of a file or from memory contents, and it will be able to return back the actual results, which we see here down in the bottom right. In this particular example, not only do we get the result, but we can see which hashing algorithm was used, in this case, Pci 256. Pci stands for Secure Hashing Algorithm. Another aspect of user account management is attackers using what are called rainbow tables. So for example, let's say that we're using Message Digest 5 or MD5 to generate password hashes. Well, the problem is that MD5 is quite an older hashing algorithm. Instead, you should be using something like Pci 256, because MD5 password hashes are known to be easily cracked, even if the passwords are up to 8 characters in length. So like a standard lookup table, a rainbow table has pre-computed hashes that are stored, but the interesting thing about this is it uses less space than what a standard lookup table is, and that's because it's kind of like a compression algorithm. So if we've got a lot of, let's say, pre-computed hashes that start with F3AA5600B, then that prefix is stored only once, and a placeholder token is used instead. So that's how it takes less storage space than a traditional lookup table that has the full passwords and perhaps even hashes stored. So while this will take less storage space than a traditional password lookup table, it's a bit slower because we have to essentially do the conversion of the replacement token with what the actual value is. Pictured here on the screen, we see that there are plenty of free websites available where malicious users can download rainbow tables, pre-computed password hash lists essentially, that they can then use against hashes that they might have gathered. So why is all this relevant to an IS auditor? Well, because having a knowledge of how easy it is, how many freely available resources there are out there for attackers to use to break into accounts, helps us determine the strength of accounts when performing an IS audit that includes that aspect of information technology. Configuring and reporting on anti-malware settings in the enterprise is best done using a centralized tool. And part of an IS audit might include us being responsible in looking at the settings to ensure that they are appropriate, that they mitigate the risk down to an acceptable level. Here we're going to use Microsoft System Center Configuration Manager, or SCCM, in order to make some anti-malware settings centrally that can then be deployed to managed devices. So to get started here in the SCCM console, in the bottom left I'll make sure I'm in the Assets and Compliance workspace, which I am. Then in the left-hand navigator, I'm going to drill down under Endpoint Protection, where we've got a view called Anti-Malware Policy. So I'm going to go ahead and click on that. Over on the right, we've got the default Client Anti-Malware Policy. Now that will apply to any managed devices within this SCCM site environment. Now what we can do is also create additional anti-malware policies because, for example, in a different department in the organization that might deal with more sensitive information, there might be different client anti-malware settings that we want applied there than we do elsewhere. And so we can build different policies. And we would do that here by right-clicking on Anti-Malware Policies on the left and choosing Create Anti-Malware Policy. Now from here, we have to check off the options that we want included. Now these are general categories, or you can think of them as general categories, in which are contained many additional detailed settings. So I'm going to turn on Scheduled Scans, Scan Settings, maybe Real-Time Protection. Now on the left, when I click Scheduled Scans, here's where I have the Scheduled Scan options listed on the right. So maybe, for example, I'm going to make sure that we've got full scans that are run on specific days. So we can choose here daily, for instance. We can also choose the time. Also, we can determine other settings. So for example, if I click on left, I can click Scan Settings, and I might say I want to scan network mapped drives when running a full scan. Although if you've got an anti-malware solution running server-side, you probably don't need to turn that on here at this point. Then I've got real-time protection settings over here, whether we want to make sure real-time anti-malware monitoring is enabled. So that's fine. I don't want users to be able to configure the real-time protection settings, so I'm going to leave that as it is. So basically at this point, if I go back to General, I can give a name to this Endpoint Protection Anti-Malware Policy. Let's say this is for computers in Toronto in Department A. So maybe I'll call it TOR Department A. And then I'll click OK. Now the last order of business to put that into effect is to right-click on that policy and then to deploy it. So when I choose Deploy, I'm determining which device collections I want this made available to. So device collections are like groups of devices, and they can be customized. You can see here I've got a customized collection here called Las Vegas. However, here I'm going to choose, in this example, all mobile devices, and I'll click OK. So at this point, if I were to select those anti-malware policy settings and click on Deployments down at the bottom, we can see the settings have been deployed to the All Mobile Devices collection. Now, despite that being done, it doesn't mean it's in effect immediately. Sometimes it can take up to an hour or so, depending on your environment, before the devices will read these configuration changes. Data loss prevention, or DLP, is a hot topic. According to Wikipedia, it is the intentional or unintentional release of secure or private and confidential information to an untrusted environment. Now, intentional would be malicious, where unintentional could be user error. An employee within an organization might inadvertently send sensitive data to a contractor through email messaging. Now, in recent years, we keep hearing more and more about data privacy laws in different parts of the world that are being enacted and also enforced. The other thing to consider is user awareness and training. Users need to be aware of social engineering, essentially deception or trickery, where people get tricked through file attachments, through email message, through social media mechanisms, including SMS text messaging through phones, to divulge sensitive information, whether it's their information, such as banking information, or whether it's sensitive trade secrets for the company, customer or financial information that shouldn't be disclosed, and so on. Data loss prevention should also be a part of new employee onboarding within an organization, where there is training that is provided and documentation about this type of thing is made easily available to users. Now, not only should that be an issue during new employee hires, but also after the fact through periodic training updates about the latest scams and maybe changes to organizational security policies. The other thing to consider are how data loss prevention techniques are implemented. Whether you're looking at a virtual appliance that is used for data loss prevention, that might work in conjunction, for example, with mail servers in the organization, or whether it's just software you install within existing servers, it consists of policies. Now, a data loss prevention policy will have conditions where it determines what type of data it's looking at. Are we looking at something that's sensitive? Is it not sensitive? Now, assuming that we've found some data that's sensitive, such as customer financial information, we then have actions. Maybe that is allowed to be sent to email addresses within the organization, but not to email addresses that use a different domain after the @ symbol that does not match the organization. So this way we can prevent sensitive file attachments and other type of data from being sent outside of the organization via email, although data loss prevention, or DLP, is certainly not limited only to email messages. It could also be embedded within a PDF document to prevent printing or editing of the content. Then there's the malware side of things, where we need to make sure that definition updates for the anti-malware scanning are kept up to date, as well as the scanning engine itself. Some malware scanning solutions also provide behavioral analysis, where they can take a look at what might be considered abnormal behavior to determine that something suspicious is happening. And it can block access to things like sensitive data, hence data loss prevention. At the same time, we should also within an organization consider whether limited external media use is a factor. Do we need to limit the use of USB thumb drives? There have been plenty of documented cases, including publicly through the media, of data being stolen or lost, intentionally and unintentionally, to USB thumb drives, such as employees forgetting to take a USB thumb drive out of a public computer kiosk, such as in a hotel lobby where the hotel provides guests with a computer in their office area. The other thing to consider is the use of network isolation, so that any servers housing very sensitive data perhaps should be on an isolated network that has very restricted and limited access. Maybe that traffic shouldn't be traveling on a standard IP network where regular client traffic exists. Much like data privacy, Internet of Things, or IoT, is another one of those terms that we keep hearing more and more about. As an IS auditor, it's important to consider security as it relates to the use of Internet of Things. But first, let's define exactly what IoT really is. What we're talking about here is a physical device with embedded software. Now, there are a wide variety of IoT devices, but an IoT device is a device that can communicate over the internet. There are also ways that we can send the resultant data of that communication from the IoT device to a central location in the cloud for processing, an example of which would be something like Microsoft Azure IoT Hub. Now, as a result, we also have to consider not only perhaps the use of on-premises IoT devices within a facility, but also where it might be sending the data, such as to the cloud. So what are some examples of IoT devices? Examples would include smartphones, home environmental controls, as well as more commercial environmental controls for heating and lighting that can be scheduled to turn on and turn off at certain parts or times of the day, as well as being controlled remotely, even through a smartphone app. The other thing to consider is devices like smart vehicles that can be controlled remotely. Even pressures and valves and pumps that are used in a lot of social infrastructure locations, as well as medical devices that can send patient information such as heart rate or blood sugar levels to a centralized location that can then be used, ideally legitimately, by a doctor to make some kind of a diagnosis. So there are a lot of different types of devices, but the problem is that if we run a simple IoT search using a standard IoT search engine like Shodan, we'll get a list of some common devices that are detected in every part of the world that perhaps have not been secured. As an example, here we see that we've got a device that might be susceptible to a directory traversal attack to gain access to a file system that shouldn't have access given. And we can see down below that there are some details about what exactly is. This is a home automation application that allows users to control housewares and appliances locally or remotely via a web interface. So there's a lot that can be learned by simply using a website like Shodan. So what can we do about it? Well, the fact is there are many consumer-grade IoT devices out there, and there will be billions more over the next few years. So the problem with this is that security is not a first priority in many cases, such as firmware that might not be updatable within the IoT device. And so it's very important that default settings like usernames and passwords be changed on IoT devices. And as a mitigation, you might even consider placing an IoT device on an isolated network that has very limited and restricted access. So as an IS auditor then, we have to have an understanding of IoT devices, what they are. One of the common security deficiencies, as we've seen here, is default settings or firmware that can't be upgraded. We have to be aware of this so that we can put controls in place to mitigate these vulnerabilities. Many IoT devices are notorious for not being secure, whether it's not being secured straight from the factory, which means we as IoT device users must change default settings, but in some cases IoT devices might not allow changing of things like a default username or password. It's embedded in the firmware and it can't be changed, and in some cases the firmware can't even be updated. Those are the types of IoT devices you really need to stay away from. Because here at the Shodan.io website, we've got an indexed listing over the internet of IoT devices that have been scanned. Now this can be used naturally for nefarious purposes. The last thing we want is our IoT devices showing up here. So for example, here on the Shodan website, I'm going to start by clicking Explore, and perhaps maybe I'll scroll down and we'll click on the keyword default, looking for items that have default configurations. So as we scroll down through here, we get a listing of things like IP addresses. We have a sense of where these devices are, such as in the United States, or Toronto, Canada, or Taipei, Taiwan. And as we go through these things, we can see some of the default settings that might actually be in use on these items. Now, this is a problem because the bad guys out on the internet certainly are doing this and many other nefarious tasks to discover devices that might be easy to compromise. And so it's important then that we either research IoT devices before we put them on our network and only use ones that can be secured, or ones that can be partially secured, we might place them on an isolated network segment so that if they do get compromised, then those compromised devices don't have access to other important devices on that same network segment. IoT, or Internet of Things devices, are those that can communicate over the internet. And printers are included in that, including things like baby monitors, video surveillance systems, building environmental control systems that might even manifest themselves as an app that you can conveniently use on your smartphone to remotely control these things. So in this example, I've used the Nmap graphical front-end tool called ZenMap to scan a range of IP addresses on my network. Now I can also, after the scan is completed, click on Services to look at the different services that were detected, like HTTP web servers, and also network printers. Here's JetDirect. I see here that port 9100, TCP 9100, is open on 192.168.0.8. And if I look at HTTP for web servers, it's also open on port 80 on that device. So that's telling me that I've got a web interface configuration utility for that network printer. Okay, we're going to connect to that IP address in a web browser. So here in my web browser, I've entered the IP address of that embedded web server for that network printer. Now, depending on the configuration of the device and the specific model will determine whether you are asked for credentials out of the box or not. And one of the problems with many IoT devices is that security takes a back seat to convenience. And so, as a result, by default, security configurations might not be as secure as they could be. Not only that, but if we do have a username and password, we want to make sure we change it from the default. So here in my HP JetDirect printer, I'm going to start by going to Settings, where if I go down under Security, I can go to Password Settings. Now when I click OK, it redirects me over HTTPS, which is good. And it will prompt me if there are any credentials required to access this secured part of the site. That's a good thing. Now I don't want to save any passwords, so I'm going to choose Never. And this is where I could specify not a different username, unfortunately, but I can change the password to something different. Now you can use your favorite search engine to quickly come up with numerous default password lists, as I've done here. And as I go down through this list, I can see a lot of the different manufacturers' models. Let's just go back up so we can see the column headings for a moment. And we can also see the default username and password. And this is why it's so absolutely critical that this stuff be changed. And not only that, use a complex password. Now, knowing that it's that easy, it's important then to make sure we set the password to something other than the default. Now here on this particular embedded website for this network printer, if I go to Network, I'll also have some network security options. For example, if I go down under Advanced Settings, and if I scroll down, I can take a look at a lot of these different protocols that are supported by the device and determine whether or not they are enabled or disabled. The key here is only enable what you absolutely need. If I were to keep some things enabled that I'm not using, then it's just increasing the attack surface. So we would go ahead and do that and apply the settings. But at the same time, I'm going to go here to HTTPS redirection. It's not a bad idea to force everything to be redirected to HTTPS. Because if we allow connectivity over HTTP, we don't have encrypted communications. And anyone that happens to be on the network that's able to capture that traffic will see what we're doing. So this is always a good idea. So once we've gone and made a lot of these secure settings for this device, we would click Apply. And then they will be in effect. With the increased usage of mobile devices like smartphones, chances are as an IS auditor that could fall into the scope of an IS audit. So mobile device access control is an important consideration then. However, the use of mobile devices, as ubiquitous as it may currently be, does introduce some security risks, such as with BYOD, bring your own device, whereby employees are allowed to use their own devices to conduct business. But with that comes risk because the IT department doesn't have full control of that device. It's the users. The other thing to consider then is the use of a centralized solution for mobile devices, an MDM, a mobile device management tool. This way we have a centralized way inventory and manage mobile devices in accordance with organizational security policies, and also to get lists of compliant devices versus those that do not comply with organizational security policies. Examples of this would include Microsoft System Center Configuration Manager, SCCM, in conjunction with Microsoft Intune in the cloud. Intune is really good at registering and managing mobile devices, and that information can be made available in SCCM. With mobile devices, we have to consider what networks they have access to and how they are treated on those networks, such as whether a captive portal is used. A captive portal is something that you've probably interacted with, although you may not know the name of it. A captive portal is just a web page that you need to interact with before you get network access. And you might see this in your local coffee shop when you sign into the Wi-Fi with your smartphone. Before you actually get internet access, you might have to agree to terms and conditions. Or in the case of a more restricted environment like a hotel, you might have to have a user ID or a username and password. And we're not talking here about the Wi-Fi password. We're talking about after that. We're talking about before you get access to the internet. And often it's done through a web page. So this is a great way to secure networks that might contain untrusted devices like mobile devices, like smartphones or tablets. The other thing to consider is the use of PKI certificates. PKI certificates are issued by a certificate authority, and they can be unique, for example, for each individual smartphone. So this can be used to authenticate the device, to establish a level of trust on the network, to say, yes, we trust this device. And it could also include, in addition to device authentication through the PKI certificate, we might still have to authenticate with our username and password before gaining access to the network. Another aspect of dealing with mobile devices and what they can reach out on the network is by placing mobile devices on a separate network. Through network isolation, we have more control in this example, because imagine that we've got a medical clinic where patients have the ability to connect to free Wi-Fi as they wait for their appointment. Well, that, of course, should not be on the same network where the medical clinic will store sensitive patient information. It should be a separate network, hence network isolation. That might be called a guest network that would perhaps only allow outbound access to the internet and nothing more. Then we have to think about things like whitelisting based on MAC addresses. The MAC address is a unique address burned into a card in a device, like a Bluetooth card or a Wi-Fi card. And so what we could do is make lists of which MAC addresses are allowed to connect, for example, to a wireless network. That's called MAC address filtering. However, the thing to bear in mind is that MAC addresses themselves can easily be forged or spoofed using freely available tools. And also, using MAC address whitelisting, such as with a Wi-Fi network, it just really isn't feasible on a large network. The other thing is configuring mobile device settings to lock them down or to harden them, ideally using a centralized mobile device management tool. You might do things like turn off the microphone and camera on the device for privacy reasons, or maybe disable GPS, again for privacy reasons perhaps, and enable device encryption and remote wipe capabilities. Of course, whether these things are done and other settings really depends on the unique requirements of a specific organization or of a set of users within the organization. Other things to consider is the scheduled malware engine and definition updates on mobile devices. Mobile devices are computers. A smartphone is a computer, and so it should be treated as you would treat a desktop computer or a laptop, such as having anti-malware solutions and scheduled malware scans. Mobile devices that are used for corporate use should also have a restricted or limited set of apps that can be installed. Maybe even users don't have the ability to install apps at all. We might also use a mobile device management solution to push out settings related to password and authentication, where we might require long passwords, or maybe finger scans and so on. We should also have an inventory of mobile devices. If you don't know what's on the network, then it's hard to protect the network. So we should have an inventory of the types of devices, so the hardware, whether we've got iPhones, Android devices, Windows phones, and so on, but also the software installed on them. Because sometimes all it takes is a single device on a network with vulnerable software to compromise the entire network. The other thing is to think about mobile device partitioning, especially with BYOD, bring your own device to work, whereby we could have a corporate partition that would contain organizational related apps, settings, and data. But then we'd have a personal partition that has user apps that they decide they want to run, user settings for those apps, and user data. So by doing this, we have an easy way to remotely and selectively wipe the device if it's been lost or stolen, to prevent a malicious user from perhaps finding sensitive data on the stolen or lost device, or for using the device to access a secure. There are some cases where you might need to check the individual mobile device settings, such as devices that maybe don't connect often to the network that might be out of date with settings. You want to make sure the settings are compliant with organizational policies. One way to do that with Android devices is to go into your settings. I'm already in the settings on this device, but you can swipe down from the top of the screen and click the cog to get into the settings on the mobile platform. So if I scroll down here, we can see that Bluetooth is disabled. Essentially, anything that isn't required for job tasks should not be enabled on the smartphone. If I go further down, I'll see I've got location turned off. So the GPS tracking of this device is not enabled, but depending on the apps you're using, you might need it. For example, if you're using the Uber app to get around while you travel for work instead of paying for taxis, you're going to need to turn on location services if you want the app to determine where you are, which means you only have to specify your destination to make things a bit easier. When you're conducting an IS audit, you might have to come in and check an individual device settings if it's not getting them from a central configuration. If I go into security, we have a number of security options for the phone, like screen lock, which is currently set to a PIN. Now, if I select that, I can enter my current PIN for this device and then change it if I wish, maybe to a password or to some kind of a swipe gesture to unlock the phone. I'm going to go back, and then we can look at the encrypt phone option. You can choose to encrypt the contents of the phone, so when the phone is powered on and you authenticate successfully, in our case through a PIN, then it decrypts the contents of the phone. But if you can't authenticate, such as if you forget the PIN, then you have a problem, because you won't be able to decrypt the phone. So one option is to perform a factory reset of the device, but what that does is wipe everything out. But another thing to consider, and it depends how the device is configured, if it's syncing data to the cloud, like contacts or email messages or anything like that, you might want to check in the cloud to make sure that you have a version of the files or the content that is not encrypted. Further down, I can determine if passwords should be visible. We can turn that off so that if someone happens to be watching you as you're entering a password, we don't want the characters to appear on the mobile device screen. So we've got a number of options available then to check whether security is configured on a mobile device in accordance with organizational security policies. One thing that you might have to check in some IS audits as it might relate to the management of mobile devices is policies or configuration items that set a standard security baseline that's applied to mobile devices. So in a larger organization, there's going to be a centralized way to do this. And in this example, we're looking at Microsoft System Center Configuration Manager, otherwise called SCCM. Here in the SCCM console, I'm going to start by going to the Assets and Compliance workspace in the bottom left. And then on the left, I'm going to go down under Compliance Settings, and I'm going to choose Configuration Items, where I'll then right-click on that and choose Create Configuration Items. What I'm interested in doing here is locking down Android devices. So I'm going to put Lock Down Android Devices as the name of this configuration item. And down below, I'm very interested in selecting Android and Samsung as the settings type. Then I'm going to click Next. So it's got Android selected. I could expand that and choose the specific variation. Now, if you've got an older listing for Android operating system versions, it's because the tool you're using is a little bit out of date. So it's always important to apply updates to management tools to get the latest config settings. I'm going to leave them all checked on, and I'll click Next. I'm interested in password, security, and encryption. So I'm going to turn on those check marks, and then over the next few pages of the wizard, they will relate to what I've just turned on here. So if I click Next, we're looking at password settings. So require password settings on devices. Yes, we require password settings. Minimum password length, if we're using passwords on mobile devices, let's say is 10 characters. Password expiration, let's say, is every 60 days. I would do this in accordance with organizational security policies. Of course, as an IS auditor, we would check that these are set in an acceptable way in accordance with policies. So we could go through and specify all of the details related for this. So I'm going to choose, let's say, alphanumeric with symbols for password quality or complexity. And notice here we've got remediate non-compliant settings for devices that are affected by this configuration item. So I'm going to click Next. Next thing is we've got security. So maybe we're going to prohibit the use of the camera on company smartphones because it's not required for job tasks. And maybe we'll disable YouTube and so on. So we can go and do that. And again, notice remediate non-compliant settings is checked on down here at the bottom. For encryption, file encryption on the device, I'm going to turn it on. And then I'll click Next. So at this point, I'm going to go through and complete the wizard by accepting the rest of the defaults. After which I will have what's called a configuration item. Now the way that SCCM works is once you've got a configuration item, which we do here to lock down Android devices, you need to add it and perhaps any other configuration items that might apply to a configuration baseline. Because if I right click on that configuration item, unfortunately I don't have the option here in the context menu of deploying it to a collection of mobile devices. So it will never be in effect. Well, we're going to change that. So I'm going to right click on configuration baselines and I'll choose create configuration baseline. This is going to be for Android devices. And down below, I'm going to click add to add a configuration item. And it's going to be the lockdown Android devices configuration item. So once I've done that, I'll click OK. Now I've got a configuration baseline, if we switch over to that view, called Android devices. What I now need to do is right click on it and deploy it. Deploy it to what, you might ask? Well, I have to deal with the collection. The collection is like a group of devices that will be affected by these settings. If I click browse, I can do it based on the user or based on the device. So in this case, I'll choose device collections and I'll choose, let's say, all mobile devices and OK. Now, the other thing to bear in mind here is to remediate non-compliant rules when supported. So I'm going to go ahead and turn that on, and I'll click OK. So at this point, if I look at my Android devices configuration baseline down at the bottom, if I click on deployments, we can see it's been deployed to the all mobile devices collection. So sometimes, depending on your environment, it can take up to an hour or sometimes even more before devices realize these configuration changes are in place and before they are put into effect. Chances are, most modern-day IS audits will in some way involve mobile devices. Our twist on that topic is really going to be the apps on mobile devices. First thing to bear in mind is that there have been many reported cases in the media of malicious apps being available in major vendor app stores and then being installed on, in some cases, millions of devices until it's known that the app is malicious. Now, most major vendors take a lot of steps to ensure that this doesn't happen, but as is always the case with technological solutions, nothing is 100% foolproof. So the resulting behavior of this type of malicious software that's been available in app stores has been things like personally identifiable information or PI leakage, in other words, sensitive data disclosure, and the unleashing of malware on those mobile devices, such as banking malware and even other nasty variants like ransomware. So what can we do to mitigate this? Well, if you're using the Android platform, one option is to leave the Google Play Protect option enabled. This is built into the Android OS. You can actually find it if you have an Android phone by going into the Google Play app and tapping on the menu, and then you'll see a Play Protect option. Now that's on by default, and what it does is it makes sure that all of the apps installed on your device are safe and not known to be malicious, even old apps installed in the past. Certainly it also applies to new apps that you're about to install from the Google Play Store. So each platform has something similar that will look for malicious apps on the mobile device that are already there or that you're about to install. The other thing to bear in mind is code signing certificates. This is on the App Store side. The app stores will normally require developers to have a code signing certificate to digitally sign apps before they're allowed to be uploaded to an app store. There are other safety checks as well. Now, this digitally signed app or software is done with a certificate issued by the App Store vendor, and so it's trusted by the App Store vendor. The other thing is that many vendors are now offering bug bounties for anyone that can uncover previously unknown flaws or vulnerabilities in their software. And so that's a great incentive in the overall IT community around the world globally to make sure that apps are safe. The other thing to think about is the major vendor app stores, so Google Play Store, Apple App Store, or the Microsoft Store, whether or not those should even be accessible by users. Do we want to allow users that are using their smartphones, for instance, for business use to be able to install whatever they want, even from these vendor app stores? Another option is to use an enterprise-controlled app store that would contain only corporate-approved apps and nothing else. The cool thing about this is it can be configured such that admin approval is required before an app installation is allowed. That could be done for all or some of the corporate apps in the corporate app store, the enterprise app store. and so users can have the option to request those apps. The other thing to bear in mind is whether or not proper auditing techniques have been in use for mobile devices and their applications. So for example, App Store usage and whether signed apps are the ones that are being used on the mobile device. Whether the mobile device has Bluetooth or GPS, near-field communication, NFC, or the camera turned off if it's not needed. That would be in accordance with organizational security policy. And that can also be centrally managed and reported upon using some kind of a mobile device management or MDM solution. The other thing to think about is the permissions that apps have. So most users are unaware that when an app installs and asks for all these permissions, it might not actually need them all for the functionality required by that user from that app. Of course, mobile devices should have anti-malware just like a standard desktop computer should. They should have a personal firewall to limit inbound and outbound traffic. They should have patches applied and remote wipe options enabled so that if the device is lost or stolen, it can be wiped out, thereby making apps or sensitive data unavailable to whoever has the phone in their possession at the time. The other thing, of course, is to encrypt data at rest, for example, by encrypting everything on the phone and also any micro SD cards that might be inserted in the phone, and also data in transit. Now that's really more dependent on the apps and how they communicate over the network. But the idea is there are a lot of things that we need to check in a modern day IS audit that might be related to mobile devices and apps. In this exercise, you're going to start by explaining why OSI Layer 7 security solutions provide more options than Layer 3 security solutions. So think, for example, of a Layer 7 versus a Layer 3 firewall solution. Next, you'll provide mitigation recommendations against Linux rainbow attacks. Then you will list 5 examples of common IoT devices, and finally you'll describe how mobile devices can be hardened. At this point, pause the video and think about each of these items in the context of an IS audit, and then come back to view the solutions. The OSI model is a 7-layer conceptual model that's used to explain communications hardware and software. Layer 3 is called the network layer. Now, anything that is firewall-based that relates to Layer 3 will be able to look at things like source and destination MAC addresses, which are actually Layer 2 addresses, and also IP addresses, which are certainly Layer 3 addresses. Layer 7 is higher in the OSI model. This is the application layer. And so it has a lot more capabilities to dig down deep into the contents or the payload, the data portion of a packet. So it has the ability to parse all of the packet data. Rainbow attack mitigations can come in many different forms. Remember that a rainbow attack is a pre-computed list of password hashes along with the plaintext password that gets compared against stolen hashes to see if there's a match. And so one way to make sure we mitigate against that is to use a strong hashing algorithm. MD5, Message Digest 5, is not considered a strong hashing algorithm. Instead, we should be using something like SHA-256. Secure hashing algorithm is what SHA stands for. The other thing is to use complex passwords for the root account. We should really be using complex passwords for all accounts. The root account is the super admin account in the Linux environment. And of course, we should apply standard host and network hardening techniques to make sure the machine is not susceptible to attacks whereby malicious users could gain access to password hashes in the first place. IoT, or Internet of Things devices, are those types of common modern devices that communicate over the internet. Things like wireless video surveillance cameras or baby monitors, or even things like home and business environmental controls for heat or lighting or air conditioning and ventilation. On the medical side, even IoT devices related to things like blood pressure monitors, and of course at the standard transport level, we've got smart cars that can communicate over the internet for a variety of reasons. For example, to track the location of the car for safety purposes, which could also be used for nefarious purposes. Mobile device hardening comes in many different flavors. One option, if not required, is to disable things that aren't needed, like Bluetooth. to limit Wi-Fi network connectivity, for example, to only allow users of a smartphone to connect to predefined Wi-Fi networks. Disabling public app store access to prevent users from installing apps, or perhaps to prevent them from installing apps from that app store, but maybe instead from an enterprise-controlled app store. Having up-to-date anti-malware running on a mobile device and a firewall app, and of course, applying all updates. The other thing to think about is isolating mobile devices on separate networks. This could mean, for example, that you have a separate network, a guest network as it's often called, configured that allows mobile device connectivity, perhaps only to gain access to the internet, and that network would be kept separate from other networks where sensitive servers reside.